Good morning, everyone. Good morning. So my name is Thiago Rodrigues. I'm the CEO of the Wireless Broadband Alliance. So welcome to Paris. Welcome to the Wireless Global Congress. I want to spend just a few minutes on my presentation to talk about the Wireless Broadband Alliance, a little bit about the work of the organization, so that you can understand our evolution and the activities that my team has been developing. Just a note on the health and safety from the event security, as well the Wi-Fi password in case you don't have, as well the app of the event. A big thank you to all the sponsors of the event for supporting us and making this event possible. And this is the agenda for the day. But I want to jump into my presentation. So 2025 for the Wireless Broadband Alliance has been a really fantastic year. I'm super proud of the team and all the members that have contributed to the activities. We had a record of revenues, so all of you that joined WBI that contribute, thank you for that. We deliver more than 20 technical projects throughout 2025. Our membership is growing. Open roaming, one of our most visible technical programs, continues to grow quite exponentially. And as well on the marketing and on our events, we see a significant growth, as you can see. That is very good to see, and we are very pleased to see that in the WBI. This is just a snapshot of all the members that joined so far in 2025 WBI. As you can see, it's a mix of operators, enterprises, even government agencies, municipalities, different solution providers have joined the organization. Is super positive. And on our program management office, like I said, more than 20 projects delivered. The number of companies participating and active, reaching almost 150 companies, putting resources, technical experts on the different programs. We have more than 70% of our members are quite active on the activities. And the number of participants on the programs have been growing from year to year. And just to give two examples, so one of the programs that we saw a lot of engagement is on the end-to-end Wi-Fi quality of service. Just as an example, we have been producing different documents on this area, either on L4S, but as well how to provide a better quality over Wi-Fi networks, what are the different components, the technical metrics that need to be monitored, that we can all benefit from a better Wi-Fi. Another very positive program has been our open roaming compliancy program. We have today more than 50 manufacturers of Wi-Fi equipment that has passed the testing, and they have developed products and services on top of the open roaming standards. But it's not only about technical programs. We do as well a lot of marketing. So our marketing group and our marketing team have been producing a substantial number of briefings to the media, press releases, promoting the work of the Alliance, many times promoting the work that many of you do in the WBI. You can see that we have more than 66 briefings to the media. We have as well almost 4,000 articles on the media from all different types of media outlets. So that visibility from the work that all of you developed is super positive, super proud of seeing the engagement from the media and the exposure of our programs. Good examples of that is, for example, the 6G group that provides a deliverable in the early of 2025. It got more than 1,000 media exposures in terms of articles, more than 500,000 exposure in terms of visibility, so very positive to see. And as well, Wi-Fi 7 trials has been another example of a very positive outreach to the media, and good to see the number of articles being written about the work that WBA has been doing. Same happening on the events like this today, the Wireless Global Congress, our partnership with Network X, being here and be exposed to either community. Our number of sponsors has been growing year after year. The number of attendees as well, many of you as speakers, good to have you on the agenda and exposure. Your product, services, case studies has been super positive for the agendas. As well, super important, our satisfaction rating from events has been growing. We reached 4.6 on a scale from 0 to 5. I've been talking with the team, it's always more challenging to increase and to improve when we already have a very high rate number. But I'm very satisfied with this rating, and thank you for giving value to our events and being part of them. I want to leave a message that if any of you are not still members of the Alliance, and if you believe that the work that we do is relevant, please consider to join, consider to be part of the organization. Stay along the way, learn more about what we do. We'll have fantastic presentations throughout the day, and will be awesome to have you as well on the membership. Before I finish, I want to bring one topic related with the WBA leadership. So we had a change on the top level leadership of WBA. So J.R. Wilson has been our chairman for more than 12 years in WBA. He was representing AT&T. So J.R. Wilson moved on from AT&T, and he stepped down from the role of chairman in the Alliance. And yesterday on our board meeting, we elect a new chairman. So Dr. Derek Patterson from Boingo Wireless, the CTO at Boingo, as well a long-term member of the board and supporter of WBA, was elected as the new chairman. And I would like to invite Derek to come on stage and introduce yourself as well. I think everyone knows you already,
I think so,
but it's good to to share your thoughts and views for the WBA.
Yep. Thanks, everyone. I was hoping I could see JR here too. Maybe he'll be here in a moment. You know, I'd like to thank JR for what he did. You know, we went through a lot of changes over the last 12 years with the WBA, and he did a great job guiding us through that. You know, we're an organization of collaboration to really just drive this connectivity forward. And I think many of you know it's kind of my passion. Connectivity is a huge passion of mine, so it's an honor to be able to be the chairman and work with all of you. I mean, all of us collectively have been collaborating for a lot of years to really drive this seamless connectivity forward. And I think, you know, with 6G, and I'm going to get into it in a presentation in a minute, but with 6G and with Wi-Fi 7 and 8 coming to fruition, we've got a lot of work to do. And so it's going to be a lot of fun to work together with your expertise and dedication and passion to really just keep making and driving our seamless, interoperable, secure connectivity forward. So thanks. And look forward to working with you.
And your participation is fundamental for our technical programs, to get your views, your insights that can shape the different technical work that is done in WBA.
Yeah. Good.
Okay. No,
I
please,
think I'm next.
You are next. You can stay. Thank you. Thank you, everyone. And I will leave you with next speaker, Dr. Derek Patterson. Thank you.
All right. Thank you. All right, so I decided to take a little bit of a change today in my presentation and talk about the converged. I mean, who's shocked that I'm going to talk about converged? No, I don't think anybody who's seen me speak is like going, oh, Derek's going to talk about convergence. And many of you know that probably is 20. You know, I came from cellular before I went to Boingo, and I realized that Wi-Fi was hard to connect to. And I was like, why is it? And we were a Wi-Fi company when I joined Boingo. You know, we were strictly Wi-Fi. We did DAS still. We've been doing it since '99, but we were more focused on the Wi-Fi, and I realized it wasn't converged as well as it needed to be. So that's why I joined the WBA years ago, was to push that forward. And here it is, I don't know, 12 or 14 years later, I'm still pushing, and I think it's important. It's a passion of mine to kind of keep pushing this forward. So I'm going to be talking about the next era of converged wireless. All right, so we've been talking about it for a long time together, and what we really are trying to make happen is all these networks should work together. You know, as a CTO for Boingo, when I go inside of a venue, and that's how I kind of think of them today, there's a lot going on inside venues today. Everything's moving digital, AI's everywhere. You know, you have to make sure that all those networks are secure, and you're bouncing back and forth between network technologies, and it's getting more and more complex. And so, you know, I used to always say 5G, you know, because it gets all the hype, was about trying to get networks to finally focus on use cases and the importance of going into a location and saying, what are we trying to do with the network? Instead of just saying, oh, I can build all these great wires and wireless access points and let everybody else figure it out. It was like, hey, in 5G, let's start talking about all the use cases, and it changed. For me, when we start thinking about 6G and Wi-Fi 7 and Wi-Fi 8, and now satellite and all the other new technologies that are coming in, it's now about recognizing how we can make it all work together. And so to me, that's really what we do in the WBA, is we go and we work with other organizations, we collaborate with them, and then we try to figure out how can we make those work together. How can I make it when you're on the private network and you move to a public network, whether it's Wi-Fi or cellular, that's a seamless transition, that all the use cases still work. And so how does it make sure that they work together? So around that, what we know is, because all this changing, these connectivity is so important, we have to figure out how to make this work better together. And so we need to look at our infrastructure no longer as separate silos of technologies, but actually as a use case that leads through that, right? And so when we work with a venue, whether it's, you know, a stadium or transportation, which we're known for, or you know, a hospital, it's recognizing the flow that's going through that location and how you're going to deal with it. There's the way you get there, and then there's parking, and then after parking you got to get into the venue, and there's some kind of a ticket in a lot of these situations. And then once you're in there, you got to create experiences that somebody enjoys, and all of these take different network technologies. There's no one network technology or one communication technologies that's solving it all, right? And that's the challenge, is how do you create that experience when you're bouncing across technologies? And so one of the ways we do this, and many of you know I also sit on the board of the OnGo Alliance, and one of the things that, you know, I remember 1996 when I was working in cellular and satellite, back when I first got out of the military, we were all the cellular systems, you'd lose your connection as you went from tower to tower. And you go to a different location, you lose your connection. And so what happened? 3GPP got together with GSMA, and they ended up creating roaming standards. And those roaming standards enable it so that when I travel to Paris from the US, or I was in Oman last week, and I can go place to place and I'm always connected, because there's a roaming standard for being able to connect everything. So the first thing we have to do is we have to figure out, how do you connect all these things together that are the heterogeneous networks. So GSMA did that, and if we go back to our history in the WBA, that's what we did. I remember one of my first meetings was with you running the RICS group, and I was sitting there going, what is this RICS thing? And I had to learn about the RICS. And what the WBA was first started for was trying to figure out, well, if you've got 650 million, I think is the latest number I heard or something from Matt, hotspots around the world, how are you going to make it so you can connect to all of them? And so roaming becomes very important part of it. In the OnGo Alliance, we're not even talking about roaming yet. We're just trying to get it out, private networks, but they've got a challenge now too. How do you roam? So you go set up a private network and you need to roam from multiple private networks. If you want to join those together, and there's a big group of airports that's saying, hey, we're all going to launch our own private network for planes to be able to have a private network that's secure for them to connect to. How do I make sure that that works across all the different airports? Well, you've got to start thinking about roaming. And so that's what the WBA has been focused on for a long time, was this idea that we're going to end up making this seamless connectivity across all Wi-Fi. And then we expanded it and we said, now it's going back and forth across Wi-Fi, across cellular, across satellite, across all these new technologies. How do we do that? And that's a very important part of what we're working on today with open roaming. And it's a very important part of what we all still need to collaborate on, because it's still not functioning perfectly, right? We all got a lot of work to do to keep moving that forward. And as we look forward then to the future and this ubiquitous connectivity across all these things, we know that roaming protocols are going to have to change, right? So we're going to add in satellite, we're going to add in IoT devices, we're going to add in some new technologies along the way, AI capabilities, new connected devices, whether it's watches and cameras and glasses and all these new things. And along the way, we've also got to recognize that we've got a group that's focused on AI ML, because there's a new emerging technologies that are going to help us do this better. So the WBA's got an AI group that's taking in these new capabilities with AI and being able to drive those into the ecosystem to be able to make roaming and seamless interoperable connectivity work. And we're bringing in satellite. We have several satellite members now inside the group, and we're getting more satellites people in our group. We've got, of course, got our 6 converged cellular groups and all of our Wi-Fi people. So bringing it all together and then trying to figure out how we extend that coverage as we move back and forth. And I know Matt's going to come in after me and talk about probably vector, I'm hoping. And you're going to see the importance of being able to move from location to location and having that ubiquitous connected experience. So again, this is my call to everybody as kind of the chairman, but also as Boingo and also as the guy who's passionate about this, right, is we get a chance to define 6G. We are all defining what it's going to be. We at the WBA, we grew from, I don't know, a few years ago, we were below 100 members. We're well over 200, approaching 250, and I think we're going to continue to grow. Steve's doing a great job doing that. But as we continue to grow, we now have a voice. We're a group of individuals who have come together, who recognize this idea that we need connectivity for everything. The world needs it. We live in a crazy world where communication is going to be the only way that we're going to end up building a better world for our children and our children's children, is by being able to enable communication in better ways. And connectivity is essential for that. If you don't have connectivity, there's no communication happening. And so we need to make sure that we recognize the responsibility we kind of all have to be able to drive that forward. And I think with the collaborative voices in this room, the work groups that we're doing, we are going to be able to recognize what 6G really should be, which is connectivity ubiquitous across all these technologies that we've been working on and developing over the last few years in the WBA. And it shows by our membership, and it shows by the passion that I see from all of you when I talk to you every day, or some of you weekly, and some of you when I just come to these meetings, but it's great to be able to talk to you about that. All right, I got one last thing. I know I'm probably out of time. I want to give an example, because a lot of times you need examples to kind of drive it home. So, you know, you could probably see our marketing team shared yesterday our Port Authority. We've been working for the Port Authority, which is New York, New Jersey, trains, all the airports, all the key locations there. We've been working with them since 1999, trying to figure out how to bring connectivity to all those locations. To give you an idea of scale, 60 million people go through JFK every year. 50 million people through New York. The tunnel that was just built from Long Island into Penn Station, 50 million people go through that tunnel underneath the Hudson every year. A lot of people, a lot of different needs that they need for connectivity, whether it's calling their spouse, telling them that they've arrived, or it's checking on their kids, or it's checking on their work. They need that connectivity. And then once they get there, those locations need to be safe and secure, so there's cameras that need to be connected. There's tickets that are being processed that used to be processed with pieces of paper that are now being processed with facial recognition and other kinds of bio recognition capabilities. And all of that is being done across multiple technologies, across multiple connected technologies. We're running Wi-Fi networks, of course, through there. DAS, the DAS networks through there, private networks through there, IoT networks, badging capability networks. There's all these networks running, and they all have to work and then be able to go back to a single pane of glass so that my NOC team can end up being able to make sure all those things are working across all those technologies. And today, the way we had to do it is we had to build a venue management dashboard that pulls in all of these different technologies and all these different KPIs so that we can make sure that there's a quality service across all these hundreds of use cases that are going on across these transportation systems. It has been a challenge, but it's getting easier, right? Because of these technology advancements, because of the collaboration work that we're doing, so that when the handoff between the Wi-Fi and the cellular is working better, the handoff between the Wi-Fi and the Wi-Fi access point is finally working better. All those things are essential to being able to drive this connected vision. And it's exciting as the CTO for Boingo, and now also working with you as the chairman for the WBA, to really continue to drive this vision home, where ubiquitous, seamless, interoperable connection across all these technologies work. So with that, that's my push. I think we have a lot to do across all these domains of security, interoperable, a lot of engineering, taking advantage of AI. We're doing it in the WBA. It's exciting to see. And that's my call to everybody. Let's go build this together. We've had fun for the last 12 years that I've been doing this with you. I'm looking forward to many more years, hopefully, of doing this with you. I'm excited to be here and with all of you here today. So thanks. And with that, I appreciate your time.
Yeah, before you go, any questions for Derek from anyone?
You can always rely on Dean. Nobody?
Oh, there is one. Oh, over there.
Yeah, please.
I wouldn't want you to go completely unquestioned.
Thanks.
But, I'm interested when you were talking about your projects in the Port Authority and whatnot, and IoT devices. And perhaps this rests more in the residential area, but it's also in agriculture and whatnot. The non-IP type of connectivity, the lower ends, the Zigbees, the Z-Waves, which proliferate in the IoT world. We just finished a comprehensive white paper on how these crash together in the multi-dwelling unit thing. Where is that in the more industrial side of things that you guys are involved in?
Yeah, I mean, we're definitely releasing a lot. We've played around with a lot of LoRa WAN connections, so we have some of that out there. You know, the challenge is with Bluetooth, LoRa WAN, Halo now, all these different technologies. There's a lot of different technologies you can kind of bring to bear. You know, I remember when we were working in San Diego, Apple tags were like huge, and it was like, okay, we put up this huge tag capability across the airport in San Diego. I think that the challenge we've always had with all of these things is there hasn't been, and then maybe that's something we can take up, you know, we have opportunities. There hasn't been a single way to do it yet. And so it's very diversified. And so what we've found, you know, personally as the CTO for Boingo, who's helped different venues try to solve this, what we found is we've kind of go into each scenario trying to figure out which one of these technologies to bring in. And then we have to see how rich the API set is to be able to try to meld it in instead of it being pushed in from the start. And I think that there's work for us to do that. I'm hopeful for Halo. I think it was probably 10 years ago I sat at a Wi-Fi Alliance thing, and I remember the Orange guys were bugging me going, why are you pushing Halo? And I go, because at least it's in the Wi-Fi stack still. And so it's part of the Wi-Fi stack, and it solves some of these connectivity problems for these IoT devices. So I think that there's opportunity there. I know we're working on headless device stuff in some of the work groups for authentication and security. So I think there's a lot of work to do. I would agree with you. Still a lot of work to do there. It's something that I think the WBA can definitely push forward. So I'm hoping we do.
Yeah.
Hopefully that answered your question from my perspective. Did you want to add anything to that?
Yeah. No, I think we went there well. Any other questions to Derek? Okay.
Okay.
Thank you.
Thank you.
Thank you. Okay, and now from New York City Port Authority, we move to Japan, more precisely to Tokyo City. Next speaker is Mr. Manadu Komiya, Chief Section Digital Services at the Tokyo Metropolitan Government, and he's going to present the vision for Smart City Tokyo infrastructure plans. So, Mr. Manadu, welcome. Thank you.
First of all, on behalf of the Tokyo Metropolitan Government, I'd like to express my gratitude. I'm Manabu Komiya, the Wi-Fi Section Director at the Digital Service Bureau in Tokyo Metropolitan Government. Today, we are honored to have the opportunity to speak at the Wireless Global Congress EMEA about our open roaming Wi-Fi initiatives. We appreciate to Tiago-san and everyone at WBA for their kindness. We focus on the safety and seamless connectivity of open roaming, and we are working on the installation in public facilities and promoting wireless in the private companies. Thank you, Tiago-san and Bruno-san, for visiting the TMZ on January in this year. From then on, the collaboration between the TMZ and WBA began. Now, I'd like to explain Tokyo Data Highway, the telephone infrastructure for Smart Tokyo. Digital transformation is the key for people's quality of life and the competitiveness of city. For realizing the Tokyo vision of Society 5.0 Smart Tokyo. The metropolitan government will advance the Tokyo Data Highway, telecom infrastructure, as well as road and railways, etc. Smart Tokyo aims to enable Tokyo residents to lead a high-quality life through the digital technology and the quality of service in fields such as digital prevention, education, and industry, etc. The basic infrastructure to realize Smart Tokyo is Tokyo Data Highway, which is a road for radio waves, such as Wi-Fi and 5G. We will accelerate the constitution of high-speed internet networks to build a data highway and realize a connected Tokyo that connects anyone, anywhere, anytime, in any situation, by a strategy and a 3-year action plan. Utilizing multiple communication methods, a 3-level network of optical fiber, such as submarine cables, mobile internet, such as Wi-Fi and 5G, and satellite communications, enable secure connections. Since March 2023, the TMZ has been developing open roaming at Tokyo facility that many people use daily and during disaster, and at facilities inbound tourist visit. Open roaming is currently available at 859 TMZ facilities, with the aim of expanding to 1,000 facilities by fiscal year 2025, and municipal subsidies are used for 175 facilities. We aim to expand to 7,000 facilities by fiscal year 2026. In Tokyo, the number of access has grown rapidly to 21,350,000. In February 2027, approx 100 times compared to October 2023. In addition to the TMZ facilities, over the next 3 years, we will install open roaming Wi-Fi in approx 1,800 facilities, using telephone booths and other things as assets in outdoor areas where many people gather. Specifically around major train stations and parks where many tourists visit. TMZ will enhance the convenience of tourism and upgrade the communication environment of open roaming Wi-Fi, which can be effectively use during disaster and further enhance its presence as international city. We would like to collaborate with WBA and major cities such as London, Dublin, New York, and Paris to make open roaming Wi-Fi available globally. TMZ and NTT East Japan signed an agreement on August 27, 2025 to install Wi-Fi in approx 1,500 telephone booths over 3 years. This year, we will develop it around the station of Yamanote Line, which is the most used railway in Tokyo, and in parks operated by the TMZ. Please pay attention to the sticker. You can use open roaming Wi-Fi around here. It's sticker, green and white green sticker. The governor of Tokyo and telecom CEOs gather together every year to discuss the realization of Tokyo Data Highway. In October 2024, we held the 5th Tokyo Data Highway Summit under the theme of Capital City Defense from Disasters. This concludes my explanation. Thank you all for listening. Next January, WGC APAC 2026 will be in Tokyo. Please come and visit us. We look forward to see you and expanding open roaming Wi-Fi together. Thank you very much.
Thank you, Manadu-san, for the presentation. I would like to make one question. So you present the graphic that since 2003, the usage of open roaming, your Wi-Fi networks with open roaming, they grew up 100 times. So why you see this? What are the reasons for this to happen? It's a very substantial growth.
Thank you. I think this is because TMZ is developing facilities that take Tokyo residents and foreign tourists to use open roaming Wi-Fi conveniently. Monthly open roaming usage is increasing in proportion to the number of facilities that have Wi-Fi in place. In addition, we believe that where open roaming Wi-Fi available and TMZ put the sticker this is, user can know it about it.
Yeah, so promotion plays a big role on that growth of the usage. One more question from my side. So fantastic to see the collaboration for the 1500 phone booth with NTT East. I know that many other cities like New York and London and others, they use as well Wi-Fi on the phone booth. Any thoughts and ideas, how can we create a global movement for all these municipalities to collaborate?
Yes. At the Earliest, we hope to be able to use it from the end of November this year. At the end of January, when the WGC APAC 2026 held in Tokyo, there will be more and more places where open roaming Wi-Fi can be used at phone booths around the major station. And please look forward to open roaming Wi-Fi in the phone booth. Tiago-san and everyone at the Avenue, please come to Tokyo. Thank you.
Thank you. Thank you.
Thank you very much.
Thank you. Okay, moving on the agenda. I would like to invite Matt McPherson, Wireless CTO at Cisco, to talk about wireless fusion and in a connected world. So Matt, once more, welcome.
Okay, am I on? Is it working? Okay. Good, well, it's great to be in Paris. I'll have to say, I really enjoy coming to France. We had the board dinner last night, and I think I probably had one of the best meals I've had, well, in a long time. I don't know what it is about the French, but they can cook. I'll say that. So, and I'm very excited about what we just saw. I mean, we've been working on open roaming now for about 5 years in the WBA. We're seeing entire cities now lighting up and offering services, and we're starting to see some of the real benefit in Tokyo and many other locations as well. I was talking to Tiago earlier today, and I was saying, well, how many open roaming implementations do we have? How many access points are actually doing it? And there's so many signing up now that we've lost track. It's several million different networks have signed up. So it's really exciting to see, and it's exciting to see some of the benefits. So wireless fusion. So I'm going to disappoint Derek a little bit, because the last couple of times I talked about vector roaming, but so vector roaming is a brand new technology, and I am going to touch on it just a little bit as part of what we need to do in order to do convergence. Now, Derek and I didn't coordinate on this, but I'm going to talk a little bit about convergence too, because I'm so excited about some of the projects and the things that we're doing here at the WBA. So who are the players? Who are the key players? Who are we trying to work with? Who are we trying to converge? So when we think about convergence, we think about different access technologies, but there's got to be an outcome, and there's got to be motive to doing it. And so what we find here at the WBA is that we have these different constituents. Talk a little bit about enterprise. Why is the network important to enterprise? Because, in the enterprise, it's a cost center. You know why? Because it drives productivity. Productivity drives innovation. Innovation drives profitability. So they're willing to spend the money in these networks. Have you been in an office building that hasn't had Wi-Fi? All of them are doing it, and all of them are benefiting from it. So what's the service provider want? The service provider wants to provide networks towards that productivity that can be monetized as a service. And so we see these different services. Now, both the enterprise and the indoor space, we're seeing whole new sets of services. In fact, Eric had a question on this I'll get into a little bit. And the service providers are adding additional sets of services. Now, what do regulators want? Because you know what this all built on? It's all built on spectrum. So what do the regulators want? They want to be able to better digitize their country so that they can be competitive in the worldplace. Right? That's what regulators want. And so we're going to have to leverage these multiple technologies to achieve that. So what's the best way to do it? And what do users want? They want the network to improve the way they work, live, play, and learn. It is now a part of everything that they do. So you take the network down, and what happens? You get withdrawal. So connectivity is a multiplier. We've known this for a long time. And certain segments of the industry are completely dependent on it. So what happens when you're sitting at work and the network goes down? I should say, what happens when you're using a competitor's network and it goes to... You go get a cup of coffee, everything stops. You know what's funny? At my house, I have all the network on UPS, so I can completely lose power. I don't have lights, but I still have the network because I need the network for productivity. I'm still working. So the network has become a major component of this. Now, so what are the customers telling us? So in the last two Cisco Lives, the Cisco Live that we had over in Europe, the Cisco Live that we just had over in the US, we asked customers, what's most important to you? And so when we look at the several different outcomes that networks provide and how we use them, this is what they told us. Now, you might be surprised because we're hearing all this information about AI, and I'm talking about AI in just a minute, but what we find is that really it's these two things. So when we talk to IT departments, we talk to the workplace, they want the network to be deterministic, they want it to be predictable, and they want it to be reliable. Now this, you don't have to go too far back in time when that wasn't the case. Remember when Wi-Fi was a cool technology so that you could go use your laptop on your back deck? But if you really needed to get work done, what did you do? You had to go back to your desk. Now we're installing whole systems, whole businesses, that the only connectivity that they have is Wi-Fi. So they want this to be predictable and reliable. Now the next one is this simplicity. Well, how are we handling simplicity? Because RF is kind of a complex thing. And we deploy some really big networks. Sometimes we're not talking about tens of APs, we're talking about hundreds of APs, thousands of APs, tens of thousands of APs. We have customers that have over 100,000 APs. These things can become complex. And so what's the answer to that? We're applying AI. Now AI is really good when it comes to analyzing RF. And so we're starting to see these technologies optimize the network based on the current demand. So this is a big shift than what we've done before. Now what we find is that there's a dependency between these two, because as we become simple, that doesn't mean we become less capable. And we're still going after this deterministic, predictable, and reliable. But you know what we're doing? We're now using AI to achieve it, because we are now in the wireless first world. That's how we connect. That's how we connect people. That's how we connect things. So I know this has got a lot of fine print. Don't read any of this. You can get the slides afterwards. I wanted to have some of the different sectors, but what I wanted to do is just point you to this chart because it's interesting. What this chart shows is these are the different sectors, right? Different verticals that as a result of AI are going to have an increased requirement on connectivity. Isn't that interesting? We spend so many hours of a day connected to the network, and there's certain verticals where they're completely dependent on it. So for example, this is the growth rate. You can see it, right? So I'll talk about productivity in a second, but this connectivity uplift. So how many percentage points are we going to raise the demand on connectivity? So what you see is in information tech, well, actually it doesn't raise that much. You know why? Because information tech is already at 90% connectivity. So we don't see as much uplift there. But if we look at some of these other sectors, healthcare, manufacturing, retail, education, now we're getting into some pretty big numbers where we're now expecting for productivity in these other verticals to be connected all the time. So this dependency doesn't mean just Wi-Fi. This means 5G. This means Wi-Fi. And someone brought up earlier some of these IoT technologies. We have to work together because productivity is dependent on it. It's dependent on the connectivity no matter what you do. And when you get a chance to read some of this fine print, it's even interesting because it's hidden in these areas like construction and field work. Look at the 20% more connectivity to do that job where the guy used to go out there and he used to lift bricks and stack them. Now what he's doing is he's using AI to not only better implement it, but there's checks going on because they're using robots to check the work, to check what's going on. So all of this uplift coming from AI, setting that next expectation. And if you've read some of the papers out there, this line here in these different sectors shows the increase in productivity because of AI. So when you start talking about productivity uplift in the 10 to 20%, those are big numbers. Those are big numbers. If you can increase productivity in your particular sector by 10 to 20%, that is something that's otherwise very difficult to do. AI is going to do it, but you know what? You can't do it if you can't connect to it. And that's what we're doing with these networks, and that's why we have to converge them across the board. Now, this is an interesting chart. If you're talking about doing work on Wi-Fi, this is the average time that people spend on the network and the different technology that they use. So you can see here a general adult is spending almost 3 hours on Wi-Fi, right? And again, these are averages. And you can see here the work on cellular, and way down here, these are the cabled connections we all used to love, connect to, even cable our houses with. But look at this knowledge worker, right? This knowledge worker is spending over 8 hours a day on the network. Now, if you look at this technology, what would you say is the more important access technology? And it's a trick question, because there isn't one that's more important. Because what we're doing is we're taking advantage of unlicensed technology and the fact that it's low power to get extreme reuse. In other words, we use the spectrum, we use the spectrum, we use the spectrum. The spectrum that is being used in here is being used right outside that wall again, because it's a low radius technology. So that's why we're getting these huge capacity capabilities that we're getting on an unlicensed, low range, low power technology. That's how we're doing it. That's why Wi-Fi can run on unlicensed, because guess what? If you start to increase that radius, what happens? You increase your interference domain. And if you increase your interference domain, what happens to an unlicensed technology? It starts to become unpredictable. And that's why we're applying AI. That's why we apply radio resource management. If you follow the Cisco literature, that's why we do AI RRM, so that we can optimize that experience. Now, the same thing, if you're doing cellular, that has to be licensed. Do you ever think about that? If cellular is going to go several kilometers, right? If that was an unlicensed technology, pi r squared, it's exponential. Do you know how much interference you're likely to get? So you're not going to get the same reuse factor, and you're not going to be able to do it unlicensed because interference will exist all the time. So when it comes to that ubiquitous coverage, we are completely and totally dependent on cellular networks. So what do we need to do? We need to converge these together. Now, I know another busy chart. Sorry about this. And every time I put up a busy chart, I don't know if Steve here, but Steve says, your charts are too busy. But I like providing a lot of information. So what happens indoors? So this is an example in the US. In the US, there's just over 5 million buildings. 5 million commercial buildings. Now what you see here, about 130,000 of them have over 100,000 square feet. So what is the domain of 100,000 square feet and above? This is where you apply DAS, this is where you apply small cell. But everything that's smaller than that, the economics don't work to put in 5G because Wi-Fi is already there. And it easily covers the smaller spaces. So 5 million over this 5,130,000 are actually the domain indoors of the dominant technology we know as Wi-Fi. And why is that? Well, some of you have seen the reports. You can see here, this is the cost of putting in a typical DAS system. I think the difference here, I'm showing kind of the minimum and the maximum being if you're putting in a multi-carrier implementation. Well, if you're putting in a DAS, you like to use it neutral. Most indoor implementations want multi-carrier. So that's where we are. Now, small cell improves this a lot. And then this yellow line shows you the increase in capacity of these two systems. A lot of times this is LTE, small cells now. This is LTE as well, but you're seeing more and more 5G implementations that's taking it to higher and higher capacity. Now, if you look here in Wi-Fi, you can see that if the cabling system's already in, deploying the APs and lighting them up is down around 50 cents, right? And we're talking about basically the cost per square foot. But if you look at the capacity, and I show a range here because it depends on what version you use, you see the capacity is considerably higher than these other technologies. So what do we want to do? High power, long range, big buildings, capacity. This is why we need to combine the technologies. This is why we need to converge. And there's some gaps in order to achieve that. Now, by the way, I have this times 7. Why this times 7? This is a capacity of a single AP. And I just told you we're deploying tens and hundreds of thousands of these things, and that the AP here is using the same spectrum as the AP out there. Typically, it takes about 7 APs to cover the same range as a higher power small cell. That's the times 7. So again, capacity, Wi-Fi, range and power is where we put the domain of 5G. These are complementary technologies. Now, we talk about densification. There's 2 ways that you get additional capacity on the network. So if you're a 5G operator, one way to get additional capacity is what do? You put in more towers. You know what the problem is with putting in more towers? You have to acquire real estate. You have to connect to it. There's a CapEx expense to building it and putting it out there. And then there's an OpEx expense because you have to connect it to a backhaul. So it gets very expensive. But you know what's happening in Wi-Fi? It's going through some densification too. So if you see here, this is a very typical deployment today. So if you see here, this is in square footage. We typically have an AP density where an AP would cover 2,500 square feet. But there was an earlier question, well, what about IoT? What about these other technologies? Well, you know what? These APs aren't, everyone thinks AP, they think Wi-Fi. And you know what? That's true, but that's not all the AP does now. The APs have multiple radios in them. The APs have 15.1 radio, Bluetooth. The APs have 15.4 radios. They can do Zigbee. They can do Matter and Thread. So these things are all coming together. And you know why they're coming together at the AP? Because these are mid-band technologies. And you know what's common about mid-band technologies? They propagate the same distance. So if your Wi-Fi covers your area, then these IoT technologies also cover the same area. So the perfect place to put these technologies is in the AP you've already got a cable going to and you're already supplying power to. So this is what we're seeing. And this is also driving some additional densification for reasons of accuracy. Now, you know, typically you wouldn't deploy on the edges of a building, but if you want good accuracy when you're doing location services, you need to have these at the edge, or you're not going to be able to effectively triangulate. And same thing, you start to go into higher densities as you start to get into some of these new use cases. And by the way, this is becoming ubiquitous. These are the different technologies. We've been doing triangulation using power for years. RSSI, you know what the problem is with power? Every time it goes through a wall, it throws off your calculation because you're using power. You're using power in order to measure how far you are from the AP. And how many walls have you gone through? Well, I don't know. Well, what kind of wall is it? Is it a stone wall? Is it, concrete? What is it? Is it metal? Right? And so what happens is that your accuracy only comes out to 5 to 10 meters. Bluetooth's a little better because it interprets energy more accurately. But now what's happened is the marketplace has completely changed. Do you know that every Wi-Fi chipset has FTM in it? It's part of the Wi-Fi spec. Do you know what FTM does? It's like GPS. It sends out a timing signal and the device echoes it back. And it works both ways. The device can send out a signal and the AP will echo it back. We know the speed of light, so we can calculate the distance to the AP based on the speed of light and the difference we see in the time it takes to echo that signal back. So this is very, very accurate. In fact, with ultra-wideband, because it's a wide signal, I won't get into all the physics of why wide is better, but we get down to 20 centimeters or about 5 inches. Now, if you can start to do that, now you can work in whole new use cases. The better your accuracy, the more use cases you have. And so what's happening now is because of technologies like this and the fact that we're putting these additional radios and capabilities in the AP, it's not about densification for capacity because Wi-Fi has a lot of capacity already. It's about densification to handle these other technologies and what we're doing with IoT and how we're sharing that spectrum together. All right, so I wanted to talk about strengths. I can remember we talk about convergence, and I was having a conversation with Dean. I don't know, I thought I saw him over here before, but I don't know if he's in here. But Dean goes, well, I think it's divergence, right? And he doggone Dean, he's right, it's both. Because we need to converge these technologies, but they also diverge. And what do I mean by that? Divergence means this. We have created certain stacks and technologies to address a specific problem. Wi-Fi, low cost, extremely high reuse of spectrum, capacity. That's what Wi-Fi does. That's why it's in all the buildings. 5G, licensed, high power, right? So you can't have the interference, so it must be licensed, and mobility. Private 5G, you know what we do here? Enterprises want more control of the policy of the connectivity that they're doing with private 5G, and they don't feel that they have that from the macro 5G solution. So what we do is we take the strengths of private 5G, the public 5G system, and the unlicensed implementations, and this is now multi-stack, and we converge that for a seamless experience. But you know where divergence is? Divergence is at the edges. We use the stacks in their strengths to deliver what we need for the purpose that they were built, and then we converge them through what? Identity, handoff, mobility, so that we can move across these networks, because what did the users want? How do we drive productivity? Ubiquitous access all the time. That's how we do it. And so these technologies come together. Now, I'm not going to spend much on this slide. Again, this will be in the deck, but this is what we're working on here at the WBA. Unified identity. Well, we did that. We did that with open roaming, and we can use multiple identities. Policy and QoS integration, there's components also there. Seamless mobility, I just talked about. How do we move across these? And when I say move across them, I don't mean moving across a 5G network and a Wi-Fi network that you own with a common core. I'm talking about moving across access networks that you own and you don't own to the benefit of everyone. Extending the 5G network indoors where Wi-Fi already exists. And the opposite. Extending the enterprise policy into the macro networks so that we can get the enterprise the productivity they need as they move around and they connect to these different networks. And we have the rest here. And again, I'll leave that for the deck. So this is a very old slide. This is something that we talked about when we first created the concept of open roaming. And you know what? We're still on this mission. Frictionless onboarding. Open roaming with Passpoint, thanks to the WFA. Seamless interworking. So in other words, if you have multiple ways to connect, what's the policy for connecting to which access? You might be able to connect to Wi-Fi, private 5G, and the macro system at the same time because you can see all the radios. And you know what? You want to be connected, but you're going to send your traffic a particular path. What's the policy for doing that? So intelligent path selection, and then seamless handover. And this is the vector part that Derek thought I was going to talk about, but I decided not to talk about this time. So, in conclusion, I would say 5G is the answer to Wi-Fi coverage. You know, I was looking at the square footage that Wi-Fi covers, and it's pretty daggone impressive, but it's only a fraction of what 5G covers. So Wi-Fi can't solve ubiquitous coverage. It's dependent on 5G. It needs 5G for ubiquitous connectivity. Wi-Fi is the answer to cost-effective capacity. That's why we have to pull these technologies together. Open roaming, and we talked a little bit about AI, that is the answer to convergence. That's the answer to how we do it well. And thanks to Tiago and the team and the work that we're doing here, WBA is where this is happening. That's the focus. How do we solve these solutions? How do we connect these ecosystems together? So with that, I'll wrap up.
Any questions to Matt from anyone?
I must have been really clear. Yeah.
Okay, there is one there.
Interesting conversation that we literally had at the board meeting. You know, I see satellite as a convergence too, and you know, we already do converge. I mean, so I talked about location services happening indoors, but what do we do outdoors? We do GPS. GPS and LTE 5G, they already converge, because what do? You get the signal from the satellite, but the LTE is what actually paints the map. Right? Now we do location services indoor. That's another point of convergence where we can tie these things together. Now satellite is also doing SOS type connectivity now, and there's a lot of push to connect directly to the satellite. The way I see this is umbrella technologies. You have Wi-Fi, very low radius. You have 5G, which is towers, which is good at covering landmass, and then you have satellite that covers all the in-between. So to me, it's the ultimate next step in convergence.
Yeah. Any other question? I'd like to raise one topic, Matt. So what do you believe is missing between the mobile operators community and the enterprise community? How they can collaborate better to make this converged connectivity a reality?
Yeah, you're probably not going to like my answer. To be honest, I think it's a trust thing. You know, the experience with the original Wi-Fi, if you go back to Wi-Fi 5, I'll never forget these conversations. We would go talk to service providers, and service providers would say, well, how many Erlings am I going to get per busy hour? And I'd say it's Wi-Fi, it's unlicensed, it depends. It depends on how much interference there is, it depends on how many other Wi-Fi networks are there, and the operators never like that. But I think where we are now is at a different point in time where we can do carrier class solutions with Wi-Fi, and that's because of all the work that went into Wi-Fi 6, where we introduced OFDMA, which, by the way, 5G is also based on. Yeah. So we're using common low-stack scheduling. But we also started to introduce technologies in Wi-Fi 7 that allow us to better schedule the medium and actually mitigate for interference so that we can bound worst-case latency. So if you look at what's gone into the Wi-Fi 7 specs, for example, over an IEEE and what the WFA is certified and what's going into 8, I would say 80–90% of it is how do you manage interference effectively, things like puncturing, things like MLO, and how do you produce a more reliable connection. Once we've established that, and that's where we are, now it's carrier class, now we can trust each other to provide a good service as we move across these networks. So I think the time is right.
Okay. Thank you, Matt. Thank you. Okay, moving on the agenda. So next speaker is Metin Tasking, CEO of AirTies. So Metin will talk about how Wi-Fi quality of service and pricing is impacting churn for fixed broadband services. So Metin, welcome.
Thank you, Tiago. Hello, good morning, everyone. My voice is a little bit disrupted this morning. I've been talking a lot since yesterday. I'm going to talk to you about, let me move, consumer survey results. We conducted a survey, not ourselves, we hired a professional company to do that. We asked about 50 questions to the residential subscribers in US and in UK, a bit over 1,000 in each geography. I'm going to focus on the US results because they're very similar. It's easier to do on one. So we asked them things about today. What are they doing? How are they using their Wi-Fi? And what does it mean for them? I think all of you probably know this quite well. That was just a confirmation of what we already know. People are using Wi-Fi. It's the invisible foundation of everyday living. They use it every day, and they use it for video streaming. We all watch TV over internet now. Online gaming, working from home, Wi-Fi calling. So it's everything we do about connecting to the world, basically. So that's a confirmation of everybody could guess. But yet, 75% of people that say that, I have had issue with connectivity at least once a month. Once a month sounds small, but still, imagine that your electricity doesn't turn on once a month, or your water doesn't come on when you just get into the shower, doesn't come on. It's really big disruption. And about 10 to 15% said that once a week. It's a big problem. Once a week, your internet doesn't work, or one of your devices cannot connect for some reason. And some of them, I think 4 or 5% was every day. Can you imagine that? Every day you have a connectivity issue. So this is the status today. And we asked them, what are the issues that you see once a month or once a day or once a week? Or not once a week, daily, weekly, and monthly. This is what we asked them. Mostly video freezing. As you can imagine, mostly video is viewing is done over the connectivity. So video freeze issues, video call quality, WhatsApp. I think my kids are using other things than WhatsApp now for calling. What was that? I forgot the application that I'm not using so much. Instagram calling, or you may remember, what's the other thing that kids are using mostly? They're not using WhatsApp. TikTok, that's not for calling. I'll remember. I'll tell you, you'll all know it. My kids don't know the phone numbers of their friends. No more phone numbers. I'll remember that application in a moment. So that was today. This is what they're doing. This is what they're experiencing. And this is what Wi-Fi, we asked them Wi-Fi, but people think Wi-Fi is just a connectivity. They don't distinguish between Wi-Fi versus broadband or the core network. Doesn't matter. If your video works, Wi-Fi works. Video stops, Wi-Fi stops. This is how they say it. And we asked them yesterday, how many of you changed your service provider past 12 months? In US, that number was 18%. 18% remembers that they changed their service provider in past 12 months. So that's what we call churn. It's the biggest issue of this industry, churn. People leave their service provider to go to another service provider, and that service provider loses money because they lost revenue. The other service provider also loses money. Okay, he will make more money with the customer in time, but spends a lot of money to acquire that customer acquisition cost. So it's a big industry leak, I would say, financial leak that's happening. And it doesn't help grow the total market because it doesn't increase the number of subscribers. It's just subscribers are switching from one operator to another. It's like musical chairs. They get out from one chair, get into another one. And there is no change in the total business size. And when we asked them why you switched, half of them said quality. I had issues, and either I had issues, I couldn't solve it, or the service provider could not help me to solve it. So I was frustrated, I moved. Price was lower than the quality. This is a little bit counterintuitive to what we all hear or service providers believe, or we believe because we all receive calls from the other service provider that's in our country trying to convince us to switch with discounts, with all those price things. But people mostly do not switch because of price. They switch when they are really frustrated with the service. And we try to double check that by asking a different question. When you switched, are you paying less, same, or more? 70% is paying the same or more. So they didn't switch because of price. They didn't save any money by going to another service provider. So that also confirms that people are switching service providers because they're not getting what they expect from the connectivity. They want it to work just like electricity or water. There shouldn't be any interruptions. My video should not freeze when I'm watching the best, my favorite series or even live stream. So it should work all the time. But that's not the case. We asked them tomorrow, about tomorrow. 28% said, I am planning to change my service provider. So that's what they know today. It's not like they're trying to remember if they changed 12 months ago, because this can be forgotten, they may be mistaken. But when you ask them, are you planning to change your service provider, 1/3 of them, and the number is a little bit higher in the UK, but similar, 1/3 of them says that I will change my service provider. And we asked them, why? Similar numbers. Performance, 44% says, I leave when the contract ends. Does it mean price or quality? I think it's a mix. Doesn't really mean price. Because they have a contract, they're staying with the service provider. That was a big number there. They're staying with the service provider because they have a contract. But when contract ends, they're going to leave. They're part of this 28% who wants to leave. And this was a very striking number. We asked them in a different context. We're not talking about why you churn or anything like that. We asked them, how satisfied are you with the quality of service? And there's a very satisfied, somewhat satisfied, somewhat dissatisfied, and very dissatisfied. The ones that says very dissatisfied, in US, 82% says that I'm going to leave my service provider. All of them, almost. In the UK, it was 92. This is very striking. When customer is dissatisfied with the quality, they will leave the service. It doesn't matter what the price is. They may stay because the contract is still up, so they will wait until the end of the contract, but they will leave. Number of dissatisfied customers at any moment is not like half of the people say, I'm very dissatisfied. I think the number is like 5-6% or something, but at any moment, you have that many customers that are very dissatisfied and they will leave. So what do we do about that? Not much. I haven't seen any service provider going after the customer, trying to fix their issue, whatever it is. It's all reactive. If customer calls, they try to fix it. And a lot of times, if they're not able to fix, and that happens too, customer leaves. So that was 4 times more compared to the satisfied customers. So satisfied customers don't want to leave. They may leave still for other reasons, but they don't want to leave because of performance. It's 4 times more for the customer, same type of customer, but it's just not satisfied with the quality. So what to do? We looked at the economical impact of this in US only. $124 billion revenue lost by one of the service providers, by all of them altogether, but each of them individually. The total revenue lost is $124 billion. How do we calculate that? We look at how many people churn and 3 years revenue from that many people. That's a lot of money. If you look at it in a different perspective, customer leaves and the service provider finds another customer. They need to find 20% every year, average I'm talking about, just to stay flat in their subscriber numbers. And they spend, the number is very debatable, $1,000 per customer, per new customer, or $2,000 per new customer acquisition cost. We put $1,000 just to calculate how much it is. $71 billion is spent just to stay flat. It's a big economical issue. And we talked about this one in two leaves from the quality issues and all those numbers that we talked about. So that's where we are. So what do we need to do? We need to really have connectivity experience management. I'm not talking about smart Wi-Fi. I'm not talking about, I don't know, additional value-added services. Those are all different angles to, get some customer satisfaction or maybe win customers. But number one issue or number one differentiation for a service provider, provide better user experience. It's not about tons of features I want to bundle in, make a 10 gigabit per second service so that I can really give big numbers and people will come and subscribe to my service. The biggest differentiator is quality service. And how do you do that? First, you need to measure the quality. Measuring quality is very difficult. Measuring how the customer experiences the connectivity is not that easy. the customer experiences in his mobile phone, in his TV, on his tablet, you don't have anything on those devices to tell you how this worked or how the service worked. When they watched video, did it freeze or not? So the only place the service provider has is the router. And the router is seeing all the traffic coming in and out. And this is where the measurement can happen. And this is what we do as Airties, trying to understand what the customer experience is. The middle one is very, very difficult. Even if you know all of this, who has a department who looks at those reports and goes after proactively fixing it? It's very difficult to operationalize that, but that is needed. This is the solution, to have a department that's not call center, because call center only answers the calls they receive. All they're trying to do is minimize as much as possible the wait time and resolution in the fastest way possible with the least resources possible. The call center doesn't call back and say someone that you have a problem in your home, please move your router to this other location, or this device seems to be broken, let me send you a replacement device. There is no proactive maintenance department that I heard of in service providers. It needs to happen. This is really, billions of dollars are lost because the customer is suffering and then leaving and no action is taken. So ACT is very important. And grow also. Biggest differentiator is better service. Nothing about features, it just needs to connect, that's all. The devices needs to connect all the time, not even fail once a month. And by looking at data, by understanding where I can provide that peace of mind and which customers are likely to buy that peace of mind. The customers, one more question we asked was, how much more would you be willing to pay if you get an offer that guarantees that you'll always get connectivity? Significant money, $10 more. A lot of people say that I'll pay $10 more if the service will never fail, if I get peace of mind. And that is learning from data. You can really even sell this premium connectivity service. I'm not talking about 25 different features that you bundle in, bundle Netflix in, bundle security, bundle this, bundle that. That's also some way of selling, but it's much less effective than selling peace of mind. So, time is up. All right, last word. We try to reinvent ourselves. What is the purpose of Airties? Our purpose is to empower operators to deliver smooth, smart connectivity. Smooth because it always works. Smart because you learn from data, you act smarter, and you deliver much better offerings to your customers. Thank you.
Thank you, Metin. Fantastic presentation. Thank you for sharing all the findings of the survey. Question from the audience. There is one from Andy.
Hi, Andy Gans, Cisco. I just wanted to ask you a question on, is it the Wi-Fi systems that are going down and causing the outage, or is it the contention on the network, cable infrastructure? That's an interesting question. If it's the Wi-Fi, then it's spectrum.
Yeah.
Simple. Or
Yeah.
upgrading. And actually Europe, I'll do a presentation this afternoon. Europe's in danger of doing that in 6 gigahertz and not giving enough spectrum compared to the US. So it's an interesting conundrum for operators who are pushing for more spectrum for mobile,
Yeah.
but maybe causing problems for their own subscribers on the fixed networks.
Yeah. I don't think it is spectrum. There is enough spectrum in Wi-Fi, much more than mobile networks. Right? Hundreds and hundreds of megahertz. That's not, no mobile operator has that much licensed spectrum, right? It's really stupid problems. I call them stupid problems. A client device that has an interoperability issue with the routers. The problem will be bigger with Wi-Fi 7. It is bigger with Wi-Fi 7, and it's going to be even bigger with Wi-Fi 8. The clients out in the market, there's 14 billion Wi-Fi devices in the market. And they all have, I don't know how many vendors there is, thousands of vendors. Tens of thousands of different software versions, different implementations, especially the legacy clients. When they see a Wi-Fi 7 beacon or probe response, some of them do not connect. So you may have 25, 30 different Wi-Fi devices at home, and one or two doesn't connect anymore. That's a problem. That's a dissatisfaction. So the networks, of course, they get modern, more modern, higher capacity, but the clients do not get replaced that much. Mobile clients replace very quickly, but IoT devices, speakers, audio players, TVs, those things stay as they are without update. And when you introduce a new Wi-Fi version, they're supposed to be interoperable, but they've never seen that Wi-Fi version in their life before. When they were certified, there was no Wi-Fi 7. And we are all dealing with software. You have unexpected results time to time. So a lot of things clients are not connecting. Interference is an issue, but there are solutions there. You select different channels, and the Wi-Fi 6, 7 has very good interference mitigation methods. I don't think it's this kind of Wi-Fi capacity issue. It's more of an end-to-end system. A lot of routers have software bugs, and they may reboot time to time. They may lose connectivity time to time. So Wi-Fi capacity can be solved. You can add extenders, you can manage spectrum better, but there is really not so easily understandable by, let's say, engineering desk calculations. It's not like that. You find millions of different combinations in different homes, and there's issues like installation issues, for example. You buy a mesh extender, you put it in the same room as the router, and then your network doesn't work. You don't understand why, because I bought this booster, it should increase my signal level. Many customers do that. So it's very easy to fix. Just take this mesh extender and put it into 2 rooms away, or the upstairs. So stupid issues like that.
They think Wi-Fi's got spectrum to itself. Bluetooth uses the same spectrum as Wi-Fi. Zigbee uses the same spectrum as Wi-Fi.
Yeah.
The backward compatibility issues cause spectrum issues.
Yeah.
Because you go back to the old Wi-Fi technology, which means you go back to the lower data rates. So that causes a problem on your routers as well. So people need to look at the spectrum issues as well. It's not just a case of actually not being able to solve it by putting more spectrum, because you need more spectrum, because you're putting more and more devices on that network. And the more and more devices you put on the network, and the more and more backward compatibility issues you've got to deal with, then the more spectrum you need to do it. And if you want to do low latency, you need spectrum to do that as well. So
yeah, spectrum increases the capacity, of course.
There is like a naivety that thinks that Wi-Fi's got enough spectrum.
Yeah.
In enterprise, you certainly don't. You get more data rate in your home network today than you do in your enterprise networks, because enterprise need to do frequency reuse patterns exactly the same as cellular systems. So they're now down to 20 megahertz channelization to do the frequency reuse, maybe 40 if they're lucky. And they're going to have the same problem in 6 gig.
Yeah.
If they don't get enough 6 gig spectrum, or any other spectrum. So there is problems there. And it's a naive thinking that spectrum's not an issue.
Yeah, but yes, that is not 70% complaint reason. This is what I'm saying, right? Yeah. So maybe there's some really dense areas where spectrum is a limiting factor, but there are tons of more problems by stupid reasons.
Yeah. And Martin, maybe you can share a little bit about how AI can help specific on the prevention of many of these issues, and learn from recurrent issues on the home LAN, and how AI can help that. Because I think many of these issues, like you said, it happen on a regular basis on the same environment.
Yeah. AI definitely helps, because, like I said, it's many different reasons that comes together and ends up in this customer experience issue. So it's not really I will multiply this by 2, add this one, and then combine, and I'll get the result. There is no formula to tell you what the issue could be in a home. But by looking at data is very immense, right? There's a lot of different parameters being collected. Every second, we're collecting data from every connection. When you combine all that, somebody has to say, like, this is the issue to fix.
Yeah.
And that is done today by technicians, right? A technician can go in a home. I say that our field application engineers, technicians, when they look at the data, there is not a single case that they cannot find what the problem is in a home. So somebody complains, when they look at the data, they find it.
Okay.
AI can do the same. We're not there yet, but AI can do the same. So if you're able to put a technician in every home, there will be no issues. We can't do that, but we can put AI in every home.
Yeah.
So with the right recommendation, there is no problem that cannot be fixed.
Okay. Good thoughts. And by the way, was Discord the application for video calling? No.
It's not Discord, I
Yeah,
remember
okay,
that.
that's fine, that's fine. Okay, Martin, thank you so much.
Thank you.
Yeah, looks like I need to talk more with my young daughters to understand all these new Snapchat. Okay, good. Okay, moving on the agenda, I would like to invite Eric McLaughlin, VP and GM for Wireless Solutions in Intel, to talk about Wi-Fi innovations for support massive growth and the different use cases evolution. Eric, welcome.
Thank you. Well, I'm like most of the other speakers have said so far, I'm really, really happy to be here. Not only did we have great food at the board dinner last night, but I love being in this environment because I'm surrounded by the smartest people in the industry, and that is really cool and energizing. And so much so that I realized as I was sitting in the audience that when I come here, I always say, you know, there's three things that I want to make sure the audience leaves with. And then after listening to Matt and Derek and all these great speakers before me, it changes, and what I want to do is just not look stupid. So we'll see if I can accomplish that this week. So I do want to talk about, oh good, the slide's here, about innovation. And it's one of my favorite topics. So I'm going to tell you a little journey. It's kind of my experience, Intel's experience. But I think what's cool about this journey is everybody here is in that same experience. At least I hope so. So back in 2020, Intel Capital, the investment arm of Intel, did a study about major consumer devices. So PC, phone, tablet primarily, and looked at where is innovation happening on those devices. Is it the OS? Is it in the display? Is it in, power? Where is the innovation going? And they studied for 6 months and came back, called me up and said, it's wireless. Wireless is the most innovative part of the device. More things are being changed, improved, and worked on in wireless to drive innovation than any other part of the device. So we started this work of evaluating all these startup companies out there in the world that were working on all these cool things, all this great innovation. We surveyed and talked to over 100 companies and looked at them and, do we want to partner with them? Is there something we can learn from them? Should we invest in them? What can we learn, right? So as I look back on our innovation journey and kind of how we look at things, one of the things I want to point out, we just talked a little bit about spectrum, the importance of spectrum. That came up multiple times. Convergence, the importance of making all of these things work together comes up multiple times. So this is a little bit about my journey. Chris Szymanski from Broadcom's here. He's probably in some of these photos. But back in 2020, a group of us went and visited Chairman Pai of the FCC. And when we visited him, our whole goal was to show him, if you open up 6 gigahertz spectrum, this is what you're going to get. So we actually got a test license. We went and tested with real product, right? A real client product from Intel, a real base station product from our friends at Broadcom. And we showed them in their office what it accomplished. And if you go look at his tweets, it was March 6, 2020, he was like thrilled, right? And in April, he opened the spectrum. All 1,200 megahertz of 6 gigahertz open for the US, right? Huge. Now, I would love to take credit for that, and say it was us. I think we just had a nice, timely visit, but it was, I think, a really, really important thing that happened in the world and continues to happen across the world as more and more companies open up more spectrum. So the other thing I always point out about this, because I don't think people really understand it, but that journey to 2020 started in 2016, 2015. So when you're doing, we're the silicon guys, right? So when we make silicon, it takes 4 years from the time that we start the design to the time that it actually ships in a product. About 3 years of that is our development effort. We sample about a year before, somehow I set a timer on myself. We always sample about a year before, final product. But 4 years, so we had to make a bet that 6 gigahertz was going to open 4 years before it did and start investing tens of millions of dollars to develop a product that ended up, luckily, being ready within the time frame when the US and other geos started opening up the spectrum. So now fast forward to 2025. We went again and visited with Chairman Carr and had a chance to show them, hey, here's what we've done with all of the spectrum that you've given us so far. So I don't know if you've seen these statistics, but 12 million APs in the world out there supporting 6 gigahertz. Over 1 billion devices since, end of year 2020, when devices first started shipping. And at Intel, 70% of our products that we ship to our customers support 6 gig. 70%. So a very fast ramp of 6 gigahertz support. And that's without, geographies in countries like China who haven't even opened up any 6 gigahertz. So as we continue to roll out 6 gigahertz spectrum, that number is just going to go up and up and up. So why do we drive innovation in wireless? Why is this such an important place for innovation to happen? This is, on the left, a report from some Comcast data that came out earlier this year. In the US, 90% of mobile internet traffic runs over Wi-Fi. 90%. So your phone, believe it or not, as you're doing all the things you do on your phone, 90% of the data that you use and drive is over Wi-Fi. Why? Because when you walk into your home, automatically fails over to, shifts over to Wi-Fi. Most of us, myself for example, when I get to the office, I have a network for that. And, when we walk in the office, it shifts to Wi-Fi. Any place that I have Wi-Fi access and credentials, a WBA open roaming event, for example, my phone automatically switches over to Wi-Fi. 90%. So that means Wi-Fi is carrying 10x the amount of data that cellular is carrying at any given time. All cellular, right? 3G, 4G, 5G, everything. More than 10x. And this is a huge growth, 36 average number of devices in the home. Anybody have more than 36 here? I knew Matt did. Yeah. Few, yep. 1%, the top 1% of Comcast had 150 devices in the home. So huge number of devices being used. I'm somewhere around 30, but that's because my kids have left the house. It would be more. So we've got a huge number, a huge reason, right? Wi-Fi is carrying so much traffic, so much data, and is so important. And all of these devices that we're shipping have it. I think Kevin, speaking later, he'll probably quote the same statistics, but about 4.5 billion devices a year are shipping, right, in Wi-Fi. So a huge number of devices shipping every year. So, you know, the number of Wi-Fi devices is growing, 6 gigahertz is getting better, and traffic has gone up a significant amount, and that's before we actually account for AI. So AI is just scratching the surface today of moving data back and forth, whether it's to the cloud or, you know, local to your enterprise or even on your device, doing AI workloads. It's just scratching the surface of how much that's going to impact our these networks that we're building out. So on top of that, here's your parts of the journey. I'm guessing that the people in this room have participated in a lot of those things here on the left. If you're part of the WBA, you certainly have, but I'm guessing most people here have participated in helping drive some of these innovations. So, you know, we just talked about, you know, how do you fix, you know, Matt, when he was talking, how do you actually proactively fix problems in a network? Well, we're already doing some of that. We just rolled out a solution that's an Intel-based solution for PCs at Intel across all of our IT that reduces time to fix from 20 minutes to 20 seconds. All right, so you still need a human at this point to take not just the data, but the insights that come in on the issue, to look at it and say, yeah, that makes sense, and hit the button to, for example, download the right driver or whatever the fix might be. Over time, that's not going to need to be happening. Over time, it's going to, if it's a driver update and the driver is resident within the IT domain, it'll just update. It'll get done. And the user will not have to pick up the phone for a help desk call. So AI ops, cloud and SaaS, all these, you know, huge numbers of things that are going on, all innovations that are being driven by people in this room. At Intel, we've been hard at work. I mentioned our, I don't think it's, yeah, it's the bottom one, Intel Connectivity Analytics is the one that I just mentioned that's helping reduce the number of help desk calls and helping to reduce the mean time to fix. We also have talked about this several times so far in the discussion, and probably will be brought up more with the next day, is that, you know, issues happen, right? Problems occur. So one of the things we've tried to do is anticipate the typical problems that happen. For example, we know that people are going to move. And how do you anticipate, you know, that movement? And what do you do? Well, in the standard, Wi-Fi primarily waits for a certain amount of, you know, poor performance before it'll actually make the switch you know, to a different AP. We're actively scoring APs on a regular basis. We know what the best AP is. Before you don't even know it, it just happens in the background and it moves to a better AP. And the better AP can be fewer users, more bandwidth, you know, higher performance AP, whatever the case may be. So those types of things are already coming. Those are innovations that we've been driving because, to the points that have been made by several speakers, we want happy customers. We want happy people using their devices. We don't want people to have to pick up the phone and say, my PC isn't working, it's not functioning, my phone isn't working, I can't get connected. And we want them to just have a great experience all the time. So that innovation train continues. The way we look at Wi-Fi 8 at Intel, and I noticed Broadcom announced some stuff yesterday, was it? Congratulations. But so for Wi-Fi 8, the way we're looking at it is that Wi-Fi 8 is the Wi-Fi for the AI era, right? This is the technology that we're going to start rolling out as Wi-Fi becomes more and more part of the AI experience. And that AI experience has to be highly reliable, right? It has to be reliable. It has to be efficient because now we're moving even more data, more workloads. You need that efficient managed network capability and to be intelligent and smart. You need seamless coordination between the APs and the clients, as well as all of the other radios that are going on, as Matt and Derek mentioned earlier. So if we do these things, you get deterministic performance, you get context awareness, which is going to add to AI in two ways. So, simple example, today we have the capability in our products using Wi-Fi to tell if there's a person in front of the PC or not. And did they move or not move? We can also, believe it or not, we have the beginnings of breathing detection using Wi-Fi. So is the person sitting in front of the PC breathing, not breathing? That's going to get better and better as channels get wider, as we get to Wi-Fi 9, 10 time frame and you open up 60 gigahertz back into Wi-Fi again, you'll have massive amounts of new spectrum, massive pipes, big wide channels, and we'll be able to do gesture control and other things that really improve context awareness, which means your relationship with your device and the network becomes a lot more personal. So context awareness is going to drive AI experiences we haven't even thought of yet. And then obviously with AI, we need privacy and security. Wi-Fi delivers on that as well. So closing thoughts. The industry, this industry is so fun to work in because we innovate. I can't, as I listen to your keynotes, as I go to these booths, as I talk to people in the industry so often, I'm just amazed at the amount of innovation, starting in the standards, starting in certification, making sure the foundational capabilities of the Wi-Fi spec or Bluetooth spec or whatever it may be, 6G, is helping to drive innovation. But then over and above that, all the things that your companies are doing to make devices work better, networks work better, experiences to be better. So my closing remark is, my view is the place to do that is the WBA. We have a great history and pedigree of collaboration, engagement, to not just talk, but do, and go solve real problems, go fix things that have, need a lot of work to be fixed, and you have all these amazing companies and smart individuals in one place where you can go make that stuff happen. For those of us who were in the forum yesterday, we were treated to a lot of the outputs from all of these technical work groups. Just amazing the amount of innovation and problem solving that's going on. So love to be here, love to be part of the WBA, and love to be part of an industry and a group of people that aren't just smart, they innovate at a fast pace. Thank you.
Thank you, Eric. Time for one question. Anyone? Any question for Eric? Okay. Looks like you did a great job. Thank you, Eric. Okay, moving on the agenda. So next session is a fireside chat that I want to have with my friend and colleague, Jason Briggs, the President and CEO of RDK. So Jason, welcome to the Wireless Global Congress. Thank you. Thank you for coming, Jason. Good to have you here with us.
This is a picture of me when I started RDK. Oh boy.
Yeah, maybe we can start by, first of all, introduce RDK. Who are the companies behind the organization, type of work, the programs that you guys run, and of course, any novelties, recent announcements will be good to share with the audience.
Yeah, so maybe I'll start at the beginning and fast forward, but we started RDK back in 2012, so a long time ago. We've been doing this for a while. And every new project, technology, innovation usually starts with a problem. And so the problem we were solving at the time was the slow pace in innovation, and we looked at the kind of the core reason for slow innovation. It really a lot of it tied back, not all of it, but a lot of it tied back to the software on our gateways, our Wi-Fi gateways and set-top boxes, and there was a number of operators that looked at that. So, and the reason for that, it was proprietary. It was tough to port a new service from one to the other. So a number of the operators at the time got together. At the time, it was Time Warner, Comcast, and Liberty Global to say, why don't we work together in a more open way, open stack to help to speed up innovation. And lo and behold, it did that. But it also opened up maybe a new chapter in the 2014, 2015 timeframe where we said, look, we need to do this more as an open source project and less as an operator project. And we essentially open sourced RDK at that time. And since that time, we've grown. So we have we recently announced over 200 million shipped devices on RDK, and that's video and broadband, both inception to date. We had, what started with a couple of members in our community. We now have a community of over 700 members today. So it's, fantastic growth, and it's really amazing that I'm really lucky that I could see it from the beginning to where it is now. And I think to answer your question, some of the nuggets outside of our deployment numbers we had some recent announcements from here in Paris, SFR in France, announcing the use of RDK B on their gateways. Vodafone recently announced UK and Germany going RDK B for their Wi-Fi 7 gateways. So a lot of really great momentum, especially on the broadband and Wi-Fi side.
Yeah, and we saw on the presentation from Martin from Airties, lots of momentum on the residential broadband services and demand. Fantastic. One area that I can share the WBA experience, but I would like to hear from you as well.
Yeah.
It's very challenging for many of your companies, to be able to allocate financial resources, human resources to develop all these programs. It's not only about the time and the money, but the amount of expertise that probably they need to stop doing other things, either in your network with your customers, and you need to invest that time in organizations like us, and then you need to travel around the world, and you need to pay all your telecommodations and all that is really a huge burden that we see on our members. I don't know if you see the same, Jason, as well on your side in RDK, but is a big challenge. And I think we as an organization, we should try to bring the best value to them at the end of the day.
Yeah, I think same perspective. It's no secret that resources are becoming more constrained. And I look back to a story I had with about 2 years ago with an operator exec talking about, hey, we're going to have to find ways to cut back and do more with less, and how's that going to impact RDK? And I said, well, honestly, I think it's actually going to be a catalyst for us if we do it the right way. Yeah. And what I mean is when you have, I would say, when you have unlimited resources, which no one really has, but even back when you're in innovation phases, when you have unlimited resources, you have a tendency to quickly build what may have already been built out in the open source. And so when you start to turn the dials, at least from a capital kind of constraints perspective, it forces new decisions on where you spend your time and effort and resources. And for us, that's great. That means and I said we were kind of made for this moment. We were waiting for this moment because it actually brings people together. It actually gets people saying, well, we want to do this thing, build this thing. Has anyone else done it? And if they have, can we actually work together on it? So it's a bit of a motherhood and apple pie, but it does work. And it then frees up resources to do things for the customer, which is really what they want to do. So I think, from our perspective, it's always a challenge, but it can be a good thing if people embrace it the right way.
Yeah, and one thing that, at least on WBI, we try to do is to increase the collaboration between the alliances. At least we exchange information, we exchange roadmaps of programs, we exchange plans ahead, so we avoid duplication of work. We avoid that two organizations are working on the same topics. It's important that we find very innovative areas that each of organizations should focus to avoid that duplication of work is super fundamental. That's why we are here today, Jason,
Yep.
and I have many other good stories with Wi-Fi Alliance and other organizations.
Yeah, we tend to say, with RDK, you can use it stock, or you can pick things to kind of work with us on. So both are fine. And I would say, if you want to work on everything, that's fine. But I think every organization that comes to the table brings something special, something unique. And those are the things I encourage to say, if you can bring one or two people that know Wi-Fi very, very well, and can help us make a better, more standardized Wi-Fi stack, that is great. And that's what we want. So we want to kind of make sure that it's not kind of one of those things you need to bring a whole army of people to do everything. Really, little contributions really help us a lot.
Yeah. I would like to ask about your experience on open source communities, because there is always this tendency to say that standards development is a very slowly type of exercise, because we need to collect opinion from everyone and put everyone in agreement. But you are coming more from an open source perspective.
Yeah.
How do you see the difference between the traditional standards development and open source?
Yeah, so I think that's a correct statement. I think from our perspective, open source is a double-edged sword, because it's great because you can pick it up and start using it very, very quickly. But then the question is, okay, once you get something, a proof of concept up and going, what do you do with it? And is it scalable? Can you deploy it? And that's actually where the rubber hits the road, as we say. And so from an RDK perspective, we try to, we keep an open source mindset, but we also keep a mindset of scale and deployability. So we put a lot of testing into our code, and we try to catch things earlier in the cycle, so that if someone's putting RDK on their hardware or deploying it to customers, maybe we've caught a majority of the issues before they see it there. So in a way that slows us down, but I think that slows us down in a good way.
Yeah.
The other thing I'll say is I'm pushing for a concept of platform versus product. So if you're thinking platform, that's really where I want RDK to play, and that's where I think it can go a little slower and more, a little more measured in the way we innovate. If you do that, the product that rides on top can spin and innovate as fast as you want to. So if we get a good common foundation, a solid foundation, then that innovation, the speed of innovation can happen very, very quickly.
Yeah, and a good example of the collaboration between WBA and RDK is the Operator Managed Wi-Fi program from WBA, where RDK, you guys participated,
Yeah.
you contributed, you bring your perspectives, we incorporated on the architecture, so that's a good example of how organizations should collaborate, avoid that overlap of work, and each of them gives their own components to overall benefit for the industry.
Yeah, I think a shout, I don't know if Jose is in the crowd here, but a shout out to Jose on the RDK team. Maybe he's off meeting folks right now, but he really took this up and was very passionate about working with the
Correct.
WA, and I was really happy about that. And I think you've issued the 2.0 spec, and it has a great reference architecture of OMWE working with RDKB, and a lot of that is the hard work that both of the teams have worked together to kind of put that in place. So I think that's great.
Awesome. Well, to start wrapping up, I know that you guys had your event recently.
Yep. Yeah.
Maybe you can share any of insights,
Yeah.
major topics, discussions that happened on the RDK Summit.
Yeah, we covered a wide range. So we had a global summit we have every year right around at the end of IBC. So we've been doing this now for a long time. And over 500 people. It was a great venue. I think the things that stood out to me, first of all, we had amazing presentations from Vodafone to NSFR talking about their deployments in RDK. Pedro Bandiera with DT was there, Paul Clark from Comcast. We had a lot of great operator representation talking about their plans with RDK. I think my message at the theme that we had at least was that solid foundations make great platforms. And so a lot of the work that we're going to be doing over the next couple of years are really about how do we, number one, align around a core RDK, which is in my mind not really technology or code, but a way of working. So how do we boil this down to an essential software stack with extensions for the things you need? And then how do we certify the stack? And so we announced the upcoming program called RDK Ready, where what we want to do is give people the ability to take RDK, put it on devices, and actually certify that it works and put a stamp on it. That will help a lot of operators, OEM, silicon vendors to actually bring it up and put kind of a trust stamp on it. So a lot of things we covered.
And by the way, thank you for the invitation to be on the
You're welcome.
RDK
Anytime.
Summit.
Anytime.
That you made to me. Unfortunately, I could not go there, but because I was double booked, but thank you for that.
Yeah.
Final question just to share. It happens as well in WBA, but many times on these organizations, we have that competition and co-collaboration, co-competition between carriers that they compete with. At the same time, they need to cooperate in these organizations. How do you manage and you see that at RDK?
I could take tips from you. Yeah, when we started RDK, the members really didn't compete in a large degree. And as M&A, new deployments, consolidation has happened, now virtually all of our operator users, let's say, have an overlap in one way or another. And I'll actually give full credit to Pedro Bandiera at Deutsche Telekom when he was looking at this and kind of mapping it out. But he said, look, we need to look at this technology in kind of two ways, and kind of like the platform way. But he goes, we need to look at it as enabling technology. And enabling technology is something that if you don't do it, someone else will, and there's really no reason to deviate on that technology. We should actually work together on that. It doesn't really differentiate our products or our services. It adds cost if we decide to do things differently, and we should probably work together on those things. And then on top of that would be the differentiating technology, and that's actually technology that a lot of the companies will keep themselves. It's what they use to differentiate their services in the market. So if you look at it that way, then if you have that lens and the way you look at it, then it actually helps, at least us from a software perspective, to kind of designate that this is enabling technology and you should use it. And the consequences of not doing that, of going alone, I think are probably more severe than actually working maybe with your competitors at the same time to get it
we see that not so often in WBA, but we see as well sometimes some friction, either between carriers that they compete or even vendors. But like you said, we try to always bring the bigger good for everyone, so to find the common benefits that everyone can have. Jason, maybe we can work better on events in the future, more collaboration. Maybe we can discuss that on the coffee break, but I'd love to collaborate more with RDK.
I'd love to. I didn't go into the core RDK principles, but one of the principles are to align to standards. If there are standards out there, don't reinvent what's been invented in standards. So absolutely would love to do that.
Yeah. Thank you for coming, and fantastic to have you here.
Thanks for having me. Yeah, appreciate it.
Thank you.
Good morning and welcome back, everybody. I hope you had a good coffee. Thank you for joining us for what I know will be an insightful and engaging session on enterprise connectivity. It says here, on the move, on the pause, offices and venues. For those of you that don't know, I'm Steve Namasaveyan. I'm Vice President for our Industry Alliances and our membership program at the WBA. I'll be moderating the entire session, taking us up to lunch. Here's the agenda. I'd like to get things started by welcoming Kevin Robinson, who's the CEO of the Wi-Fi Alliance, to the stage to talk about the future of Wi-Fi in the connected world. So Kevin, please. Thank you.
Okay, thank you. Well, good morning, everybody. It's a pleasure to be here, and always great to be present with the WBA. I think the Alliance and WBA have had a long-standing partnership of collaborating well together. Of course, I come from the Wi-Fi Alliance, which is the worldwide network of companies that brought you Wi-Fi. We're made up of more than 900 companies that help drive the future of Wi-Fi innovation. So, a lot of these stats you may have seen a little bit earlier, but I think by any measure, any neutral measure, Wi-Fi is one of the most successful technologies that the world has seen. We ship anywhere from 4 to 4.5 billion devices per year. This year, we're expecting to ship over a billion 6 gigahertz devices, and I'll get into 6 gigahertz a little bit later, which of course is one of our main focus areas. But today's Wi-Fi 7, we're seeing phenomenal momentum and growth. In fact, between 2025 and 2030 or 2029, we're expecting to see roughly a 45% compounding annual growth rate of Wi-Fi 7 shipments. I'm going to touch on a few key trends and developments within the Alliance that we think are really going to kind of support this continued innovation and success. One, of course, is around 6 gigahertz, which is going to be essential for delivering low latency multi-gigabit connectivity. Talking a little bit about how Wi-Fi does a better job of supporting a new, deployment models like in multi-dwelling units, a little bit more of a seamless experience there. And then, of course, talking about how AI is going to contribute to Wi-Fi moving forward. So I'm not going to spend a lot of time on the convergence piece because I think a lot of the previous speakers really spoke very well about it. And maybe convergence is not the best word. I think Matt was very correct in saying it's a bit of divergence and convergence. But the reality is we need to find ways for how Wi-Fi and complementary technologies like cellular and satellite can work better together, so ultimately the experience for the end user is better. And these are just some of the reasons why it is so important that we get this right. The reality is with new data-intensive use cases, we want to deliver that consistent experience in those use cases no matter where the user is. If they're in the home, if they're out and about, maybe increasingly if they're out in a national park or something like that. How do we deliver those use cases wherever you are? And that's going to require better collaboration between Wi-Fi and cellular type technologies. Now, of course, indoor and outdoor coverage. We know that Wi-Fi is the predominant way that indoor connectivity is delivered. That's just the reality. And that's why Wi-Fi becomes so important. Because if you're looking at this from the MNO perspective, and you want to deliver those 5G and 6G use cases, you have to do that indoors as well. And Wi-Fi is how that's done traditionally and moving into the future. And of course, Wi-Fi is absolutely critical to cellular offload. This is just one stat. You see numbers as high as like 90% of smartphone traffic is going over Wi-Fi. This one I find interesting from OpenSignal because it's saying more than 75% of smartphone data usage when you're away from home is over Wi-Fi. I think people would intuitively understand why, when you're in your home, the lion's share of traffic on your smartphone is going to be over Wi-Fi. But when you're away from the home, it's still upwards of 75%. And that's just absolutely incredible. So I want to give one very concrete example around the importance of 6 gigahertz. And this was a trial that Wi-Fi Alliance did with Ramathabodi Hospital in Thailand. And it was a 7-month trial looking at the benefits that 6 gigahertz delivers. There were 2 use cases that we tested. One was looking at emerging applications like augmented reality, virtual reality, where the hospital had developed this innovative application for teaching basic medical students anatomy. So rather than 12 students huddled around a cadaver looking at how the various systems of the body work together, you are now able to get dozens or hundreds of students virtually around that instructor over a virtual cadaver and kind of taking each of the organs out and peeling off the skin and all of that without the use of this limited resource of human cadavers. In addition, we looked at scenarios where we were doing things like going through testing, et cetera. So more than 200 students in a single classroom doing highly intensive video-based tests of that anatomy course. So both of these were really designed to kind of tax the abilities of Wi-Fi networks and networks in general. Now, what were the results? We looked at 2 scenarios. We looked at just the lower part of the 6 gigahertz band, and then we looked at what type of improvements would we get if we had the full 1200 megahertz. In scenario 1, using only the low 100 or 500 megahertz, we had pretty good performance, but it was somewhat limited. We had latencies that were starting to surpass 200 milliseconds, Now, when you're doing extended reality, sometimes there you're starting to get glitches, you're getting, lag between the professor moving their hand and when you're actually seeing that on your VR headsets. And in the worst cases, you're seeing things like motion sickness. Now, in the second scenario, we had the full 1200 megahertz available. We were able to double the throughput to any individual device, and that's really what matters. It's not, it's what the collection, the whole system is able to deliver. We were able to reduce latencies down to 20 to 30 milliseconds, even with 200 plus students in a room, having extremely smooth streaming and extended reality experiences. And then in addition to that, we did more of a qualitative measure of experience. So surveying the students on what they felt like their experience was and a number of different metrics. And there was a 3x improvement in user satisfaction. Okay, so all of that's great. So what are the challenges, some of the challenges ahead of us? Some of the challenges are in the area of policy, and very specifically in Europe right now. And I know some people touched on this earlier on, but we're in a position now where Wi-Fi is ready to deliver these benefits. We have Wi-Fi is already operating in the full band. We have more than 5,000 different product models that support 5 gigahertz that are shipping globally. But unfortunately, many of those devices, like the one in my pocket, when I'm at home in the US, it takes advantage of the full 1200 megahertz. When I'm here, it has a constrained experience. It only has the lower portion of the band. And that's problematic. So of course, from the Alliance's perspective, it's absolutely essential that we get access to the full 1200 megahertz. Now, there's a bit of a caveat in that, because I think we can actually fit within some of the goals that regulators and policymakers have in Europe in a very pragmatic approach. But what's critical is that we're able to get that access. It's a way to kind of future-proof some of the growing connectivity demands, such as universal gigabit connectivity. I know there was a question earlier around, well, really is the full 1200 megahertz necessary? What does that do around experiences? We had one very concrete set of examples in a recent study that we commissioned, looking at a typical multi-dwelling unit environment. So this is, apartment buildings. You're bringing gigabit fiber into every one of those apartments. If you only have half of the band, you have roughly a 50% chance of actually delivering that gigabit connectivity. Or put another way, only half of the people in that building will actually get the gigabit connectivity they pay for. So again, access to the band is absolutely essential. Now, I talked about kind of a pragmatic or a flexible approach. We see that in a number of regions, so specifically the EU and the UK, they're looking at, okay, well, how can we potentially give Wi-Fi access to the entire band, but then do more of a prioritized split so that if IMT ultimately shows up in the upper part of the band, they can get access. And we think that is a very pragmatic approach. It gets Wi-Fi into the full band immediately today. The devices in your pockets will get the benefit of that spectrum. But then if IMT does ultimately show up, we can have sharing mechanisms where ultimately IMT can be used in those very, very dense deployments where it's necessary, and Wi-Fi can get the spectrum it needs everywhere else. Now, this next slide, some of you may ask, why are we talking about some esoteric reconciliation bill in the US? Some of what we're seeing, particularly in the debate in Europe, is quite honestly, this is a very, I'll give a little bit of grace here and say a misinformed set of facts on what's actually happening in US spectrum policy. The reality is, contrary to what some may say about, let's say, a rollback of the US position on 6 gigahertz, the position in the US on 6 gigahertz could not be stronger. There are a number of facts around a recent legislation in the US that's looking at how do we get more spectrum for IMT, and that's an absolutely critical goal. IMT does need spectrum. But what's not going to happen is the US is not rolling back on 6 gigahertz. There's a couple of data points in here. I would really encourage anyone to download. We have kind of a fact sheet on what is actually happening around spectrum policy in the US. But again, the key point here is Spectrum in the US is not changing. These are just a few points I wanted to hit of some other recent global 6 gigahertz spectrum progress. We've seen an opening of the full 6 gigahertz band in the US for VLP. We've seen Canada open up for standard power operation using AFC. And as I mentioned before, the EU and the UK through Ofcom are looking at some kind of novel ways to allow Wi-Fi to get access to the full band. Okay, touching on, I had mentioned about this use case where, particularly in like multi-dwelling units, think of apartment complexes where you have individual apartments, you have shared common areas, pools, gyms, et cetera. There's been kind of an ongoing challenge of how we deliver a more seamless experience through those environments. So as an example, you're in your apartment, you want to print to your printer. That's great. It's easier on a private network. But what if you want to deliver that over shared infrastructure? So where you'd have access points managed by the apartment complex, and whether you're in your apartment, you're out at the pool, you have access to all the same private resources that are on your private network. So the Alliance right now is actually working at standardization around this. There have been some proprietary approaches in the past with pre-shared group keys, where you have a kind of a unique password. It's that typical Wi-Fi experience of simply clicking on an SSID, typing in your password. But now you're almost getting this combination of an enterprise-like network with isolated VLANs, et cetera. So again, you get a private network experience, but through this large area where you have kind of a shared infrastructure. So again, casting from your tablet to a TV, being maybe at the dog park and accessing the network attached storage that's in your apartment. And all doing this with having strong security, addressing privacy risks, and also addressing some of the challenges for the management of that apartment complex. So if this is something that's interesting to you, I would certainly encourage you to participate in the Alliance. Okay, so my last point. I know I'm going kind of rapid fire here. I had 15 minutes. I cannot get off stage like just about any presenter without mentioning AI. I'm kind of getting chuckles from all the other presenters here. But Wi-Fi and AI have a symbiotic relationship. And really we kind of bucket this into two different areas. One is, how is Wi-Fi going to provide the essential infrastructure for AI? Right, so when you're looking at some of the needs for AI around high bandwidth, ubiquitous broad coverage, and superb reliability, Wi-Fi is going to be able to deliver that. Looking at today's generations like Wi-Fi 7, but especially getting into Wi-Fi 8 where we start getting that ultra high reliability, where now these applications can rely upon Wi-Fi to really meet all their needs. In addition, there's a lot of work going on in the Alliance right now in standardization bodies like the IEEE around Wi-Fi sensing. So somebody brought up earlier, using Wi-Fi to detect breathing, things like fall detection. So now the Wi-Fi network is not just providing that much needed data connectivity, but it's also providing a set of tools through AI are able to deliver entirely new applications. Now, what's kind of the other major category? And that we're kind of going to flip it now. So how is AI going to make Wi-Fi even better? So we're clearly going to see where AI is going to enhance performance through its ability to be more adaptive. Now, whether that is more in the management of the network itself, optimizing, which channels that access points are on, or, managing the load of where devices are on the network, or, for some of the things that Cisco is working on in, vector-based roaming, where now AI is able to kind of intelligently tell that device where it should be going. Those are all great examples of how AI is going to make Wi-Fi better. But in order to do that, as we know, AI relies heavily on the usage of data, and actually standardized data. And this is one of the main things where the Wi-Fi industry is actually looking to, and Wi-Fi Alliance specifically is looking to enable this, is how do we develop these sophisticated and standardized data models that are ultimately going to feed into the machine learning that many of your companies are developing. So whether it is understanding what's actually happening in any given Wi-Fi environment in a standardized way, understanding how a client device is actually experiencing the Wi-Fi network and getting that data in a standardized way, into AI that maybe your companies are developing. And most importantly, how do we do this in a way where it's not like data and AI is an afterthought, but as we're developing each subsequent generation of Wi-Fi or each new optional feature that delivers more capabilities, that from day one, it has the data models necessary to support AI innovation. And that work right now is going on within Wi-Fi Alliance. So, about a minute over, did my best, but I want to thank you all for being here and for your attention. And if you're interested in any of these various areas of innovation, I would encourage you all to look into Wi-Fi Alliance membership. Thanks again.
Excellent presentation, excellent timekeeping. I think actually on timekeeping, we have a minute. So if there are any questions for Kevin, we can take one from anyone. Okay, otherwise I think we're good. Thank you. Okay, so next, we're going to talk about applying AI to the connected reality of Wi-Fi networks. So I'd like to invite Jim Palmer from Ruckus Networks to the stage as well. So Jim, to you.
Thank you. So I couldn't thank Kevin enough for his lead-in to my presentation because and I promise you, we didn't actually practice this. He talked about AI. He's talking about how we can, there we go. He's talking about AI. He's talking about, what do we do with AI? He's talking about spectrum, 6 gigahertz. And I wanted to start off, and I'm going to spend a couple of my minutes here talking about what I saw when I got here. And this is what I'm seeing right here in this room. And this is part of the problem that we have with Wi-Fi. You want to complain about the Wi-Fi not working in this facility. This is kind of the reason why. What we're looking at here is the RF. And I'm a radio guy. I know my title is something else, but I'm a radio guy at heart, and that's really what I care about. And the radio part ends up being the weakest link in anything that we do. And it's because it's the one thing that's misunderstood the most. It's the black magic. It's that invisible part. If you only plugged in a wire, you only plugged in a fiber, you wouldn't have this problem. But we can solve this. We just have to know what we're doing. The unfortunate thing is, like Kevin was talking about, when we get into 6 gigahertz, there's so much spectrum. Once you get to 1200 megahertz, we're talking about a lot of channels. We're talking about a lot of channels here. And if you mess this part up, then it doesn't matter what you have on the backside. You can have an AP that has 25 gigabits per second connecting to a core that'll do 400 gigabits per second and 1 terabyte per second link to the internet. But if we mess this part up, it's not going to work. So that's what I want to talk about today. Switch over here to my presentation. And all right, step one of my live demo worked great. So my name's Jim Palmer. I work for Ruckus Networks. I'm the manager of our Ruckus Managed Networks design team. But like I said, I'm actually a radio guy at heart. I've been doing radio for 32 years. It's what I'm passionate about. It's what I care about. And anytime I get a chance to talk about it, I'm going to talk, and I'm going to go for a lot more than 17 and a half minutes. So AI. I'm going to start out, Kevin ended with AI. I'm going to start off with AI. And this is a slide that I stole. So if you've seen a Ruckus Network presentation, you've probably seen this slide. I stole it because there's all kinds of little cool graphs and little things and stuff like that. But let's be honest, when we first heard about AI and ML, right, it was basically a network, it was a buzzword bingo thing. And I can't believe not enough people know this joke, but, when they first asked, they're like, how can you tell the difference between AI and ML? Well, of course, AI is PowerPoint and ML is Excel. So that's basically what it's built on, right? At least that was the joke a long time ago. And I was like, I'm going to resurrect it because I'm an old man. But we're going to have enough PowerPoint presentations, over the, yesterday, today, and tomorrow. So I want to focus on the ML part. My nice little spreadsheet here now. you talk to any engineer, we're going to tell you, we live in the spreadsheets. We like spreadsheets. We have spreadsheets for our spreadsheets. We have tabs and we have all these other things. But there's an inherent problem with the way that these tables are built and the way that this is all laid out and the way that, we have some key fields and then they just go across and they keep going and they keep going and they keep going. And it's great for collecting information on a single thing. But when we have these connected types of environments, we need a different way to take a look at how do we solve these problems? How do we fix this? And so one of the things that Ruckus has done and are doing currently in refining is around this thing called Graph AI. Now, I was at lunch yesterday and I was talking to a lady and she was trying to get me on LinkedIn. And she was like, oh yeah, she's like, we're not connected on LinkedIn. Let me try to connect you in. And so she searched me, and she's like, oh look, here's your name. And the first thing I looked at was next to my name was a number and it said second. And that is a relationship that comes from Graph AI, right? You can be the second, you can be the third, because in reality, we're not just a simple, I know Tiago, or I know, my two bosses sitting in the back of the room who are critiquing me right now. It's like, I know them, but who do they know? And then who do they know? We come to these events so we can network, so we can build those networks. And Wi-Fi is almost the same thing. When I design a network, when I'm doing my day job, I put dots on maps. And then based on where I put these dots on the maps, you get to see your heat maps. You get to see these, oh, this is green, everything's green and happy, right? We all want the green in our heat maps as I'm putting these dots on the maps. Now, a lot of times you'll think that the way I put the dots on the maps is just sort of random, the kind of way it's going up here. And sometimes it is, I'm not gonna lie. But more importantly is what separates a decent network or a not so great network from a really great network is how do these dots interconnect? How do they match? How do they talk to each other? How do they hear? Who do they know? Who are their relationships? Because a lot of times in a building, in a facility, anywhere, you're going to have relationships that you didn't realize that you had. You're going to be like, wow, I didn't realize that this link right here is actually talking to this guy up here. Conversely, you'll think, oh, well, these guys over here, they should be able to talk back and forth, because they're really close to each other. Except that's not how RF works. It's not how RF works at all. And so understanding how these things function and how they work is critical in understanding how they relate. Kevin was talking about Cisco working on a predictive roaming thing. It's about understanding as a client device, and we're going to take a look at that here in a second. As a client device, as a phone, as a tablet, as your watch, as you move through a facility, what direction are you taking? What direction are you most likely to take? It's understanding these relationships that really will dictate how your experience is. So now I'm going to go to my second live demo. We're going to see if we can figure this out. So this is a MDU facility that I was working on. I kind of mocked it up real quick and threw it in here. And what we're looking at here is it's a single AP. It's a Ruckus R770, all the fun stuff. We're looking at the 5 gigahertz. Now everybody looks at that and they go, oh, look at that green. Again, I don't care about the green. What I care about are the reds. I care about the yellows. And more importantly, I care about the pink. Because when we start placing more APs, and we can see this, when I come in and I say, hey, let's see what this AP looks like. Oh, now we've expanded our coverage. Now I have great coverage between those two units, right? We got those in there. But what happens, and we can sort of understand that relationship, but what happens like when we look at this AP, right? He can kind of see it, but more importantly, what is his neighbors? What are his relationships and how do they work together? Because if we zoom out here a little bit, I want to take a look at this AP right up here in this corner. Right? These APs, the one in the corner that my mouse pointer's on, and these 3 down here, when you look at them without the maps, without the colors, you might look at that and go, there's no relationship between the 3 over here and the 1 up here. But in fact, there is. And we have to pay attention to that because we can see right there on the right side of the building, those signals overlap. There's a connection there that we did not expect. And if we don't account for that in our designs, in our configurations, then we can't account for that, and we're going to end up with a thing called co-channel interference. Co-channel interference means we have two APs that are talking on the same channel at a level that they can hear each other. And when that happens, Wi-Fi is very Canadian. It's very polite. It goes, oh, no, you talk. And then you end up going, and then you have two people in a standoff going, no, you talk. What ends up happening is we end up with all this latency. We have this delay because we're trying to figure out whose turn is it to talk. So we can have all this stuff, but if we can't figure out the latency part, so our VR wearers don't end up with, motion sickness, that's the problem. You can have as much spectrum in the world as you want, but if you don't manage that spectrum and if you don't take care of it, then you end up with some really weird things and it doesn't work the way you want. And then you come to people like me and you go, Jim, I paid you all this money for this great Wi-Fi network, brand new stuff, 6 gigahertz Wi-Fi 7, and in a couple of years Wi-Fi 8, and then 7 or 8 years Wi-Fi 9. Why doesn't it work? And it's like, well, because I'm not managing that layer 1 like we looked at the beginning. So the other thing I want to look at here is how does it look? So we can keep adding these in, and eventually you end up with a signal that looks like this, and you go, wow, that's all green, except for the stairwells, because I'm guessing those are concrete. But what if I guess wrong in my design? Now I have relationships that I didn't plan on. I didn't expect to have a relationship between these two APs. I thought that stairwell was going to be concrete, and then somebody said, oh, well, we didn't put a stairwell in there, we put something else. Now my prediction models are wrong. Now I have this relationship that I wasn't counting on. And what do I do with that? Because if I switch over from my nice green map and I take a look at some of my interference maps, that's not as nice and green anymore. And I'll tell you, I did a little thing here to make this look this good on my interference patterns. I turned the radios as far down as I could. If I turn them up to what most people turn them up to, the entire screen will go black or go red. And it'll go really dark red because I have all this interference. So it's understanding that relationship that is critical, because when we take a client device and we put them into our network, right here, and we start to move that device around the network, what we're seeing is we're seeing a prediction of where my device is going to connect based on where I am in the facility. You can see I'm talking to that one in the hallway. If you've ever wondered why we don't like to put APs in hallways, this is it. Because as I move down this hallway, you can see I'm still connected. I'm passing, and this is that predictive roaming thing. I'm passing all these APs that are actually better candidates. And if you could, we zoomed in, I could show you there's a little other little lines that show you where you're connected to. I have candidates, but it's not until I come around this corner that I connect to the one at the other end of the hall. But I have a candidate that's actually probably a better connection in up 1-01. It's predictive roaming. It's understanding these relationships. So that's what's critical. So, cool. My other live demo worked. So let's go back to this. We'll escape out of here. We'll zoom past my backup slides. And we're going to come into here. We're going to talk about why Graph AI is the right AI for RF, because it gives us centrality metrics. The problem with MDUs a lot of times is, we put in a CPE into an MDU unit, and he doesn't really know what he's doing for the other, all of his neighbors. It can see it. It has that RF connection. It knows its RF neighbors, but it's not reporting it to anybody. So it's making decisions based on what it knows about his first ring of connections. It's like making a decision based on only your first level of contacts on LinkedIn or only your first social media thing. And so it's the centrality, it's integration. How do we integrate that? Segregate. How do we segregate it? Where do we have clusters that live that we didn't expect to have clusters? How many people have heard the hospital story about, the Wi-Fi didn't work in this office that they just remodeled, and then you find out that, that used to be the X-ray room and the walls are lead lined, and we got to go put an AP right in that one office. I mean, that's the story as old as time. And so we have segregation that we don't expect, but we can't predict that as well because it takes a lot of time to go measure walls. People don't want to spend the money to do it. And we can use these types of things to understand the resiliency. What happens if we lose an AP? What happens if we lose a switch? Can we design to where we can lose an entire switch but our Wi-Fi stays up? Because for the most part, the Wi-Fi is the internet. We were in our meetings yesterday, and the internet went down, and somebody said, it's the Wi-Fi. And I immediately yelled across from the other side of the room, and I said, no, the Wi-Fi's fine. Just because it was a ruckus AP, I wasn't saying that just because. The Wi-Fi was actually fine. The problem we had was that it was a backhaul connection. It was a backhaul problem. And so understanding how all that is what we can use Graph AI for. And let me give you an example. This is a real-life example from a network that Ruckus deployed our AI RRM algorithm on. And what it does is when you turn it on, it listens for 7 days, and it doesn't do anything. It just sits there and listens, and it learns what's happening. It's like when you go to a party and you go stand in the corner and you kind of survey and you see like who's talking to who knows who, how do these people, how does it all relate, how does it all work together? And what we do is we identify, and here it's shown as a red dot. We identify where there's contention. We identify where there's a problem. We identify where it's going to make our little spectrum graph look like just garbage. We identify that stuff and we say, okay, what can we do now that we know this? We have a centralized place that knows this information. What do we do with it? And so we start then modeling it. And we model and we model and we model. If have you ever watched F1 races and they talk about they use the power of the cloud, and they run simulations on when do we stop to get new tires? What tires do we get? And they're constantly running simulations so that anytime a scenario changes in the race, they immediately know what is their next right decision to do. We do the same thing, believe it or not, just we don't have $1 million steering wheels. What we do is we model it and we mock it up and we go through the 59 channels in 6 gigahertz. We go through the 25 channels in 5 gigahertz, and then we just completely ignore the 2.4 because 2.4 is dead. I'm joking, it's not dead, but 2.4 is easier, but we still model that. And then we build a digital twin and we say, what potential mix of the 3 channels that we use in 2.4, the 25 and 5, and the 59 and the 1200 megahertz of 6 gigahertz, and we say, how do we make this all fit together to where we can have this huge room of people, we can have a huge venue where there's pockets over here and there's pockets over here, can we reuse that stuff? And we can take that, and we can take that contention and we can move it to almost nothing, because again, Wi-Fi is very courteous. So we need to be able to take that, those channels, break them down, and then to go into it a little bit further, we then tell you, why did we do it? So we don't just automatically make the change, because there's a saying in the technical world that, with AI and some of this stuff and things that are automatic, one click to rule them all, one click to crash them all. So we don't just automatically deploy this stuff. We give you a write-up and we say, hey, here's your current configuration. Here's a recommended one. This is where it can go from before to what we're recommending. And then we'll tell you, hey, there's a potential trade-off, because everything in Wi-Fi is a balance. We never get anything for free. In order for me to give you faster speeds, I need a wider channel. But to give you a wider channel, I have less channels to use. So if I need more channels, then I go to a narrower channel, but now my speed's down. So we're always balancing. We're trying to find that mix. And so instead of just saying, oh, we think this is the best and we're going to force it down, we say, hey, this is what it is. And then what you can see down here is the status trail. Hey, we applied it, it's scheduled, and we're making these changes. And then up here, we have a configuration change monitor that says, hey, we made this change. Here was our metrics before, here's our metrics after, changes in the middle. And you go, oh, this one thing that we really cared about took a hit. We went down by 10%, and that's just too much for us. So now I need to revert back. And we can schedule that and we can make it work. Because using AI, we can do stuff like we can take all these different facilities, especially if you have multiple facilities, and we can go from, we had a bunch of interfering links, 10 interfering links down to 4, 18 down to 15. So Pickens Academy here, that tells me that we need to go in and take a deeper dive, because we're using this and we're saying, hey, we have 38 recommendations for these different zones covering, 823,000 possible combinations. This is what we need AI for, not for, telling me or building me a picture of a robot, or a meme or something like that. I need AI to tell me, you got 823,000 possibilities. Can you imagine the spreadsheet on that one? Because I don't want to see a spreadsheet that has 823,000 lines. It's just way too scary for me. I'm too old, I'm too tired to deal with it. So this is the AI that we need to be using, because we can take our networks from looking like crap to looking like something that we can actually use. Because at the end of the day, the last thing I want for you to do as my customer is to call me, because you should be able to use your network and not even think about me when you're using it. So, thank you.
Thank you, Jim.
And I got a minute left.
You've got a minute, and you can have a question from the audience if anyone would like to pose one to Jim. Otherwise, we can move it forward.
I know I didn't explain it that well. I'm not that good. Yeah.
Anybody?
Yeah. Yeah.
Matthew from Zen Internet in the UK. I'm just curious, and I asked this question earlier in the year and last year at Connected Britain, just around 6 gigahertz and vendors taking out the 6 gigahertz with Wi-Fi 7 and just delivering it with 5 and 2.4 in devices as an option because it's cheaper. When do you think it'll become the normal where Wi-Fi 7 and vendors just deliver the whole tri-band at the right price for them, to give it to people, where it becomes normal, where it's implemented and not taken out in Wi-Fi 7?
So there's two factors here. The first one is 6 gigahertz is not a requirement for Wi-Fi 7 certification. So Kevin was up here before, you talk to him, and anytime something becomes optional, that opens up a wiggle room. And the second one is just literally a cost. So we make an AP that it's a Wi-Fi 7, but it's dual band, because we still get some functionality, we still get some features, we still get some things in Wi-Fi 7, but in places like I worked at a place where we'd have these little whole offices in the ground, and there'd be like 3 guys in a room. It's like, do I really need 6 gigahertz down there? I don't. I need 6 gigahertz in places like this, but you could walk around this facility and you could find a little tiny hole that's completely isolated that has 2 or 3 people that need a connection, and they don't need a tri-band AP. So why not do a dual band like we had? Because quite honestly, if you have 2 people and a 80 megahertz wide Wi-Fi 5 gigahertz channel, that's perfect. I mean, for that type of use case, you wouldn't need 6 gigahertz. So it allows me to then offer the facility a whole mix, but it's still the same generation, it's still under the same support, and it'll expire at the same time. So I understand what you're saying. I'd love to have everything, but the other problem you run into is size. The antennas, to try to do, when you think, I taught a class about RF, and it's like you have 83 megahertz and 2.4, you have almost 1200 megahertz from the beginning of the 5 gigahertz to the end of the 5 gigahertz. And then when you add in another 1200 megahertz of spectrum, you now have almost 8 gig of spectrum that you have to make antennas that are resonant for. And to fit that into a device that's smaller than, a small car, gets a little hard. And so there's a lot of, again, it's a balance, it's a trade-off between cost, performance, and all these other things. So, good question, though.
Good question. Yeah, good question. Interesting presentation. Congratulations on a successful demo.
Oh, thanks.
So we've seen that. Okay, we're doing well. So I think we can move forward. So next, I would like to invite Diwakar Kasibocha, who's the CTO from 11 Software, to the stage. He's going to be talking about hospitality and AI, and hospitality and data are shaping the future of Wi-Fi. Okay, Diwakar.
Hello, everyone. My name is Diwakar Kasibotla, and I'm the CTO for 11 Software. 11 Software is the leading software provider in the managed Wi-Fi solution space. We serve one of the top brands in the hospitality space. You see the list here. Our software is used in more than 130 plus countries. We do close to 12 billion connections annually. And then we are, in more than 30,000 properties across the globe. When you think about hospitality, let's start with the simple truth. Hospitality is all about personal connections. When you check into a hotel, you want the front desk to use your last name and address you in such a way. Yet, when an industry where the guest demands high personalization, high amount of seamlessness, how do you do digital transformation and still keep the personalization in place? You want to do the digital transformation in hospitality, but you don't want to become a friction between the front desk and the guest, because you still want to maintain the personalization and the human touch. Imagine that you are checking into a hotel after a long flight, which I think probably 80% of you here have done. Your room isn't just ready, it's personalized. What that means is the lights are dim to your personal setting, your favorite music playing softly as you enter the room, and a virtual concierge providing you recommendations about local experiences based on your past stays. Now, this is not science fiction. This is the power of data and AI. But for us to get there, we must address the challenges of the industry, of the hospitality industry today. Hospitality has been booming post-pandemic, but not without its challenges. Rising guest expectations. 73% of the guests now demand personalization. Instant service response, they want instantaneous service. They want tailored recommendations. If it's your anniversary, if it's your honeymoon, if it's something going on in your life, you want a personalized experience. And then seamless digital interactions. The second is the operational pressures. There's a strong labor shortage in hospitality, and then there is a cost increase, year over year, 14% cost increase, squeezing the margins. And then, of course, staff retention, you're faced with the staff retention, and then the expenses, overall expenses. And to top that, there's a data overload. 89% of the hotels generate data that's untapped. They don't even use that data, and we'll see how we can tap on that data. And this is where the opportunity is. This is where we can leverage the power of data and AI that will boost the operational efficiency by 10 to 15% at the minimum. Now let's look at the sources of data in the hospitality. You have the Wi-Fi interaction logs that looks at the guest movement and also check on the preferences the guests when they are connected to the Wi-Fi provide. You have the IoT sensor network information. We talked about in the previous presentations about the IoT, which is measuring the occupancy and getting the energy metrics. And then you have the booking systems that are identifying the booking patterns by the guest. Now, combine this data, you can easily get 64% faster decisions just by this data. Our platform captures almost 1 billion transactions or 1 billion connections on a monthly basis. That provides us faster insights for the operators, for the members, for our customers to provide deeper insights into the guest performance. Now, data isn't enough. It's the AI that unlocks the potential, right? So now let's look at some of the AI-driven strategies. Now, the first is the targeted campaigns. AI guest segmentation can drive 25% higher engagement. You can use machine learning to detect the microsegments based on their behavior and the preferences. It's a growing area. The second most important one, which is where majority of the investment is going, 73% of the AI budget is going in real-time sentiment analysis. Think about ChatGPT for hospitality. You have all these reviews, customer reviews, feedbacks, posts, interactions on the chats that are being captured and built like a ChatGPT, providing deeper insights and real-time feedback to the guests, and then addressing their concerns. That's a big area for investment. And the third is the intelligent upselling. There's a 40% in conversion rates, higher conversion rates when you have personalized offers. When you are going to a property and you are looking at more opportunities for the guests to be, for the front desk to upsell you, and the more personalized the offer, the better they can upsell. So AI is helping build those personalized offer based on your preferences. All of this will increase the overall revenue by 10 to 15 or sometimes 20% through operational efficiencies, through more better interaction with the guests. Now let's look at the real impact. And this is an example that I'm sharing that we did with a major hotel chain. This is the power of AI and Wi-Fi data. As I shared, the challenge has been that the guest data is fragmented across multiple systems. This is a big challenge in the hospitality space. You have sometimes each property will have its own data. So if there are 500 properties, you have 500 silos of data. If the brand wants to roll up that information up to the brand level and they want to see how what's the performance, it's very difficult, it's very manual. So there were a lot of manual processes involved there. There's, of course, that leads to missed revenue opportunities. Using our platform, we collected all that data. We had added AI on top of it that allowed the front desk agent to spend less time on manual procedures and improve the check-ins by 25%. This also increases the loyalty. The hotels, the hospitality industry is focused on increasing the overall loyalty because that's how they make sure that the guest is returning to the property again and again, or to the brand again and again. So an 18% uplift in the overall loyalty program. And then, of course, saving 12% operational costs. We were using AI to predict the network failure. So as we can see all the information, all the network drop packets, the status of the network connectivity using our platform, we are able to predict when the network packets are getting dropped, when there's a degradation in the service, and then letting the hospital network operator or someone in the hospitality side or the property side to let them know that there's an issue in their Wi-Fi or issue in their gateway or issue in some of the hardware that they have so that they can prevent that failure from happening. And then, of course, allowing a better service on the Wi-Fi. This overall, of course, increased the guest satisfaction. This was kind of the goal of the program. And this is kind of where we were focused on as Wi-Fi as the gateway for data, for the guest data. And I think Eric from Intel also shared that 90% of the network traffic happens through mobile devices on Wi-Fi. And if you look at some of the actionable insights, harness data through robust Wi-Fi. Every guest interaction is a data opportunity. 90% in hospitality, 90% of the data that is collected happens through Wi-Fi. It's everything that they do goes through the Wi-Fi, and that's where, once they do the booking, once they're done with the booking system, that's it. Once they check in at the hotel property, all of the things that are happening is through Wi-Fi. So make sure that you are using the Wi-Fi as the gateway for building intelligent connectivity. Second is prioritize personalization. Again, as I said, hospitality is all about personalization and efficiency. Now, how do you tailor your AI programs, tailor your data programs towards more personalization? This is going to easily give you a 10 to 20% and we have more productivity boost or revenue boost in your system. When it comes to data and AI, start the pilots if you're getting started in hospitality or any other, it's true for any other business as well. Start small, start with pilots, and make sure that security is inbuilt in your program from day one. Security and privacy, which is a big concern for everyone. So make sure that you are baking that as part of your program early so that you can, as you grow your pilots, as you make your pilots production ready, there's a level of satisfaction and you can address the concerns about privacy early on. And lastly, partner with an AI-ready partner who has done this before, who understands this space, either the hospitality space or any other space that you have challenges or you're working on from an AI standpoint, which is going to give you a better ROI. Lastly, I want to, before I move to Q&A, I want to share this quote that someone in the hospitality said very rightly. AI in hospitality is the future, but balance human touch or you risk losing the soul. Thank you.
Thank you, Duaka. Yeah. My arm. Yeah. Can we have some questions for Duaka from the audience? Anybody? Okay, I think you've done a good job. Okay. Okay. So next, we're going to flow into our Enterprise Connectivity Forum, which is going to take form in a panel session next. So I would like to invite some people to the stage. Ivan Muccini from Cloud4Y, who's VP of Product. Hannah Greenberg, CEO from 11 Software. Tim Dyer, Vice President for Global Service Providers and Market Development. And Carol Roth, who's SVP for Hotel Experience at the Accor Digital Factory. Thank you. Okay. Please. Anywhere. I think, so we're missing, is Tim?
I think he's
around. Tim Dyer. Okay. Otherwise, I think we'll probably go ahead then. Okay, so hopefully Tim can join us in a moment. So we're going to talk about Wi-Fi monetization, customer engagement, loyalty, and ROI on Wi-Fi. I think the first question I'd like to ask is, what have you found to be the most effective business models for monetizing Wi-Fi as well? And I'd like to ask, actually, before we do that, let's just do some intros. We have Tim coming as well. Hi, Tim. Welcome.
here, please. Thank you. We can have a space.
Actually, before we jump into the question, I should ask you just to introduce yourselves briefly as well. So we'll go in order. So, Ivan?
Hello, everyone. My name is Ivan Muccini. I'm VP of Product at Cloud4Y. And, we serve mainly enterprise customers providing SPFI to global brands. And actually, monetization is kind of the core of our culture and the mission of the company. So it's a relevant topic for us.
And hi, I'm Tim Dyer. I'm with Ruckus Networks, for those of you who know Ruckus. I run our global service provider business as well as our market development.
I'm Hannah Greenberg, CEO of 11 Software. My CTO is just on the stage. We're a large managed Wi-Fi software provider focused on business outcomes driving from Wi-Fi, specifically in hospitality and the multifamily industries.
Hi everyone, I'm Carol Ross. I'm responsible for the hotel and guest experience for Accor Group and responsible for the connected technology for more than 5,000 hotels in 40 brands.
Thank you. Yeah, so I'm going to ask 2 or 3 questions and then we are going to open it out to the audience. So back to my question about Wi-Fi monetization and what strategies that you've found to be the most effective. So we will start maybe with Carol first.
At Accor, Wi-Fi is key, and I think maybe you travel a lot and you see that Wi-Fi is in the core experience during your stay at the hotel. At Accor, the loyalty program is also key to enroll new members. And Wi-Fi for us, and mainly with the 11 software, we create Wi-Fi for all. So if you're a member, it's free for you to have the Wi-Fi, and you have the best quality of Wi-Fi everywhere into the hotel and, of course, into your room. And right now, so this is the top one business model at Accor that we can enroll some new members for every stay during for one customer. And why is it key? To deliver the best services for our guests at Accor in terms of quality and seamless Wi-Fi. And right now, this is the first one channel to enroll with, we can count in millions of new enrollment in only 1 year. And this is really the top one channel, and we can see this is a direct correlation between also the guest satisfaction and the Wi-Fi quality. So definitely, this is one of the key growth area for loyalty program.
Thank you. Hannah, add to that?
Great, certainly proud of the work that we do with Accor. I think, our observations is that the best outcomes are from a combination of business models. So certainly the captive portal, the ability to have the first point of entry as the guest is arriving to property is important. Those have been around a long time, right? That's not necessarily new technology. I think that's table stakes at this point. I think how you use the technology to drive business outcomes is what we're most interested in. And business models depend on certain circumstances and nuances, but overall, captive portal, the freemium method, upsell revenue, upsell Wi-Fi, better speeds for some price. Like that's not necessarily new. I think it's still important. But the way we look at it is the best operators, the ones that are most successful in driving monetization strategies, are those that use a combination of these models. So a captive portal, potentially Passport and open roaming, although the user experience and UI needs to improve, as I know a lot of the work groups are working on. So I don't think it's a one-size-fits-all. I think it's certainly complicated and nuanced impact, but what we see is if you focus on the business outcomes first, the technology needs to work. That is table stakes. That's a sort of an entry point. Business outcomes will help drive sort of what the end result looks like.
And so in the 11 software solution, is it quite flexible for a customer to select what they want to go after, if it's captive portal or seamless and so forth?
Certainly, many flavors, right? So it depends on the stage of the company, the size of the company, how global it is, right? Diwakar earlier said we're in 140 countries, 30,000 properties in hospitality alone means that you have a lot of different flavors, right? Small brands, large brands, global brands, regional brands, geographies, nuances, type of hardware vendor also matters. I know my friend next to me is going to talk about it. So the point is it's not one size fits all. The ability to adapt and create an experience that is unified, it is driving guest satisfaction, it is driving loyalty, it's driving frictionless connectivity, that's what matters.
Good.
All the complexity underneath, well, that's what we solve for and other vendors solve for. That's what we're trying to aim towards.
And for example, in a large hotel group like Accor, thousands of hotels, probably 5,000 plus, how does that get decided in terms of from a corporate level or at an individual hotel level, the experience that you want to deliver to a guest?
It was decided at a corporate level. We decided to invest in Wi-Fi. So what's the business model? At Accor, and between 11, this is really a contract between one unique hotel and 11, but at Accor level, we invested and we ensure that the quality of service is quite homogeneous. And we invested a lot to provide a seamless experience and unique experience for every brand and every hotel. And this is a third part, business model. We invest a lot because we are truly confident that this is key to provide guest satisfaction and to invest into, to repeat bookings. That's why, and we adapted with 11 at every type of brands at the hotel, and we are looking also for new opportunities like food and beverage, to push food and beverage, for example, new opt-in. But this is what's decided at Accor level, corporate level, to invest a lot to provide this seamless experience. And we can already see that we have a positive feedback and ROI.
Good. Thank you. Tim, anything you'd like to add?
I'll add 3 words: mobile data offload. So another area of monetization that we see quite emergent in the space, specifically for large carriers, and as we see in the United States with some very large carriers, is that ability to offload to Wi-Fi. And you saw Kevin's presentation earlier said something like 75, not something like, he said 75% of all data carriage for cellular is done over Wi-Fi. We've seen our customers, Comcast specifically, said it's as high as 90% for their network. And when you look at the cost being roughly a quarter to carry over Wi-Fi, it's a pretty compelling business case. So yes, we believe in our underlying technology, but we also believe that we're here for a purpose, and that purpose would be to be a pusher maybe on of some things. And in this instance, our carrier partners such as Comcast, Charter are saving considerable money, number one. And then number two, I'd say that that we have a huge market in front of us. We've had Wi-Fi 7 outdoor equipment out in the wild for almost a year and a half now. So we have great telemetry, great information, great analytics. So now we know exactly where to put these devices to maximize that ROI for our partners and customers.
On the mobile data offload, familiar with it very much so in the United States. How much do you think that's taken on or been taken off outside of the US?
Well, we're starting to see more and more of it. My partner in crime here is in the audience. And we're seeing more in now Asia, so Singapore specifically. We have 3 trials where we're actually testing convergence, a convergence application. And convergence to us really is that ability to transition from Wi-Fi to cellular and cellular back without any blips. So I don't want to lose my Teams call when I back out of my driveway. And I know we talk about people statically. The world is anything but static now, as I think is evidenced by this room. We're from all different countries, actually, the 4 of us. So as an example, and I think that transition, the mobile consumer, is just such a critical component of what we do going forward, and even as we talk about the future.
Ivan?
Well, I agree with Dan. There is not one single key monetization strategy that works across the board, and I think it differs mostly by vertical. Like, for example, we don't do much hospitality, primarily commercial business, like, for example, retailers. And even inside that vertical, there are different deployments, different scenarios where we could find, and we actually found different monetization models. One of them is actually mobile offload, or high traffic venues with a lot of connections that might be monetized through advertising. For example, there is a lot of attention from retail media networks right now. But most of our customers, especially in retail, we found the most effective way to drive value in the data. And data comes in form of reports and analytics, insights that can inform better business decisions, but mostly in terms of customer data, because in these verticals, right, they have a lot of investment in digital marketing, engagement, programs, but you need to have customer data, right? And so consented customer profiles that can be fed into the marketing machine, where digital marketing teams know how to monetize that data, and then close the loop through, loyalty and leading to better conversion and spending. And it's quite quantifiable and very effective in retail. We have most of our customers, this is a use case. Although, not everybody is ready to deploy this kind of model, because you need at least to have the practice in place. You need to have a digital marketing practice or a loyalty program, and being able to go beyond, newsletters, right? You need to really embrace the personalization that this data can deliver. But this we found in our customer base being very, very successful.
Do you sell the data separately as an add-on, or is it embedded in a service that Cloud4Y provides?
Well, we just provide the technology, of course. We're just a data processor, right? We just provide this technology stack. Our customers own the data since the beginning, so it's the core of our value proposition. So we spend half of our time talking with marketing and digital teams rather than IT departments. And so data is part of what they gain by adopting our survey. So it's included for sure.
And so I have to put this question to Carol in terms of data and how our core group are using data about customer or guests in the hotel. Is that something that you're actively doing or?
Yeah, but we still have room for enhancement, definitely. So we started more than a year ago this Wi-Fi for all project. Of course, we're collecting a lot of data, but we need to add some new tracking, maybe, to collect maybe if we can say new opt-in, if we can collect also that one customer can go from one hotel to another, so we can really track that there are repeat bookings and through the Wi-Fi, for example. One of the opportunities also to connect to the direct PMS, property management system also, maybe to anticipate better that they are coming to the hotel and maybe to track and to push and personalize maybe what we can push through the Wi-Fi if they are open to food and beverage and so on. So maybe to connect better with the beyond room. So to anticipate, recognize, and to really have this profiling for our customers through Wi-Fi. We can do it, but we need to develop as we are going through the deployment of the Wi-Fi. But definitely, data is key, but we still need to build the structure and to get all of the touch points to better collect it.
Thank you. So just moving it on a little bit, I want to talk about customer loyalty and specifically in the area of quality of service. So what the impact of providing a high quality seamless experience to guests, what impact does that have on engagement and on retention?
Three things. Definitely on guest satisfaction. I think everyone in this room can say, oh, Wi-Fi is not working, and you have a bad experience into the hotel, and you will remind it. Definitely Wi-Fi is like, if you're connecting directly to the Wi-Fi, you can feel like home. And definitely through Wi-Fi for all around the world, within each type of the hotel of Accor, we need you to feel at home when you enter an Accor hotel. So definitely you can provide guest satisfaction. Second, it's a question about brand perception also. If the Wi-Fi is seamless, it's like a feeling of excellence. So definitely we can ensure for even luxury, ultra luxury, we need to provide a high quality Wi-Fi to our customers. So definitely guest satisfaction, brand perception. And we can see our ROI because we have a CSAT of the Wi-Fi for more than 85% of satisfaction. And again, I mentioned it, we can see a direct correlation between the guest satisfaction for the stay and the Wi-Fi quality.
Tim, I'd like to put the same question to you. Obviously, we had the presentation earlier from Jim on AI and how that's being impacted, but anything to add?
On this or on Jim's?
On this.
On this topic? You look at Wi-Fi and everything connects through Wi-Fi now. And as a consumer, in fact, we were just talking, I'm staying in one of your hotels. As a consumer, obviously that's critical to me. Again, I go back to this mobile workforce. I can't be on calls until midnight with the rest of the world unless I have an adequate network in place. And it's not just the network for consumers. You've got all your back office that operates off of it as well, and we understand that's equally as important. So I'd say that it's really ubiquitous. I don't view it as a utility necessarily because I live in California. The utilities in California don't operate quite as effectively and efficiently as they do in other parts of the world. So you get what you pay for in some instances. In California, we actually don't get what we pay for. But not all utilities are created equally. And this is where I would argue that the foundation of what you put in place as a ruckus guy becomes really tantamount to what you get as a result for your customer satisfaction. So that's a great statistic, though. I hadn't heard that before.
Okay, Hannah, what do you see in terms of your customers and what they ask for?
Yeah, absolutely. In terms of the guest satisfaction, 85% is incredible. We've seen that those who have like a unified brand experience when it comes to Wi-Fi have seen an improvement of 20%, right? Wow. From non to using. And that's impressive. Brands are good at surveying us, right? We always get the email or in the app, right? Especially for loyal customers. So that data, I think, is important. I think also what maybe we didn't speak about is the reduction in time that front desk agents or employees have to focus on Wi-Fi related issues allows them to focus their time on driving better engagement, better customer experience. So the net savings, right, which is again like 10 to 15% of time, allows them to do higher value tasks like going above and beyond and delivering the guest satisfaction. In the hospitality use case, it is the personalized touch. No matter how technology evolves, it's still there. And so I think that the cost savings and the time savings allow operators to do a better job of delivering value in other areas, which as common travelers like ourselves, we expect these days. Like we're all high maintenance in our own ways, and I think that allows us to deliver just better in other areas.
Yeah. So I'm going to ask one more question, and then I'm going to open it out to the audience. And I want to focus a little bit on ROI. I don't know if Accor has a saleable service in terms of the Wi-Fi when you go to one of your hotels, but how do you measure the ROI on your investments apart from the direct revenue that you're getting back?
So, as I mentioned, in our business model, we focused at Accor Group on the enrollment. So we are tracking if they are repeating the booking or not. And you can see that the Wi-Fi is really the main lever to enroll new customer guests, maybe from OTA, from Booking, Expedia, just entering the hotel, and to capture that value and to enroll them. So we are tracking at first the fact that this type of new member enrolled through the Wi-Fi will repeat the booking. So this is the number one ROI that we are tracking because we are investing a lot at Accor level. Hotel also are contracting with our provider, 11. So this is a common effort and we are tracking this ROI this way because one loyal member is really, it's maybe twice the value of another member. Second, we are also pushing some new opportunities, again, through opt-in and the fact that we can push some beyond room revenue. So through the Wi-Fi portal, we can push also some upsell. So we can and we will measure this type of additional revenues, new ROI. And we need, as you mentioned, also to track the fact that we are gaining operational efficiency through the Wi-Fi, but we didn't put in place through the support and other type of measure that we will gain in this type of area also. But just to mention, we deployed the Wi-Fi also and this type of Wi-Fi for all at the headquarters of Accor to deploy this type of operational efficiency also.
Thank you. Hannah, Tim, Ivan, anything you'd like to add? I know, Ivan, you have I guess from cloud provider's perspective, a very sort of broad experience in terms of different enterprise verticals, but what do you see?
Yeah, as I mentioned, for example, in retail, as I mentioned, most of the value comes from collecting and activating customer data, again, and this could be used in different ways to nurture customers during the loyalty adoption, and the ROI is quite clear. 3 weeks ago, I received an email from a customer of ours, an international wine company, that we didn't even have to evangelize where the ROI was. They actually stated to us this: in the last 3 months, we collected this amount of contacts. 80% of them were new. We didn't have those emails. 85% of them gave us the opt-in to reach down them with marketing communication. So our digital marketing team nurtured them as they usually do with campaigns. 7% of them bought products, wine tasting and memberships. And this generated 6 times the video, 6 times the cost of our service. And so they said, we are good. The ROI, it's there, right? But there is also another component to ROI. So, there is the value, but there is also the cost, right? And so I think also reducing the overall, augmenting the efficiency, reducing the cost for running these services is essential. And this is where we are spending effort in implementing AI in our workflows to make sure that, rolling out and maintaining these services is actually effective and actually seamless and requires less and less human intervention. So, there's two parts of the equation, but the ROI in this case for retail is quite clear.
Yeah, it's very interesting.
And I was going to say, I love both Hannah, Carol, and even what Jim had brought up on the panel. Such a great point. I'm at a front desk, right? And I'm working the front desk now. I'm on the other side of the desk. And the last thing I want to worry about is two guests and their co-channel interference. If that problem takes care of itself automatically, I can focus on my guest, right? That's right there in front of me. And I think it's such a great point. I want to take notes, actually. So thank you.
I'd also add that every enterprise has a value that they ascribe to a loyal member or a loyal customer. The hospitality space, we see it, I mentioned 15 million enrollments per year. Each brand, whether it's $5 or $100, which is typically the range, it's a wide range, but it depends on sort of the tier level and the location. That value, if you do simple math, like take $10, that's a lot of money, right? That, on an annual basis, that's $150 million of value that they ascribe to it. And that is because those customers book more frequently. They book direct. They're telling their friends and family. They're spending more. They're going to the cafe or the bar or the restaurant, whatever that may be. That's substantial value. So it's not surprising that brands are investing so much money in these types of programs because the math is pretty simple, right? No matter what, chain scale or what location, it's pretty easy to understand the value. I'd say the other thing in terms of the net savings and operational efficiency is that that's above and beyond, right? It's harder to always measure cost reduction than revenue generation. But as a whole, I think that it manages expectations to what you're trying to achieve on the business outcomes and also what the guests are going to improve in terms of what they're looking for as a stay, right, as a customer. So for us, we see it as a case study that just continues to repeat itself as a success story.
Very good. Okay. We have 10 minutes, so I want to turn it out to the audience and see if there are any questions. Dr. Angelos.
Thank you. Well, I have two questions which rather could be answered by the left side of the panel. The first is that I have been using Wi-Fi in hotels since more than 20 years. Today, I stopped using it because I connect my laptop to my smartphone because I do not trust who is listening to my data on the air interface. So, and I don't know whether the name of the Wi-Fi which reaches my room or the lounge is the official one or it's fake. The question is, how can you protect the customer of this kind of attacks? Because data on laptops and smartphones completely today are very important. You do not exist without this data. The second question is, if you collect the information of a customer across different hotels or locations or countries, how do you get the consent of the customer that you can collect and use this data?
Okay, so
I will answer. For the data protection, I will ensure with my main provider and partner. But for the opt-in, of course, we are collecting really your opt-in that we can ensure. And again, at Accor, and 10 years ago, maybe the politics were a little bit different. But right now, we truly understand that it's not interesting to push a restaurant, for example, a new option to someone that don't want to be reach out. So definitely we are asking you for your preferences and if you're okay to have this type of communication. So we are really careful with all this type of collection of data. And on security, maybe I can rely on my main partner.
I can start, but I think that safety, security, compliance is in a network like a hotel, it's pretty complicated, right? We are the software provider. We have the hardware vendor. There's also the internet provider. There's the brand with the consent and sort of the brand standards. Like, it is a multi-group, solution, and the dedication to ensuring security is top of our list. Certainly, I know the top of Ruckus's list and top of Accor's list, and in that case, whoever the internet provider is needs to be top of their list, complying to SOC 2, GDPR, all the requirements. But if any of the sort of pieces of the ecosystem fail, like, we all fail. And so I'm not sure what peace of mind that gives you, but as a traveler who travels all the time, understanding that the vendors involved have a high level of scrutiny and high level of compliance, like, that's sort of what gives me peace of mind. I don't know if you have anything to share to that, but.
Yeah, I'd suggest that when you connect to Ruckus networks, we have keys, encryption, tunneling, so a variety of mechanisms to ensure your security, as well as data that's supposed to stay local will stay local, and really, that's
and maybe
from
if
a
I
technical
can
standpoint.
add something, we are more confident at Accor level to have this type of partnership, because we can discuss, we can secure, we can test this type of security, compare maybe to each type of hotel going through main provider, other providers. We can really ensure that we can work together to provide the best security and protection of data to our customer.
And I guess I would add that we, like a lot of manufacturers, have ongoing security practices. So open source vulnerabilities, CVs that need to be incorporated into our software stack, we do on a regular basis, and make sure that those are available to be automatically pushed. And these AI toolkits are even a better mechanism to do these things for us without human intervention.
Ivan, because you mentioned about obtaining people's consent as well, but go ahead.
Yeah, of course, I think everybody take care about the consent collection of things the proper way, and that's not a problem if done properly. On the challenge of the security of the network, I bet you will be more confident connecting via Passpoint or open roaming if you could, right? And I think there is where the industry is trying to make progresses in evangelizing and adopting throughout the ecosystem, onboarding channels and practices that can make sure the guests can actually connect via this medium, like via Passpoint, or maybe through your more loyalty mobile app, for example. But you need to connect also via your laptop, right, when you are in the hotel. And so how do we make this possible? So there are still some challenges in transitioning completely to more secure way to connect to the network, including Passpoint-based or open roaming. There are some technology foundations, and I think some brands are actually attempting to introduce, even in the hospitality industry, Passpoint-based connectivity for loyal members, at least on their mobile apps. And this is at least a step forward. And throughout the industry, I think we need to make efforts to try to adopt more these new technologies and embrace better security that ultimately delivers even better experience to customers, right? It's seamless, secure, automatic. So we all know that, and we just need to make it happen.
Okay. Can we ask you what you're doing on your laptop? That's right. Dean, you had a question.
Hi there. What happens when the customers, whether it's their devices or a third-party software app like an AI tool, are essentially creating AI agents for accessing the Wi-Fi in the hotel? So if you have, in a couple of years' time, for example, an agent on your phone saying, connect me to the Wi-Fi securely and anonymously, as the intent, and that then gets translated against whatever, whether it's a captive portal or open roaming or anything else, I've then expressed that intent to my AI agent. Are you preparing for that world? Because if not, you should be.
Well, I guess there is still some work to do on that end. It comes back to the point of making sure devices know which is the safer connection to be used and what are the challenges of the open connectivity. For example, most of the devices, iOS, Android, or the other systems, they have some sort of embedded kind of security measures and prioritization of the network, so they tend to prefer to connect to certain networks. But that's not standardized at all. That's still the decision of clients. So there is not really standard we see to make that happen. But I see the challenge is real, and so again, we need to work on that.
And I think it's actually going to get worse, because AI today isn't just going to a big data center, a multi-trillion-dollar data center in the sky. AI is going to be distributed compute, right? And it's going to be federated distributed compute that we're going to have to secure. So I think there's a ton of work we have to do.
I mean, where I'm going with this is thinking, first off, I want to have an agent look for what is the most secure and private way to connect. It's like, and so if it's Wi-Fi, which it involves switching off a VPN, no. If it's Wi-Fi which is trying to capture my data, definitely no. And if it's got some ridiculous captive portal, then it's not just no, but then post on social media naming and shaming the venue. And I will set up an agent chain to do that. And I think that we're inevitably going to go down that world where friction becomes a cost.
Sounds like you should be part of the work group.
Yeah.
George, we have about a minute and a half, so go ahead, George.
Okay. Yeah, first of all, I would comment in the present world, there's still a lot of work to do on the link between the reservation systems, the loyalty programs, and the Wi-Fi sign-up. Should be a one-step automatic process. I led the WBA's working group this year on a large survey of the entire landscape of the MDU connectivity issues. That white paper is ready for members now and will be revised as we go forward. And we would invite anybody to join our work as we continue that effort on trying to solve some of the issues. But for the hospitality folks, Hannah, I guess this falls into your purview. You talked about getting into residential, getting into multi-dwelling unit types of things. What are the learnings from your work in the hospitality market that you can think will bring added value to the MDU space?
Great question. Yeah, I would say the MDU space is maybe 5 to 8 years behind where hospitality is, which is a good opportunity, long runway, highly fragmented, low penetrated, and managed Wi-Fi. So all the things that maybe hospitality saw maybe even 10 years ago. What we see though is that, although the customers are different, the sales cycle is sort of different, the same travelers, right, that are traveling hospitality are those also digital nomads or those generations that are very invested in staying in living in an apartment, right, traditionally. And so what we've seen in the multifamily space that maybe can be taken from hospitality is that, seamless Wi-Fi, good connectivity, being able to roam throughout the property, private network, single, VLAN at the unit, right, at the apartment versus the hotel, the ability to go to the gym, the ability to go to all the communal spaces without dropping, whether you're on a Teams call or et cetera. Like, that's sort of the same in both industries. I think the unique part about in the MDU space is the monetization model is a little bit different, right? And so there you have owner and operators, like the large ones, like the top 50, that are wanting to own the infrastructure, right? Not only just the CapEx investment up front, but also the ability to create additional NOI for the property, right? It's no mistake that there's incremental value, right? The cap rates are lower when you have a property that has been configured to sort of today's age in Wi-Fi infrastructure. And so I think the monetization model is a bit different in MDU. I think there are more opportunities for the owner and operators to monetize it, different than a hotel brand, right? Because you have a transient customer versus those that are a year or so at a time. But the foundations are the same. It will be interesting to see what happens as this next wave of greenfield properties hits the market. There's been this huge construction boom in the MDU space. Once that sort of settles down and you have all this new inventory, what that product looks like and sort of what the expectation is for a standard tenant who rents an apartment on a monthly or annual basis, I think the standards will continue to grow. And I expect that those customization levels that you expect at staying at a 3, 4, 5-star hotel actually do trickle in to what you expect as a tenant in a Class A or Class B apartment building in any city, secondary cities, tertiary cities included. So I think that unique sort of wanting to have high standards and then the monetization model, there's a lot to look forward to in the MDU space, but we are a little behind.
Thank you. Okay. So we are into the red. So I'd like to thank Ivan, Tim, Hannah, Carol for being on the panel today. Can we give them a round of applause, please?
One last question.
Tiago.
Sorry, we have to let Tiago take us through.
That's okay. So just a quick comment and then a fast question. So first a comment, Carol, big customer of Accor Group, member of your loyalty program. I want to share that we did an open roaming demo in one of your properties over the last days. We had our members meetings in one of your hotels. Thank you as well to Records and all the teams involved on setting up that demo. And I can share with you that I felt at home when I arrived to the hotel, very close to midnight on a Saturday night, very long date for me, and I just connect without talking with anyone. I was safe, secure, wonderful experience. I will speak by myself, but I believe the rest of the members really appreciate it.
Thank you.
The question, please share any gaps or challenges that you see on the hospitality area for Wi-Fi that you believe organizations like WBI, we can bring the community to try to solve it and join forces to address those gaps.
I can share maybe, but the main challenge is the fragmented market, definitely, and we need sometimes to convince each part of the group in each type of territory, and maybe sometime on technical level, technical and sometimes prices also, because if we are entering some other market, other countries, price is still a question sometimes, and we need to invest a lot at Accor level to ensure that they are going with this type of solution, because quality is a price. So pricing, definitely. And second, to convince that we can go in an unknown solution sometime in type of market. So definitely fragmentation and pricing.
Yeah.
And I was just going to say, just to address pricing, we understand that not all brands are created equally, and even within your own brand, going down market is going down market. And Jim had mentioned a 2-radio Wi-Fi 7 offer that we just recently created with that expressed intent to lower costs. So we understand sometimes you have to strip, the seats and cushions out of things to get them to the price point, the desired price point, and we understand that. And I think we're seeing also, just overall in the market, more price pressure in the introduction of Wi-Fi 7, because we saw, 1 billion devices this year we anticipate going to Wi-Fi 7, and we want to encourage that adoption because latency, even as we talk about AI use cases, that federation is going to be all about latency, and the weakest link in these networks that we create is going to be the thing that trips up your reservation, your supply chain, et cetera.
I'll just add one thing. We've been talking about Passpoint for 10 years in hospitality, and there's not really a great proven use case yet for many reasons. And so I think that this group and the WFA, there's a lot to improve and figure out that in a complex environment that is global, that is multinational, that is fragmented, and has issues that Carol suggested, if we can come up with a solution that actually works to improve the guest satisfaction, the guest experience across all generations, all types, all backgrounds, all languages, et cetera, I think we will be in a good spot. But it has not been adopted for a reason, and I think that is that's where we got to focus on.
Thank you. Okay, so I think that brings us to the close. So again, thank you.
Thank you.
Okay, welcome everyone to the first afternoon of Wireless Global Congress. My name is Bruno Tomás. I work as a CTO for the WBA, so I'm lucky enough to work with some of the brightest minds in our industry, and it has been, quite a ride. So just these 2 days, we have been driving our 6G work group. We announced the new Wi-Fi 8 working group as well, in light of very successful Wi-Fi 7 trials that were delivered to the market. But there's more. So today you will hear from some fantastic speakers that we have on our agenda. We'll start with standards perspective with Lily from WLAN Application Alliance. We'll have Andy Goins, who leads our policy working group. Then we'll have Chris Szymanski talking us about the next generation of Wi-Fi. A bit on real-time network and value-added services from George Paredes at WOM6. And then a panel that I'm sure you don't want to miss because we'll span across public, residential, enterprise, Wi-Fi, and what are the opportunities to effectively scale next generation of Wi-Fi connectivities. With that, I would like to move on to invite our first speaker, Lily Thomas, Chief Scientist at WLAN Application Alliance. Thomas, over to you. Thank you. Thank you so much. Okay.
Good afternoon. I think it's my second time here to make speech. Last time is last year. It's the same, exact same place. I'm wondering in this room how many people can recall my last speech, but I'm not going to the investigation. So the topic is focusing on best WLAN experience. That is a mission of the World WLAN Application Alliance, which I'm representing. It's very easy to understand that the Wi-Fi is the cornerstone of the digital world, but the WLAN is majorly focused on Wi-Fi experience, but also may cover other short-range technology, communication technologies as well. But not now, because WLAN is a very young organization that is established in the year of 2022. It's only 3 years old. Now, we can call that we are going to Wi-Fi 7, Wi-Fi 8, but the technology is very advanced. It's more and more advanced, but actually the issues keeps the same. Like a limited coverage. Coverage is always a problem, of course. And insufficient speed, bandwidth, people will say no, but actually in some scenario it is true. And also unstable network performance is happening all the time. Poor interaction experience when you're playing games. You have some latency jitter. It's very bad because you may lose the game. And also the poor seamless switching and the high security risks, especially we, like a company, have a meeting in the hotel. It's somehow not very much secured. So what WLAN do is that, first of all, build a platform that everybody can come and to discuss on how to solve these problems. And also, we can establish the scenario-based WLAN performance and experience standards and certification. And finally, the target is build the best WLAN application experiences. So, if we look at our members, that's dramatically we're going towards 100, even in a very short time. It's a very complete ecosystem that we have chip makers, Qualcomm, MediaTek, HiSilicon, Realtek, etc., and also equipment manufacturers, terminal vendors, and also major telecom operators and other different kinds of players. It's a very complete ecosystem. So the alliance is doing the ecosystem building, and also depending on that have industry integration to provide values and also a commercial enhancement to the members. This is the business architecture here. We can focus on the low level of the key resources. That what we do is the standards, of course, a lot of standards over there, and also the certifications, systems, and also the industry connections to other organizations, other societies. And after last presentation here, we go forward for 1 year. I'd like to first report what we did in this recent 1 year. We published 3 new research reports or white papers. One is focusing on the campus, One is focusing on the summary of the advanced user experience, and another is about the industry scenario that how to utilize the double lane. So, what's the challenges of industry facing, especially when we are trying to define the experience standards? First of all, in the past, basically we are all device-oriented, that we all around the device to define the standards and define the certifications. But if you're going to the user-centric, it's a very few things did in the past. But if you dive into the user-centric experience, it's very hard to quantify and to standardize, because the user's subjective experience is very much diverse. It's not easy to define and let everybody agree. And also, the performance expectations is not the same. And also, if going to the scenarios that we can find out, the scenarios is very much diverse and very complex, very uncertain. So how to test to cover all the diverse scenarios and experience is very difficult. Finally, if you're going to real testing and certification, that we are lack of tools. Existing tools never exist. So we need to develop new things, and the real-world environment simulation is very difficult to have equipment. Simple equipment cannot afford that. So what we did is that finally, in 3 years' efforts, we already have the end-to-end complete specifications and certifications of the home scenario. We split this scenario in 3 parts. The first one is for the compact homes. The second is the medium-sized homes. And the third one focuses on the IoT devices. The whole working method is that, first of all, we are going to define the scenario. And secondly is to, depending on the scenario, we define the KPI and KQI. So after that, have consensus, we go into the test, and then follow up the basic performance test, and then most important and the most difficult part is service experience testing. So what we do for application, for example, when we have working in the home or do something in the home, there is several things, playing games, education, or surfing the internet. A lot of different applications, they have different kinds of requirements, especially from the user experience. So we convert it into the 6 dimensions. That is the roaming, connection, coverage, latency, security, and bandwidth. But this is only performance. It's not finally the user experience. Okay, so we will find out the KPI and the KQI as all these 6 dimensions. And how many standards we have right now? Last year, when I made the presentation, is no more than 20. But this year, we have very big progress. We are going to publish, we already published the 36 standards, and the 6 ongoing. But people will ask why we need so many standards. Because the scenario is diverse. For any scenario, any sub-scenario, we all need define the experience. And also we all need to specifically for some kind of specified application to do so. So this is a consequence is that I don't list everything here. It's we have 3 dimensions. First one is focus on what features that surface availability, green, and security, and performance. And also it targets on the network devices, terminal devices, and the system as well. And finally, we have the scenario dimension that is, we have industry, campus, everything. So this is why it's so complicated. Another great progress is about the certification system. Last year, we only defined the process. We don't have qualified certificates. At that time, we have some candidates, but don't sign contract. But right now, it's complete. We have a CI/ATI, China Mobile, and a two right line together with authorized testing labs, and also with CQC as authorized certificate deliverers. Another big step is that we build very strong relationship with IEEE SA, especially 802.11. That means everything we do in WAA will become very possibly during the relationship could become the input, requirement input of the 802.11 for the definition standards of file level and MAC level. And this is a very big step we have that China Mobile announced that they will adopt the WA certification as a preposition of become their provider. So, you know, China Mobile is doing many years the massive deployment of the Wi-Fi AP to the home and offices. So the acquisition number of the APs is huge. So this is very big progress out there, and we are expecting more to adopt the WA certificates. And this is something new that new things that we had a workshop in the last year, September, that expanding a new direction that is sensing, integrated, empowering a new campus future. So that means we define a lot of things that because Wi-Fi now is going to do sensing as well. You know, in 5G we have ASEC, the integrated sensing and the communication. The Wi-Fi can do the same thing, similar thing. So we defined, in this workshop we defined several scenarios like building green energy, like intelligent conference management, like the smart medical and the elder care that everybody, you know, every home have family has the elder people, very easy to fall down and to be hurt very seriously. If they cannot be served instantly, it's going to be a disaster. So this is also very important. And also campus dormitory management and hotel room management, supermarket customer flow analysis, and industry safety management. This is all in the smart spaces that sensing can do something here. AI is a very important thing that we released in this year, May, about in Brazil, of the new white paper about how to integrate AI into double lane and to support the industry. I'm not going to read all the details. You can get the presentation later. And also we are also doing something around the spectrum. Now spectrum is more and more complex, like in the 2.4 gig to 5 gigahertz to 6 gigahertz. And now we have 6 gigahertz. There is a problem of using the spectrum, and also in different release of the 802.11 like AC and AX, they may have some uneven way to get the resource. So this is also problems when we identified in the using models. And also in the future, what we're going to do is new things. First of all, is the sensing technologies. When using sensing technologies in Wi-Fi, we have some advantages. First of all, is a zero hardware cost, and also we have the wide coverage. This is just in the coverage scope of the Wi-Fi APs. If Wi-Fi is there, we can sense. And also the low power consumption and easy operate and manage, and high compatibility wide adaptation. We are going to focus on the 4 scenarios: smart home, smart factory, smart campus, and smart healthcare. And another technology also attract our attention is that there is a network terminal collaboration. This is very practical technology that can improve the experience and the efficiency very much. And is not only working on the home, but also in the industry scenarios as well. Our next step is going to be standardized. You know, the technology like AI and a network terminal collaboration, in the traditionally we can say it's implementing technology, not a standard technology. So you don't need, in some cases, you don't need to define protocols, but actually the boundary is vague. So we need to explore how much we can do here, how much we can standardize, how much we don't, that is to be innovation. So we are going to explore in this area. Green, of course. WA is not going to, don't have a plan to standardize green topic, but we will continuously have the conversation, discussion in the whole process. So we launched this topic, continuously discussion in the alliance. And finally, it's very important that we will build the strong connection with our partners, like strategic partners with HVAC, 802.11 as well. WBA, of course, this is the platform, and British Standards Institute, Hong Kong Quality Assurance Agency, Wi-Fi Now, and Samina. We were going to build more connections with other industry organizations and societies. Finally, ongoing the next step events. You got the invitation. Next month, November 6 to 8 in Shenzhen, there is the first Consumer Electronic Innovation Congress is holding. I'm going there. This is WA is one of the major hosts of this congress. It's including expo, seminars, workshops, everything. So the plan is going to build this one to be the top consumer electronic congress in the world. This is the beginning. And you all know that in Shenzhen is a city that already have a lot of top-level technology companies over there. We already have very strong ecosystem and a strong support of the local government. So this is a major one, and we expecting is going to be a big one in the world. And also, in the next year, co-located with NWC in Barcelona, we will have the 2026 Global AA Industry Forum. Also, everybody here is invited to join us. I think this, I hope I'm not, maybe I save some time. So this is all my presentation. Just one more thing that maybe not everybody know. The organization WAA is very new, is a chart, but it's going very good in its progresses, and it's spending very well. And thank you for your attention. Thank you.
No, thank you so much. Yeah, definitely, lots of work. Let me just ask if there's any quick question for Thomas. There's one in the back. And Thomas will join the panel later on, so let's take one, and then you can think on anything you would like to get from Thomas as well. So it's right there on the back.
Thanks a lot. A question, there's been lots of rumors recently about China and lower 6 gigahertz. Asking is, does WAA have a policy around what they would like to see in lower 6? And what is your view on the evolution of lower 6 in China?
Yeah, it's a good question. 6 gigahertz, that I think Wi-Fi society is very much concerned about. I heard the previous speakers in the morning said, I think it's from Intel, that gentleman. This is very important for expand the Wi-Fi's boundary, and it's very important because it's very difficult to find clean spectrums.
Yep.
Right. So from the point of view of WAA, we very much support the 6 gigahertz. But what's the policy of the China government is another thing. So I think we need to have more communication between the industry and the government to coordinate how to go forward. Right.
So hopefully November or March, aligning with your events, we expect an announcement. So
Yes.
thank you again,
Thank
and
you, Bruno.
we'll join later. Thank you so much. Okay, let's move on. I think, being in Europe and, spectrum is always a hot topic. So I would say no one better than the WBA co-chair for the Policy and Regulatory Affairs Working Group and also the team leader at Cisco for these topics to tell us why 6 GHz matters for Wi-Fi 7 and the upcoming Wi-Fi 8. So Andy, great to have you and looking forward to knowing more. Cheers.
Which way is forward? Green? Oh, okay. Okay, so one thing I'm going to say today is I'm looking at enterprise here specifically in the 6 gigahertz band. And predictable Wi-Fi is the future that's going to happen in enterprise. We're already seeing that today. There's customer demand. So 6 gigahertz is going to be the key for that. And actually having enough spectrum for that is going to be the key. I think I don't need to go through this message. It's already been put by a lot of people today. Wi-Fi is the workhorse of any connectivity, wireless connectivity today. If you look at the way that the kind of data is actually going up on the fixed networks, we've got 80 to 90%. And even if you look at smartphone usage, Wi-Fi is king when it comes to the usage, even in the smartphone, at least in Europe and the US. Maybe slightly different in China. So in the wireless first world, which Matt went through this morning, most traffic's going to be indoors. Enterprise Wi-Fi needs more spectrum and more predictability. And you need enough spectrum to be able to provide that predictability. There's a lot of different uses we're going to see out there. There's also a lot of peer-to-peer stuff coming in that we've not really experienced yet, from your phone to your headsets, etc., which isn't going to be part of the enterprise network. It's going to compete for spectrum with enterprise networks. So again, we're going to see that competition in 6 gigahertz and even Bluetooth and some 802.15.4 derivatives now are looking to use 6 gigahertz already. So we're going to see the same competition between license-exempt technologies that we see in 2.4 and 5 gig today. And not all of it will be controlled by the access points. And a lot of it will be peer-to-peer. And this means that you're going to have a lot of competition. Just one thing which surprised me, actually, on the healthcare side. We were in a meeting with, I think, a Qatari regulator, and we got one of the customers in from the medical side who basically provided networks for quite cutting-edge hospitals in Qatar. And they were both a customer of Cisco and HPE, I think. And the guy came in, we hadn't prepped him about anything about what to say. And he said that basically, we're running 160 different services on our Wi-Fi network today. 160 different services, he said, approximately. And the variance of that, of what they're running is low latency voice to like best effort, high data rate. And the network has to take all of that on the enterprise networks. And funnily enough, enterprise networks, you're going to have less spectrum to play with than you are in the home because we have to do frequency reuse patterns. So to do this deterministic mission, critical wireless, with high bandwidth, low latency at scale to drive increased productivity, you need enough spectrum to do that. So we're trying to solve that by, we can do some of the things with the predictable wireless start and the wireless stack, and we could do some of it by interference management. And AI will improve a lot of these things. And we can do a lot of improvements, I think, between the different technologies talking to each other at the higher layers. And some of the stuff that WBA does there will be important. And this could include 5G technologies in the future as well. This is from our customers, and Matt showed this today, and this is the only slide that I've actually duplicated with it. This is where our customers want to go in the wireless first world. They want to see deterministic, predictable, reliable usage, and it's got to be simple. And originally Wi-Fi was very simple, becoming a lot more complicated now. But we still need to keep that simplicity in there. So this is the road of the technologies went there. You know, Wi-Fi 5 and earlier, a lot of over-provision, under-subscription. We've seen more network scheduling coming into it with OFDMA and Wi-Fi 6. And now we're seeing a lot more interference management coming into Wi-Fi 7 or MLO and trying to kind of use tri-band systems to give you more capacity and also to steer traffic in different bands. So you're kind of, the traffic that's want to be more deterministic, you're probably going to put in 6 gig. And the more best effort, or the kind of low data rate, which isn't low latency, you'd probably put in 2.4 gig. And then you've got Wi-Fi 8, which is heading more towards managing the APs as a kind of entity together, rather than having more AP to AP interaction. So you're going to be able to have a bit more management in that system to be able to manage the spectrum. So all that's coming together on the technology side, but we're going to have some problems on the spectrum regulatory issues. This is where we are today worldwide. Most of the major markets have opened up or are in the process of opening up the lower 6 gig band. I think there's over 100, 110 or 120 countries have opened up lower 6. China, as we mentioned previously, and that wasn't something that we rehearsed, there's only one really of a major market that doesn't have lower 6 gig available. Future Wi-Fi needs are going to be studied alongside IMT in the upper 6 gig band. That's a given now. There is a competition there between the two technologies. Unfortunately, it has been quite brutal at times, dealing with the regulators and dealing with both communities, which is, it's a bit sad really, because really the two technologies should be working hand in hand. We're going to see indoor wireless networking is going to become more and more as strategic goals for the regulators. They've done a lot of strategic goals in Europe to do 1 gigabit to the premise, but they've not looked indoors and what they provide on the wireless networks to the customers. And that's going to be something that's going to be looked at, I think, in the next while. We've also got things like providing emergency services indoor, providing emergency calling, providing access to first responders to Wi-Fi networks. All that has been worked on now in WBA. And that will have to be done over enterprise networks, over public networks. And there will be some metrics that you're going to have to meet to do that. So on the spectrum side, we're looking at UK and EU. Today have put some proposals out. And they're looking at consultations with possible band split options, opportunistic access for Wi-Fi in the band where they're going to put, or proposing to put 5G in the future, which by the way is about 5 years away at least, to even get access to the spectrum, because there's incumbents in there, which you'll see at the bottom slide there, that are going to need to be protected, or they're going to have to move out. And a process of moving out fixed links will take 5 to 7 years for most regulators, because they've got statutory duties to do in order to remove the incumbents. They have to give them notice, which sometimes is 5 years, and then they have to go through the process of doing auctions and things like that, which again will take 2 or 3 years. So you're looking post-2030 probably for most regulators in Europe to be able to open the band. The other issue that nobody's really talked about so far, and it'll be a problem for some of the countries like UAE and about here, and I think the other one is Brazil, that are looking at, well, they've got themselves in a real mess because they've already opened the band for Wi-Fi, and now they're going to do an auction in the upper 6 for 700 megahertz to IMT.
But those countries that have opened up the 700 megahertz, at that 6425 boundary, you're going to see out-of-band emissions from high-powered base stations. These base stations are pumping out 81, 83 dBm per 100 megahertz. They're high-powered base stations. Even though they're outdoor, you're going to see them in the first 75 to 150 meters on your Wi-Fi networks. So that means that you started off with 480 megahertz in these areas, but you may end up with quite bad interference takes you down to 380 megahertz being available to provide these deterministic services. And the other thing that is important as well is outdoor access in 6 gigahertz. In Europe and most of the world actually, and I'll come to a slide later to show you the progress of AFC and standard power, there isn't outdoor access in 6 gigs, so we've actually switched off we've got tri-band APs out there, and we'll have to switch off 6 gig in outdoor settings. For things like stadiums, in Wimbledon we have indoor and outdoor areas, so you have indoor areas that 6 gig is switched on, outdoor areas it's switched off. So even in convention centres that want indoor and outdoor kind of coverage, you'll use 2.4 and 5 gig indoor, but you'll switch off 6 gig. It's in the product's there, but you don't switch it on. Spectrum crunch and enterprise. As I said, we don't think there's enough channels at 80 megahertz and 480 megahertz that's available in lower 6 to provide the frequency reuse patterns in the denser deployments that we do. We've got problems, as we all know, in the 2.4 and 5 gig. We've got backward compatibility issues there. And enterprise use probably won't be any better than 6 gig and 5 gig if you only got 480 megahertz. That means we're down to like 20 megahertz and 40 megahertz channels, which means you actually in enterprise environments, you're going to have a lot less data rate on your APs than you're going to have in your home network, which is pretty crazy. So the other issue we've got is that, as I said, you're going to have other competing users from the license exempt family, if you like, and some of them will be Wi-Fi devices for your peer-to-peer and your client-to-client activities, and then the power levels of those usage is quite important. If you start using the same power as the access points, which we're already kind of trying to reduce to give frequency reuse, then actually the footprint of them, interference-wise, is the same as your access point. But you don't have any control where they're going to come in, when they're going to come in. So you have to have enough spectrum to be able to deal with that. We also see narrowband frequency hopping stuff coming in that are non-Wi-Fi, your Bluetooth and your 802.15.4, as I said. And then you're going to see high-power IMT base station reducing it further, possibly at the boundary and 100 megahertz below it. And the way that networks are working today, a lot of buildings you have separate IT and industrial IoT networks. So you not just have one wireless network there, you may have two. And also in these things, you're also looking to replace some of the cabling in these buildings now, which means that you also have to have the equivalent of the Ethernet cabling there on the wireless network. So there's a lot of traffic going to be over there, and there's going to be a lot of interference. And in our view, 480 megahertz, as I say, is not going to be enough. So if you look at what does it mean, all these impact to these discussions on band splits. So in the US, you've got 1200 megahertz available with these number of channels for 160, 80, 20 and 40. And actually the sweet spot for us is 80. That's where we want to be in enterprise, because we can do a lot more with 80 megahertz than we can with the current channelizations. And this is in dense deployments. You may be able to use these bandwidths where there's not a dense deployment and there's not a lot of usage. But in dense deployments, this is where we see the sweet spots. And really, it's the best channel reuse pattern that we can have is about 12. And we think with 12, then we could probably deal with interference from other sources as well as providing all the services in these dense deployments we want to do.
So if you stay at 480 megahertz, you're only going to have 6 channels, 80 megahertz. So your frequency use pattern is going to be pretty bad, to be honest with you. It's going to be worse than probably 5 gig, unless you go back down to 20 and 40 megahertz. If you get an extra 160 megahertz, which is one of the options talked about, even then you're still going to only have 8 channels. And even if you get an extra 320 megahertz, you're going to only get 10 channels at 80 megahertz. And this is the impact that you have when you're talking about what kind of data rates you're going to do with a 2x2 client. You know, the difference between 80 megahertz and 20 megahertz is like it's a quarter of the speed. Sorry, it's less, it's more than that. It's a quarter of the speed at 40 megahertz, and it's even less when you have to go down to 20 megahertz. So that's what you're going to get in these APs in the enterprise environments. So just to cap off, we're seeing a massive increase in demand in enterprise, and that includes bounded latency, which Matt talked about. We're having to provide different types of quality of service on the same APs. We've got, as Matt said this morning, we have APs that have all of these technologies using the same spectrum. Bluetooth in the AP, UWBs in the AP. Sometimes we have Zigbee in the AP, and these new ones are going to come in as well. So enterprise networks need access to the 1200. How we get that access may be more managed. I don't know. It may be different from generic Wi-Fi. Generic Wi-Fi probably would be able to cope in your home networks. Maybe in some of the multi-dwelling units you may have some problems. But most homes would be okay with an increase along these lines in their Wi-Fi usage. But in enterprise, we think we're going to need the full 1200. And we think that there is ways of doing that. And actually, countries like the UK are looking at possibly having access point only access to the upper band and more controlled usage of those access points. So in the future, if IMT comes along, they can switch them on and off as necessary. So I think that's what we're saying to most countries now, and also to operators, because actually the mobile operators are going to be impacted by all of this, because they all provide enterprise services and they all provide home services. So their customers on their fixed networks are going to be impacted, possibly by them introducing their mobile networks. And the other thing that I think that we could be doing, and that's something that WEB do very well, is open roaming and passpoint. And actually we need to speak to the regulators about that. The regulators need to start taking more action to encourage both enterprise and the operators themselves to use these facilities that are available for open roaming. And then let's not forget SP and outdoor usage. Today, as I said, there's not a lot, but there's still a large demand for it. All of your large outdoor public venues need outdoor coverage. They need AFC, and standard power is useful, but actually the AFC in the outdoor is actually probably more useful for a lot of these ones, because we are using more spot beams in these ones to provide good frequency use patterns. Campus-wide networks outdoor, you've got your municipal smart cities that we've seen today, this morning from Tokyo. We've got service provider hotspots, both indoor and outdoor. We've got fixed wireless access. There's a lot of good business cases in the US springing up for fixed wireless access using the 6 gigahertz band. And then we've got things like industrial and logistics. Again, if you're taking a product in a warehouse, through the warehouse and out the warehouse, you want to maintain that connectivity through the indoor to outdoor transition. So if you've got pallets with stuff on it that's got a wireless connection, you need that there. Hybrid APs are now becoming more and more available. We have quite a few that do both LPI and standard power AFC. AFC is available now and being used in US and Canada. And actually, the important thing as well is that WB and both WFA are actually going to be supporting Open AFC, which is actually the actual database provision. And possible uses of future AFC is, they could start coordinating enterprise and public networks in Upper 6. And some regulators are thinking about that, I think. And they could also, you could start looking at local licensing in other bands as well. I know that Saudi Arabia in particular are looking at a combination of AFC and local licensing in some of their proposals going forward. So outdoor standard power AFC, important. But at the moment, it's been quite a slow progress. The only place that's open really is North America. We have got Saudi Arabia, who are quite far down the line and probably will be open maybe start of next year. We have the UK, who are looking to try and open up mid next year, I think. We've got work going on in CPT to try and give instructions or give the tools available for countries to be able to pick up and do AFC in a harmonized way in Europe. We've seen some traction in South Africa and Australia again. We've seen something. Japan have done their own version of AFC, and we've got South Korea as well. Australia, by the way, have opened up 160 megahertz extra generic for Wi-Fi as well. And then we've got Brazil, who I said they are looking at AFC, but they're trying to close Wi-Fi in the upper band. But it's very difficult because there's a lot of systems out there already. So they've got themselves in a bit of a muddle to try and do an auction for IMT in the top 700 now. And a lot of these other countries in LATAM are looking at it. And actually, there is interest in Asia, mainly for outdoor BFWA, to provide connectivity to underserved areas. So there is a lot of work going on. And with that, I'll hand over to Chris, unless there's any questions. And I'll do for time.
Yeah, very good, very good. Thank you. Very comprehensive update. Andy will stay around, so if you want to know a bit more about Spectrum, let us know. And Ofcom, Andy, hopefully by the end of this year.
We'll see, hopefully.
Let's see. Thank you so much.
Cheers.
Okay, so time to move on. Next, we'll have the, let's say, debrief of a great announcement that I believe you all see. So I would like to invite Broadcom's Director for Product Marketing, Chris Zimanski. Talking is about the next step in Wi-Fi evolution, shaping the future of connectivity. Chris, please join us and share with us the news.
Thank you very much,
Thank you.
Bruno. Hello, can you hear me? Okay. So yesterday, Broadcom announced the launch of a full ecosystem of Wi-Fi 8 products, and we see Wi-Fi 8 as Wi-Fi for the AI age. Typical boilerplate, SEC language. So first, I just want to start out by talking about the evolution of the internet. So we've gone from watching movies together collectively to watching alone to diving fully into more immersive experiences. But all the while, we're moving from consuming data to creating it. This is the era where users will make, share, and shape the content themselves. According to Statista, there are 20 billion connected devices right now. And I've seen some pretty outlandish projections where around 2030 timeframe, you could be talking as many as 15 connected devices per people, leading to a staggering over 100 billion connected devices if those projections are correct. By the end of 2025, it's projected that there'll be nearly 500 million terabytes of data created every single day. Now, this isn't internet traffic. If you were to look at an Ericsson mobility report or when Cisco is doing the VNI, where you're talking about network traffic, a lot of this traffic stays local in the enterprise or in the home. But guess what the most popular medium is for accessing this data? Wi-Fi. Current network traffic is about 90-10, but AI upends that with applications like DeepSeek and Copilot that are projecting 50-50 uplink, downlink. So this is going to change sort of the overall importance of the uplink as we start talking about internet traffic. Today's digital assistants like Alexa or Siri, or even if we're talking about ChatGPT, are fantastic, but they're not conversational. There's no capability to stop, think, interrupt. And so as we start talking about moving more towards this era of a truly agentic voice assistant, think of something more like Jarvis. We could all have Iron Man next to us in the future, but that requires barge in and barge out technology, incredibly small packets, buffering, especially on the uplink. So Broadcom sees uplink demand growing and the reliability around the uplink demand growing significantly. To get there, we need to be about 2x better latency on voice and about 10x higher reliability than today's voice. So we're talking about fairly stringent KPIs. So to enable AI, there's really a brand new edge. So, previously when Broadcom had launched, we talked about the converged gateway, which was typically broadband and, Wi-Fi, or some people have talked about fixed wireless access and Wi-Fi. But with AI, you're now talking about edge compute. So it's bringing the processor closer to where the data is created, especially in instances where you need security or privacy. The broadband is accelerating to 50 gigabits per second. I know that there are some out there that are demoing that today at NetworkX. And intelligent Wi-Fi is built for the AI era. So it offers the capacity, but more importantly, the reliability and the scheduling. We got to connect all those devices and all of that data and do it in a very intelligent manner. We see the broadband gateway as the perfect edge AI device. It's going to enable up to 50 gigabits per second fiber, NPUs at the edge, and then AI-ready Wi-Fi. So yesterday we introduced Wi-Fi 8, Wi-Fi for AI, and it's designed to be more reliable, more secure, and robust. So once again, if Wi-Fi is built for the AI era, what are we talking about? Well, we already discussed that it's reshaping the way that data moves. We've discussed the reliability KPIs and that AI feeds on context. So we see Wi-Fi 8 as being AI ready, AI aware. Sorry about that, got behind. AI aware and AI first. What do I mean by AI ready? Well, it's got to be ready for the demands on the uplink, going from the edge to the cloud. AI aware because it thrives on context, sensing, motion, ranging, providing all of that context that AI thrives on. And then AI first. What do I mean by AI first? Well, AI's got to teach the network to be smarter, machine learning, better scheduling, optimizing resources in real time. So Wi-Fi 8 is interesting because rather than a few marquee features that we saw in Wi-Fi 6, like uplink OFDMA, Wi-Fi 7 and MLO and 320, Wi-Fi 8 brings a collection of features, and at first you look at it and it might seem like it's a little bit of a patchwork, but it's not. It's designed to address pain points that users face every single day. So these features lead to higher throughput, more network capacity over the air, longer reach and stronger coverage close to the edge, and reliability and costs that stick. Wi-Fi 8 delivers even in non-ideal scenarios. So imagine that you're in an apartment typical of a major city like Paris, okay? You've got 20 apartments and maybe a family of 4. Somebody's watching TV, someone's playing Call of Duty like my son and live streaming at the same time. I'm trying to get a call out on Skype or doing a video call, and then you have some IoT gadgets. So we're not talking about a crazy number of devices or something that's out of the ordinary. But when you get into a crowded apartment building and you see this adoption, there's going to be a whole lot of contention. In that scenario, we see Wi-Fi 8 really excelling. We're getting upwards near 200% higher median throughput. So this is going to be the more typical value that people will see. But at the same time, we're compressing the latency tail by getting 6x better AI-ready voice latency, or latency KPIs, as I described earlier in the presentation. For active transmission, so think of an IoT headless device. I'm not talking about something with a screen that might be consuming loads of power beyond the Wi-Fi, but think of a doorbell or some other battery-operated device. We see the ability to increase the battery life by 2x, or a 50% reduction in power consumption. Then with features like extended long range, we're going to be able to stretch up to 2x further in line of sight scenarios. In non-ideal, non-line of sight scenarios, you might be getting 1.5x, but tremendous difference in real world applications around the home. So this is really exciting to us when we think about tail latency. So, why does latency spike? It spikes because of medium access delays. You have retransmissions because something didn't get through. Packet queuing because someone's doing full buffer for a couple of minutes, someone else is doing video streaming, you have other applications, and a high reliability QoS flow doesn't get through. Wi-Fi 8 features such as and this is just a few, there are many features collectively that add to this, but inter-AP coordination, prioritization, in-device coexistence, and seamless roaming are going to lead to significant improvements. What you're going to see is less jitter, shorter queues, fewer collisions, and much higher quality of service, even in non-ideal signal conditions. So we're not talking about a clean room, we're talking about where you all are deploying Wi-Fi today. So Wi-Fi 8 incorporates some 5 features that are pretty exciting because it's going to lead to a much more robust coverage. We're not just talking about total coverage, but we're talking about better rate versus range. So with, DRU and with ELR, enhanced long range, you're going to have, longer signal, albeit, not a whole lot of throughput, but creating those, connections where you need them. But when you look at unequal modulation or more steps in the MCS ladder, right? Now you're talking about places where instead of dropping your throughput in half, maybe it's stepping down only a little bit. And so you're not going to have those huge drops that lead to unequal performance as you're moving around or in different spots in your home or your enterprise. But as Andy had mentioned, earlier talking about Wi-Fi 8 and inter-AP coordination, Wi-Fi 8 doesn't stop there. It's going to be really exciting in the enterprise and, in the home. So if you think about features that are super important there, in the multi-AP access enhancements are really quite profound. You get more of a single unified network experience. It kind of feels more like you could be sitting anywhere within your network, but you're right next to the AP, right? So seamless roaming is going to deliver that unified network experience when you're walking around. Or if you have some multipath and you would accidentally flip to another access point or whatever, the inter-AP coordination is going to deliver interference-free mesh nodes. NPCA is going to provide you with additional channel access to ensure that the medium is fully used. And then the PHY enhancements that we discussed is going to provide a much more robust backhaul. So yesterday we introduced the world's first Wi-Fi 8 ecosystem. And the 43109 is for phones and tablets and PCs. The 6718 for residential access points. The 43840, and there's a derivative chip that's the 43820, and that's for the enterprise market. And then we also introduced a brand new field of use license for a variety of applications such as automotive and IoT. Our mobility chip is a 2x2, so 2 spatial stream, 320 megahertz capable Wi-Fi 8 radio. It supports Thread and Zigbee, proximity ranging and sensing to provide all of that context that AI thrives on. It also incorporates Bluetooth 6, so high band, high data rate. So as Andy was talking about earlier, think of Bluetooth in 5 and 6 gigahertz. For the residential market, we have the 6718. Once again, Wi-Fi 8 radio, 4 spatial stream, 320 megahertz capable device, but it incorporates some features that really cause Wi-Fi 8 to excel. So we're enabling more telemetry than we've ever enabled before in this chip. It's aligning with our AI-first approach. Gateways are evolving to include edge AI, so making Wi-Fi smarter and more adaptive. Telemetry we see as being the key to fueling AI. It models that train and run interference. Our packet scheduler has been enhanced to make smarter use of Wi-Fi 8 features, while new signal processing algorithms improve sensitivity and strengthen the uplink. We've also focused very, very heavily on energy efficiency. So we have enhanced eco modes that deliver 30% better performance than our previous generations. And our Gen 3 digital distortion technology lets the power amplifier deliver top Wi-Fi performance at 25% lower power. So it continues the improvements from Wi-Fi 6E through Wi-Fi 7. When we talk about the power for the enterprise, this is largely the same chip, but it's been modified for more enterprise-centric features. So in addition to the chip that I talked about earlier, we have a 2x2 chip that is used as a scanning analytics radio. But the power features in this are really going to be so helpful for enterprise, where you talk about enterprise APs incorporating a whole range of different things. It could be GNSS, it could be ultra wideband, but you have all these radios. It takes power. No one wants to put a fan in the access point that breaks down, and you're limited by your PoE power. So with these chipsets, you're going to be able to do more and fuel more on the platform. So we see this as really driving enterprise growth. Finally, getting into our field of use license, this is a little different strategy. While we've licensed before, we've opened up this license, and we're focused on markets that Broadcom doesn't participate in, like IoT and automotive. Partners are able to license production-ready, best-in-class chips. They can manufacture and sell the Broadcom part, but they can also derive their own derivative roadmaps, so they can make evolutionary changes, step changes in order to address their market needs. So, Wi-Fi 8 has arrived. We're excited. We're excited to see the growth, and this is really just the beginning.
Hey, Chris, I'm sure people will start asking about POCs and when this, can get in the hands of the industry. But we have time for one question. Anyone would like to ask about Wi-Fi 8? Okay, we have one here.
Hi, Chris. Andy Gowns again. Sorry. The last one that you said about the IoT, is that just going to be for Wi-Fi bands, or can you introduce that chipset for other bands?
Oh, no, this is for Wi-Fi bands. It's constrained to the 2.4, 5, and 6 gigahertz.
Got it. Okay. More focused. Okay, sounds good. So looking forward to continuing this on the working groups, and thanks for all Broadcom is doing. Thank you. Okay, so let's continue. So for our next speaker is Jorge Paredes. He's the CEO of Home6. Unfortunately, he couldn't travel to join us here today, but was kind enough to record a video around real-time networking and how they are co-building the future of AI and value-added services. So let's see if we can play the video from Jorge.
We built the superhighways, but the value is leaking away. The internet as we need it is broken. Why? Because the massive investments we pour into it have a value drain. They promised us that 5G would increase revenue, but the reality is that ARPU hasn't grown as expected. Now, AI arrives with an even greater promise. But we've lived this before. We build the roads, and others create empires of value on top of them. This time, it has to be different. It's a matter of survival. The edge is the new ocean. The traffic of the future will make the Super Bowl look like a stream. The coming challenge is on a scale we haven't seen. If you think streaming a Super Bowl stresses the networks, imagine when every light post, every vehicle, is a visual sensor or a real-time digital twin of the city. The real value of AI lies in inference, predicting the next pixel, the next action. And for that inference to be useful, it must happen at the edge, where the data is born. The risk of the inference blackout. Data sovereignty is important. Inference sovereignty is critical. And this brings us to the biggest risk of all. Governments already understand the importance of data sovereignty. But true sovereignty is the ability to run your own inference. Imagine if someone, due to external regulations, could turn off the tap on your AI, sending you back 20 years in time. That is the real risk. And that is why telcos, governments, and manufacturers must build a new internet model. How do we build this new model? A model that moves power from the cloud to the edge. Not for control, but for survival and progress. To build the smart cities and robotics of tomorrow. The question is, what are the standards that will define this new internet? Hello, I'm Jorge Paredes, CEO of WOM6. For the last 4 years, our team has been dedicated to a single mission: to build the standard upon which the value of AI can be deployed at the edge of the network. We understood that to make video more valuable, we didn't need to make it lighter, but smarter. But we hit a wall. The real-time video trilemma. Until now, these three axes were mutually exclusive. If you wanted immediacy, you sacrificed quality. If you wanted quality, you sacrificed speed. There was always a compromise. Until now, I present to you WOM6 Media. It's not an improvement. It's a new transport protocol that solves the trilemma through 3 fundamental breakthroughs. 1. Absolute immediacy. First, immediacy. We created a bufferless transmission, with a speed measured at less than 200 milliseconds end to end. 2. Master-grade quality. Second, quality. We enabled it to carry up to 300 megabits per second of binary data and assigned it a codec that improves encoding efficiency by up to 2 times over what everyone else uses, allowing us to transport full HD and 4K video in master quality. 3. Native edge distribution. Third, low distribution costs. We designed our protocol to run on low-capacity devices, both in terms of processing and power. And we managed to get the cost of transporting a 100 megabits per second stream down to just $5 per user per month. And finally, we gave it a fourth capability that doesn't exist anywhere else in the world today: veracity. We gave every frame a cryptographic guarantee of integrity with a SHA-256 hash and a hidden QR code for visual identification, and we prepared it to be natively processed by AI models, both in real time and on demand. This technology is the core of our platform. WOM6 Media is the protocol that prepares video for the future, and WOM6 Multilink is the vehicle that transports it over today's unstable networks, bonding multiple links to create one resilient connection. Together, they turn any camera into the world's real-time reality sensor, ready to build the digital twins and sovereign AI of tomorrow, but running on the internet we have today. Proven in the most demanding environment, live broadcast. But a new technology without real-world proof is just a promise. So we took our protocol to the most demanding battlefield there is: live news broadcasting. Our first test, a local broadcast against the market leader, TVU. The result, we achieved 10 times lower latency. A resounding success in speed. But we learned a vital lesson. A single link, no matter how fast, is a single point of failure for stability. This forced us to solve not just for speed, but for resilience. Thus, WOM6 Multilink was born. We went back, this time for a 220-kilometer national broadcast. Using WOM6 Multilink to bond multiple unstable links, we not only matched our competitors' stability, but maintained our advantage of being 10 times faster. The final challenge, an international round-trip broadcast to Miami. We faced not only live view, but also the gold standard SRT over dedicated fiber optics. The results speak for themselves. We were 10 times faster than live view and 20 times faster than dedicated SRT fiber. We proved that our protocol is not only faster, but can outperform even the world's most expensive private connections. And now we are ready to show the results of our system against Google Meet, where we have managed not only to beat it in quality by transporting a full HD stream at 90 megabits per second using H.265, but also in latency, being 50 milliseconds faster for a link from a video conference using different operators in Guatemala. What I have just described is not just a faster stream. It is the evidence that the video trilemma, the battle between speed, quality, and distribution, has been solved. And by solving it, we not only radically improve what exists, but we unlock what was impossible until today. This creates an opportunity like never before for a telco, a city, or a manufacturer. The ability to build value-added business models on a technology that can compete in advanced tech against Google, Meta, NVIDIA, and any other, as we have solved a problem that had gone unsolved for at least 20 years. And this brings us to a crossroads, a turning point for the industry. One path follows the old model, telcos as data pipes, while the real value is captured by others in the cloud. The other path is one where value is built and monetized directly at the edge, where networks don't just transport data, but process and understand it. A WOM6 was built to operate on that second path. We invite you to co-build the future of sovereign AI and value-added services with us, and to rebuild your business models from telcos to techcos together. Worldwide pilots available right now. Thank you.
Thank you, George, and the team from WOM6 for recording and bringing us this trilemma. Everything I'll say is there is a demo that WOM6 will do here tomorrow, so just outside. So if you are interested and want to learn more and liaise with the team, feel free to do so. But yeah, so I think this is a moment where we go into our panel for this session. So it's about next-gen Wi-Fi. So given all the news, all the spectrum potential we have, I think it's very timely that we talk about future path and these convergence opportunities. So I would like to invite Mario Didio from Ilium Networks, Jared Griffith from Ruckus Networks, Sarper Gokturk from AirTies, Mick Cox from Plume, and Lily from the WLAN Application Alliance back on stage. So guys, take a seat, no specific order. Yeah, so, perfect. Hey, Jared.
Hey, how's it going?
Thank you. Thank you. Cheers. Okay, so stay in the middle for a change, right? Next gen innovation. Okay, no, so I think, you know, when we were preparing for this panel, clearly you guys come from different spectrums of the industry. So from enterprise, public, residential. So let's start by telling our audience in terms of next-gen technologies, we all see that this is moving, but sometimes I see you have jobs around innovation, pushing R&D, having global strategy, you know, for sales. So tell us a bit, while you introduce yourselves, what you do in the company and what's next-gen about your work that can help achieving these visions. So maybe let's start with Mario and go around.
Try. Hello, everybody. My name is Mario. I'm the General Manager of Network at Helium. It's an interesting question. As I was reflecting, how to answer that. Like at Helium, we do many different things. So we are a very tiny ODM for Wi-Fi. So we have that control. We have a network of tens of thousands of hotspots deployed that do offload for carriers and indoor coverage for carriers in the US. We also have an operator, which is Helium Mobile as an MVNO. So when you talk about next gen, it's like you take all that, you sprinkle a little bit of cryptocurrency and blockchain, it becomes a lot. And so what I think about next gen is how can we use some of those assets that we create in the industry in terms of like pushing software to devices and have simultaneously be able to measure that quality of the Wi-Fi that we create for our own subscribers. And how can we push our own deployers, which is in our case is a decentralized network, so people that are incentivized by the blockchain component to deploy hotspots. And so the next gen piece is like, how can we shape that metrics in a way that can we prove that to the ecosystem that a network can be built in a decentralized way, using the metrics to steer the deployers to deploy in the places where we want them to deploy and the way that they want them to deploy, using the metrics to close the loop between the device, the network, and the subscriber on the other end. So that's kind of where...
All the pieces end-to-end.
The end-to-end,
Interesting.
yes.
Sarper, we saw this morning the big boss presenting all the challenges, and you are VP of R&D and Innovation.
Yeah.
So can you share a bit more?
Thanks for having me here, Bruno, first of all. I am Sarper Göktürk, and I'm VP of Innovations at Airties. As most of you might know, Airties is a leading provider of solution provider for managed Wi-Fi across the globe. Some of our customers are AT&T, T-Mobile, and Deutsche Telekom, and Bouygues Telecom in France also. So we are providing managed Wi-Fi solutions for the residential networks. But also, recently we have introduced our Airties Pro for small offices and office solutions. And also we have Airties Multi or multi-dwelling networks, and Nova is a test home in a box kind of concept for experience measurement of home residential network deployments. In Airties, my role is dedicated to design, implementation, and architecture of new features that Airties is planning to productize in short to long term. As such, we are always in looks for next gen and research of new technologies that we can deploy in the field as soon as possible with the limitations that we have in the gateways that are already available in the network. That's what I'm trying to bring the topic here is we always talk about maximizing the experience of the end user, because in the end it's the end-to-end that makes the change, right? It's not only the part of the software or the component or the network itself, but it's the customers and users experience as a whole, right? And it consists of many components, but in the end it's a network topic, right? So what we want to optimize is the experience. As such, that brings us to network intelligence. We are all talking about artificial intelligence, how we can bring intelligence into the network so that these all experience management and optimization is taken care of automatically by the network itself. That brings us to the infrastructure that enables this kind of optimizations so that these can be done in real deployments, right? Network is made up of many components from different vendors, right? It's gateways, extenders, client devices, all connected to the network. But they're using some standards. That's what we are doing in WBA also leading, right? Operator Managed Wi-Fi Work Group, where we are trying to find an instruction manual, maybe we can call it as a reference architecture, as the baseline, so that we have a commonality between all these vendors that provide the baseline requirements so that we can have this network intelligence built on top of all these metrics. We bring in TR181, TR369, Wi-Fi alliances, Easy Mesh, all these standards, so that we can make up the end-to-end experience maximized for all the end users. So this is so what I'm trying to say is there are some practical limitations. We have to take them into account, but we know where we are going, so we are trying to lay the infrastructure so that we can bring everything together and
Yeah, so it's a lot next gen, but the pillars need to be there.
Exactly.
And I imagine, Sarper, you will have a KPI from all the mobile operators in the world to reduce churn. And
Yeah,
you have
exactly.
To have solutions to help with
Exactly.
that. Okay,
Exactly.
good. Yeah, so let's move on. I think, with Mick and Plume, we have been working with Plume for a long time, but looks like these recent months, there were some, renewed
changes.
strategies,
Yeah,
and you are
that's right.
SVP of Technology Innovation, so tell us about it and where you are heading in terms of your role.
Absolutely. So I spent the bulk of my career at NASA at the Jet Propulsion Laboratory, where I found technologies that are going to matter in about 5 years. And then I helped deliver those technologies and realize them into real world products for people that are building rovers and driving them around on Mars. So those are people that tend to be pretty ahead on a technology spectrum. After that, I did a startup where I was a founding engineer. We had a real-time machine learning engine and streaming platform that I helped architect. They eventually asked me to be CTO there. I recently joined Plume as SVP of Technology Innovation. For those who don't know, Plume invented cloud-managed Wi-Fi, and for the purposes of this stage, we're the other leading provider of cloud-managed Wi-Fi. We have about 400 ISPs in our umbrella globally, about 500 million devices connected to our platform that we manage. In terms of things that are next-gen for me, one of the most exciting ones, it's every day I'm in it, and I hope you forgive a bit of a meta answer, is that literally everything about this organization is moving into a next generation. We have a new CEO who joined us, Dan Hertzkovici from Comcast. Our CTO, Chris Griffiths, also multi-decade experience working as an operator. And so these are people who know how to deliver at carrier grade and at enterprise grade. And so they've asked me to come in and also help push innovation at a pace that matches the entrepreneurial spirit and the entrepreneurial roots of Plume. And so I'm very, very excited to come in and help accelerate that from soup to nuts. I can't reveal everything about the playbook that we have working on, but I can say there's a lot of really interesting stuff cooking right now. This organization is unrecognizable from what it was about 6 months ago, and I'm really excited for us to start rolling out some of the things that we're working on over the next year.
Fantastic. I think we are, humbled to have you and bring some NASA experience into these industries, so that will be fantastic. Okay, so let's move to Jared. I think, service providers, global scale, how do you do it?
Well, start off with the vision. You start talking about next-gen technologies, and we pull that into a pure convergence platform where we see a world of seamless roaming between 4G, 5G, and Wi-Fi. We see the capabilities of being able to do PCRF capabilities, ATSSS, all of those type of things within a Wi-Fi segment. And, we look at it as futures, but for us, it's very much a reality as of today. And similar to you guys, we got some secret squirrel stuff that we're developing and pushing out right now, and we're super excited about that. So that's where we see next gen. At first, I was getting excited about Wi-Fi 8 being next gen, and then I heard about AI radio resource management and reduction of latency and all that, and I'm like, but we already do that today with Wi-Fi 7. So I think for us, it's the convergence play.
Convergence is the way to go. Okay. Yeah, and then Thomas, I think we all heard about what you are doing on standards. So maybe from your standpoint and also working for a Standards Alliance, what's the secret for scaling this? How you make it like part of your daily mission to scale standards and like the regions you mentioned, like China with 1.3 billion people? What's the secret sauce?
Everything we do should be combined with the age, the time right now, and we are in the AI time. So AI change everything. Whatever we do in the WAA, whatever, if we don't combine everything with the time, will never be successful. So AI impacts almost everything. Like not only the data model, the traffic model of the network, but also the working model and the social model and living model, everything. It is huge. I think in the next maybe 3 decades or 5 decades, most of the job that repeated job like a mental job or body job will be all replaced by AI. And people will living in a totally different way. What's the requirements or the user experience requirements for the network Wi-Fi? It's very difficult to predict.
Yep.
So to keep up with our step to the time is very, very important, or otherwise we will be, disband, disappear. That's very important.
Yeah. Hopefully only when Wi-Fi arrives and we are replaced here by, agents and holograms, so hopefully we can keep this panel still. So, but I think I agree with what you are leaning towards. So maybe just now let's dive deeper and maybe going back to you, Mario. So Iliam, you mentioned a concept that I believe all of us sometimes, decentralized networks. So is that a real thing? Is that scaling? But you mentioned something very interesting, that it's very important in these crowdsourced type environments to maintain real-time QoS, a managed framework. And by the way, I think you announced like a huge amount of operator offloads. You are getting that confidence. So how this is going and where you believe decentralized networks will basically go in the future?
Yeah, it's an interesting concept, and I think that it ties back to a lot of our discussion that we're just having here. By the end of the day, for us, when we look at QoS, quality of service metrics, and the work that we've been doing within the WBA, it came to us as a necessity to start with. So, because when you build a network in a decentralized way, since you're not directly involved with the ins and outs and day-to-day operation of that network, the only way to create a monitorability and actionability on that network is if you have quality of service metrics. So we started working on that with the help of within the WBA, my colleague Joey Padden leading that group. But as we were doing that, we figured out, we immediately understood that was an interest for carriers that are using our network today. We serve more than 2 million users every day on the Helium network in the US and in Mexico. And it was like, well, this is actually the key of how this can be applicable to scale. Because in this way, that's the applicability of those QoS metrics that get ingested by the carrier on a, especially quasi-real-time way, allows them to make real-time decision about where. So the convergence that Jared correctly, I agree with, is going to be the key word. We've been thinking about convergence for a long time. We've been talking about in these forums for a long time about convergence. It's all hinged on the ability of monitor and actionability. And I think Wi-Fi, when you look at the cellular stacks, usually they're very vertically integrated. They come very times from single vendors in many situations. Wi-Fi, by definition, is multi-vendor. And so the way in which you can, potentially, not compete, but actually complement and converge together is if you have standardization of the interfaces and similar monitorability and actionability on metrics. And so that's where when it started for us as a necessity to manage our own network, it became like, okay, now we're going to integrate in an open source standard, the biggest open source standard for Wi-Fi, and we keep pushing this forward. So I think that the future is good, but not only just for decentralized, and I think it's this QoS-based type of approach will potentially is the first key on the convergence play to actually happen. You and I will talk.
Some APIs as well?
With some APIs. We already have a lot of things in the pipeline beyond just the monitorability. There is an actionability of those metrics, like how do you use AI? We are applying agentic AI today on those metrics within Helium, which is kind of exciting where this is going to lead. And after that, there is operations as well. But all in all, definitely decentralized is one of the way in which network will be deployed. I feel that this type of enablement will allow this type of network to grow more. But I think there is a global play. QoS metrics on Wi-Fi and the operationality of those metrics will be key for the next generation of Wi-Fi to be integrated.
Yeah, makes sense. Theoretically, outside world converges with these real-time QoS metrics. And by the way, so there was a demo that Iliam team did, and we were on our technical working sessions, and suddenly everything went down. And of course, we were with Wi-Fi people in the room, and they said, Wi-Fi is good, Wi-Fi is good. So what happened is the backhaul of the hotel for 5 minutes went down. So the demo that was performed is like if the backhaul condition change, there is a way to signal that, and we can trigger more seamless automatic handovers, or the users would not even connect to the network if they enter the room.
That's end-to-end experience.
And that's what I'm saying. That's what I think that the Helium way of doing is because we have the luxury to have an end-to-end. So whatever we push on our devices, it will immediately be available for all the carriers, including our own MVNO. So the closed loop is really fast.
But and it's moving to other parts. So I think that's a very nice inception point. But Sarper, maybe on that note, so you mentioned the operator-managed Wi-Fi reference architecture. When I look to this pavilion, I think we have around 40 infrastructure vendors here focused on residential space. So we did the first compliance program that will be soon announced. So what's your take on why these guys should join and be leading this operator-managed Wi-Fi compliance?
So it's simple, actually. We are talking about the next-gen Wi-Fi and the networks, right? And that requires commonality across different vendors and all the players in this ecosystem, right? So we are talking about networks, end-to-end performance, QoS metrics. All these metrics needs to be fetched from a device itself, which is the driver or the gateway or the vendor itself, right? But we require these standards to be applied by these vendors so that once we have a solution that utilizes these parameters, these metrics from these devices, it can end up with a good solution, optimizing the network, fetching the latency data, and using it as a way of measurement of the end-to-end quality, and applying some prioritization or that kind of stuff requires all these parts to be working as expected properly, right? Proper implementations of standards. But as we have been discussing these standards has been around for a long time, like USB, TR369, TR069, TR181, data model, Wi-Fi alliances, easy mesh, QoS, all these standards has been around. But 2 or 3 years ago, we have seen that there's a gap because end-to-end, there's no instruction manual as in terms of reference architecture that we have defined that tells the operator how these should be combined so that there's a product that can guarantee the end-to-end requirements of all the users. So I would like to ask all the operators also to become a part of this operator-managed Wi-Fi reference architecture work group, which we have already demonstrated that some of the gateways, Heights, Nokia, AirTies are supporting this architecture and compliant with first test bed, right? Which includes TR181 data model, that standard interfaces, the APIs that you have been talking about, so that you can remotely through cloud, you have the full visibility of the network, you have full configurability on the network, and you can do it across different vendors on different platforms, which paves the way for the next-gen solutions, add-on values that we would like to introduce in 7 years, 8 years, and at the same time it's backward compatible, and at the same time it's future-looking. It can incorporate Wi-Fi 8, since these are all standards-based, so it will be easier for all the ecosystem to build value on top of it, right? So it should lay the groundwork so that as Plume also providing solutions and value-add services that would be common to all of us, right?
Yeah, joining forces. I think what we hear from our members is the amount of resources they spend individually with each vendor. If there was a common framework, they could all join and basically offload that burden that is not adding value. So that's what you just said.
Exactly. We should avoid reinventing the wheel every time. So we will have the baseline for all of us, so we will compete on the value add, not on the baseline stuff.
Perfect. Yeah, open invitation if you want to learn more. We'll be doing this going forward alongside WB events, so it will be a great opportunity. And I think on that note, Mick, you mentioned Plume, being one of the early players. I think we can call you an innovator on this intelligent managed cloud Wi-Fi. A few things have changed, but I think from what I've seen, you are now focusing more on quality of experience and how you measure that. So of course, we have to announce higher bandwidth, within a home. Maybe applications don't need, that much bandwidth. So how you are taking this new approach to deliver, quality of experience and showing the metrics to the end customers?
That's a great question. So beyond quality of service, there's what actually matters, right? Quality of experience. For a home, only just this narrow sliver, for me, it is my Zoom call is silky smooth. It never, it never drops frames. My Netflix never buffers. All of my connected devices constantly stay hooked up. right? But even in just those 3 examples that I just gave you, those are 3 different metrics that we actually have to optimize for. It's 3 entirely different things, right? So my TV that needs to be good at streaming has to optimize for just, the amount of bandwidth on the down. My IoT devices, even though there's a really weak signal strength, as long as it can get 1 packet out every 10 minutes, I get 100% functionality out of that device. I don't care, right? And my laptop needs to be optimized for jitter and ping and latency and all these other things, right? And so beyond, is the device connected and what's the signal strength of my connected device, we at Plume realized we need a different metric internally that we can use to expose, to show, is this device capable of doing the thing that it's supposed to be doing? And so we've rolled in this quality of experience metric that we've built internally that we expose through the application, the mobile application that we use, and then also to our CSRs, because, if I show a CSR who's been on the job 2 months that the ping is this and the jitter is this, it's not going to be a really helpful experience at the end of the day. But if I show them that, hey, this device is red at what it's supposed to be doing, they can directly go straight to that device. And so for us, this is one example of how we can start leveraging these. I would also say that, as Bruno mentioned, Plume has started contributing its innovative voice in the industry in a way that we have strategically not done in the past. So examples of that, we just joined WBA. Thank you for having us. We just joined Wi-Fi Alliance. We've joined the Purple Foundation as well. We were at Purple Summit last week announcing some compatibility with Easy Mesh and OpenSync, which is now compatible with RDK, and you can bring your own devices to the party, which is an exciting step forward for us. And then beyond that, we've also, of course, joined RDK at the highest level of membership as well. So these types of things that we're building internally, these quality of experience metrics, we want to start contributing those as a voice to help everybody get to that same level where you can have that level of control, visibility, and then beyond just the basics, yes, everything is working, building those value-added services on top that are uniquely differentiated and that we can provide in a way that nobody else can.
Well, impressive. I think you have a short journey in Plume, but you have not been resting much. I hope you enjoyed some Paris because your pace is unbelievable. But yeah, let's go back to Jared, because you mentioned something that, of course, for us, WA as a community is really key, which is pushing for this roaming, offload, interoperability. And we heard that Wi-Fi 8, for instance, high density. So you work with non-residential typically, but these high density venues, large customers. So how do you see this evolving for Ruckus and how you are going to achieve it?
Well, the great thing about Ruckus Foundational as a company over 23 years now, we have highly succeeded in large public venues, high density. We've always been known for the company of layer 1, layer 2, whether it's, I like to call it the data effect, density, attenuation, and distance, being able to handle multiple users. So it all goes back to the hardware. I mean, we talk about software a lot, but software never fixes physical problems. So that starts with good hardware. And once we have that good hardware, we can add the density. So then that takes us into the mobile data offload function, because now we have a good baseline, a good foundation to be able to connect those customers. And then we start using the software and the other interfaces, like diameter interfaces, the integration with all of that on the mobile packet core to be able to push data, whether it's through the P gateway or through an IP gateway. And we start making decisions, and we start looking at things like open roaming. We look at things like Passpoint. And then we want to start doing things with the software like push button Passpoint, where it's very simple for our operators to push a button, get a Passpoint clearinghouse, be able to bring someone in, whether it's themselves or someone else for the venue, and be able to push them out. But at the same time, you talk about QoS, which I love QoS, and you talk about QoE. I'm like, this is my dang talk track. So, but one of the things that we do at Ruckus is next-gen QoS. We're doing QoS mirroring. We're adding AI into our QoS, and then we talk about quality of experience and all the metrics and KPIs that go into that to be able to have that level that our operators need. With our ARPU shrinking the way it is, every customer that they have today is one that they need to keep. It is so hard and so competitive to get new customers, so that quality of experience, but I'll add one more QoE to it, it's the quality of efficiency. And we all know that the more efficient you are with your spectrum, with your clients on and off the network, the byproduct of that is aggregate throughput. And that aggregate throughput gives you the flexibility to be able to add the density of the users onto the network. So that's where we're pushing everything.
That's great. And without disclosing too much, do you see all that converging into a Ruckus One type architecture?
Absolutely. I mean, what's great is Ruckus One, everyone has looked at it historically as a cloud-based controller. The controller functionality of it is less than 10%. It's a software delivery platform, and that's where we're heading as a company. And so look to see all there.
Interesting. Let's move then into the compliance program. So once you have the even more automated features, definitely we'll be happy to help you testing it. And great.
Sure.
So maybe, Thomas, I would like just to bring one point on this convergence opportunity, which is voice and Wi-Fi calling. You mentioned working with China Mobile. So there was this recent paper where, the Chinese carriers come together to work on Wi-Fi calling. It was one of the countries still not enabling it via EPDG. So from your standard standpoint, how relevant is voice in this context? And you believe Wi-Fi calling will be enabled soon in the region?
You mean the spectrum?
Yeah, the Wi-Fi call, yeah.
I'm keeping asking for this question. Maybe next year also the same.
Next year will be...
It's a difficult question. I cannot make decision for China regulatory agencies.
You are working hard for that mission.
We are working on that.
Okay.
But what we can do is that the regulatory thing is always driven by the requirements of the industry. If the industry driven is strong enough, it's possible. So what we can see is that from the point of the alliance of WAA, we have three major things we're going to do. That is maybe drive the next generation Wi-Fi to go very high level, never reached. First one is about AI. Not only to integrate AI technology into the networking and Wi-Fi technologies, but also to predict and fulfill the real AI requirements that I think the previous speaker said that the traffic model changed very differently. So this is a very major thing that we're also using the technology of the network and terminal collaboration. This is a very useful one over there. So this is the first thing, big thing we are going to do. The second thing is that about the sensing and the campus. Because sensing is very, very important right now. This is a data generator, and it is provides the fuel of the AI calculation.
Yep.
So in this case, we combine the campus standardization of the experience of user and the sensing is a major thing that I saw many of you are talking about the user experience. Please join WAA because we are doing the same thing.
Yeah.
And the third thing is I think never mentioned today is security because 802.11 already have a new work item focused on the PQC, that is post-content computing. Cybersecurity is not only the algorithm; it's a whole system. It's a whole system design.
Yep.
And this one, especially when we talking about the data sovereignty or AI sovereignty, the cybersecurity is the key issue right now, and especially when the Q day, which is quantum computing to become commercialized, it may be much earlier than expected. In the past, we think it's 2035, but right now people say maybe 2030. It's coming. So it's a huge impact that if we are not ready, everything's done.
Yeah, we have the project approved on quantum.
Yeah, of course. So these three major things we are going to do that. If we have that one to drive the industry go forward, I think it can influence the China government to considering the 6 gigahertz for Wi-Fi.
Yeah, let's continue working together.
Yeah.
Absolutely. So maybe at this stage, I would just ask if there's any quick question to our panel on this next-gen path for future convergence. Okay, looks like not. So maybe that's a good segue for us to answer the question. So in terms of your closing remarks, I would do a round on how do we scale and accelerate adoption? Because, people is putting out these RFPs and they're always waiting for the next generation. So now Wi-Fi 8 is coming. So what would be your thoughts in terms of getting us faster to market with this, QoS, Wi-Fi 8 eventually? Let's start with Mario.
So let's try to do a quick response because I know that we are short on time, but I think at the end of the day, from what I see, from what we see at Helium, like QoS, QoE, the two flavors of QoE that were discussed here, I think being able to horizontally integrate the stack and be able to expose common interfaces for provisioning and operations of Wi-Fi, I'm talking specifically about mobile convergence, is the path to acceleration. Because in the moment in which in Wi-Fi 6 and Wi-Fi 7, those things are nice to have, like it's been so far, to be fair, for QoE and QoS. Now, if it becomes a requirement for the carrier to do mobile convergence, then if an adoption, a widely horizontal adoption through open source standards and standardization groups that go beyond just a nice architectural diagram, but actual proof of concept and code that can be actually shared, I'm really big on that point. I think that will accelerate the adoption of new gen, because it will allow the industry to move faster, to move with requirements that are clear, they are shared, and there's common platform that can be built upon. So that's what I think we need for next generation to advance faster.
Wi-Fi delivers on it.
Yeah, I definitely agree with Mario here. The reference baseline that would allow everyone to play on the same ground would be very crucial for adoption of new features and new protocols, Wi-Fi 8, Wi-Fi 7, and beyond, right? So I think that initiatives like we do in WBA, operator-managed Wi-Fi reference architecture, and compliance of all the vendors with that architecture would be key for everybody to keep up with the new generation of new protocols, right?
Yeah, for years we've heard Wi-Fi is not managed, so this is kind of the answer. What about you, Mick?
My quick thoughts are participate and iterate quickly with your colleagues, right? I mean, that's how we build things quickly. It's baked into the culture, whether it's NASA or Plume or anywhere else, right? So please participate with us.
Interesting, thank you. Jared?
Very similar, now not how, right? That's the motto on our team. My boss is sitting in the back. I'm sure he's happy that I remember that. But yeah, now not how. All of the things that we're thinking about, it's a big push to the market. 3 words really come to mind for what we're focused on. That's mobile data offload in the play for convergence. We see 12 to 15 months, whoever figures out the convergence play owns the industry. And we're really there at the tip of the spear on that.
So Wi-Fi as the offload platform.
It's funny. Everyone thought it was going to be CBRS, and they invested a bunch of money. And then about 2 years ago, we saw everyone come back and start talking about Wi-Fi, the workhorse, right?
No, and then from Ruckus standpoint, it's interesting that perspective is arising, and so it seems
it's the next gen of offload.
Thomas?
My answer is simple. Convert interest, because this, everybody say I have a very good product, but nobody knows. We need standards and certification to convert trust. That's what we do right now, and especially in the AI age and for the user experience. Thank you.
I labeled and everything. Well, guys, I think it was very insightful, at least for me. So thank you for participating and sharing your thoughts. I hope everyone enjoyed. So if you want to grab our panelists, they will stay around. But thank you so much for your participation. Thank you.
Thank you.
Thank you, and if I can ask people to take their seats. I'm Dean Bubley, and I've got a slightly noisy microphone, I think. I'm the moderator and chair for this final session of the day, and we're going to be looking at innovation, both for enterprise and also for carrier and service providers. I'm an industry analyst and commentator and advisor. You may have seen me before at these events and others. I cover a lot of different areas. So Wi-Fi is a major focus of mine, but I also spend a lot of time on 5G and increasingly 6G, and I'll talk about that tomorrow in the final session on sort of forward-looking things. But I'm also interested in things like the evolution of combining networks with sensing capabilities. We'll touch on that during this panel session. And we've got a whole set of speakers up front who are going to be talking about different forms of innovation. I have to say, walking around the show floor, I've been and looking at some of the other agendas in some of the other rooms, I've been quite impressed that this is probably one of the first general telecom events I've been to when there's actually been some serious focus on indoor wireless. Maybe not in some of the hardcore AI RAN groups, who I rather surprised when I asked them how that would work in a building like this, where either we're on Wi-Fi or an in-building cellular system, but they're getting there. What I'm hoping we're going to get from this afternoon, though, is just a sort of a view of essentially all the cool stuff that's happening. We know that there's this sort of standard progression and improvement in performance and everything else, but there's a bunch of extra stuff we can do with Wi-Fi and adjacent technologies. And hopefully both in the upfront presentations, then the panel, we can tease out some of what to expect next. This is the sort of final session of the day. I realize people have been sitting, watching a lot of PowerPoint, be a bit more here, but I will also be keeping an eye out for people with questions. So, I'll try and leave some time at the end of each session, and I'll beat up the speakers to keep to their allotments. And if you've got questions, there's bright lights at the back, but I'll try and see you. Otherwise, hang on for the panel session at the end, and we'll bring them in then. Otherwise, I'd now like to introduce to the stage our first speaker for this session, and that is Cameron Dunn from AT&T. Now, I heard Cameron speak at the WGC event in Dallas talking about the role of Wi-Fi for in-building. My understanding is this time he's going to be talking about outdoors. Cameron, over to you.
Thanks, Dean. Hey, everybody. My name is Cameron Dunn. I'm Assistant Vice President for In-Building Solutions at AT&T, and I really appreciated the opportunity to speak today about an event that we did in August that I thought you all should probably hear about as well, because we're pretty happy about it. In my position for In-Building Solutions, we're responsible for making sure that over thousands of public sites, we have the best connectivity solutions at the best cost for AT&T for in-building, from sports arenas to offices, from airports to casinos and everything in between. And as part of that, part of my team is also responsible for Wi-Fi and Wi-Fi access in particular. And that Wi-Fi access team is also in part responsible for supporting temporary events, specifically for Wi-Fi offload, when events have a high density, high population, high congestion on the cellular network. And it was at one of these temporary events that I want to talk about now and let you know how it went. So we can go to the next slide. I guess I can do that. And so the event that I'm talking about it occurred in Sturgis, South Dakota, as you can see from the picture behind me. So just for background and context, in 1938, 9 friends took their motorcycles to the Black Hills of South Dakota and raced around, probably got drunk, did some stunts. And from that event in 1938 to today, it has become a 10-day full event in South Dakota where hundreds of thousands of participants come on their motorcycles and have an event that within a town that has a population of 7,000 grows to north of 500,000 during the 10-day event. And I'm talking about the world's biggest motorcycle rally, the Sturgis Motorcycle Rally in South Dakota. And so for this event, and because it had high congestion and high density, we had been deploying a Wi-Fi solution for outdoors to supplement the traffic and allow for offload during this event. And we have been doing that for at least since 2020. But this year was somewhat different. This year, we had upgraded our outdoor equipment that we use for these temporary events to Wi-Fi 7. So for us, this was our first Wi-Fi 7 outdoor deployment to support events such as this. And we were excited about demoing and understanding how Wi-Fi 7 would add improvements to what we were already experiencing for offload and for our Wi-Fi deployments. And so we took this unique opportunity to do some metrics and some data analytics and comparison for the data that we could derive so that we can understand how Wi-Fi 7 was doing better than previous years, as well as how Wi-Fi 7 did for user experience comparative to the underlying cellular network. So we took the opportunity to bring boots on the ground. We had people there that were testing during the busy hours and multiple days, as well as taking the metrics off the access points and the Wi-Fi system itself. What we found is that during the event, and we'll talk about this in a little more detail, we had over 22% of all of the AT&T data usage during this event for 10 days was offloaded to our Wi-Fi 7 solution. So we had what we thought was a very good data set to understand what had happened during that event. So where do we do it? The top right, you'll see the pink. These are the buildings that we actually deployed the Wi-Fi 7 assets and the access points. More importantly, to cover the bottom left, which is the purple on the coverage area that we targeted for coverage. You'll see cutting right, divided right in the middle of this map is the main drag. So when you see collateral videos, et cetera, of the Sturgis event, you see a lot of people having a lot of good times. It's usually along that main thoroughfare, which was critical for us to have coverage. You'll also see that there are other areas that we focused our coverage in, especially in the Northwest, where there are stages, there are concerts. I think there's even a massive beer garden, which shouldn't be too surprising for the event. So we had as much coverage as we could in the downtown area as we could for this event where we thought the large population would be. We had 90 access points, 29 switches. Given that it was Wi-Fi 7, we were supporting both 5 gigahertz and for the first time 6 gigahertz. We had a backhaul circuit brought in, as we do for these temporary events, which was 5 gigabytes up and down. We were on 15 rooftops covering over 1.5 million square foot of coverage to try to get as much of the event as possible with this Wi-Fi deployment. And what were the results? One surprising thing for us was the year-over-year rate of data growth from 2024 to 2025. That rate of growth was 186%, where we did about 14 terabytes of data in 2025 off the system. We think this was due to data usage patterns, but also the fact that we think we were able to deliver more data throughput through the Wi-Fi 7 solution. It was also notable that it was 4.5 times more data than when we started measuring this back in 2022. So there is a data usage pattern that's gone up year over year. It was notable for how much data was being used for the people that were there. Secondly, we had over 31,000 unique AT&T devices that we captured that did seamless authentication via Passpoint onto this Wi-Fi 7 system. And we don't have the statistics on how many have connected in years past, but 31,000 did surpass how many we thought would be connecting at the time. Now, one statistic I missed, I did mention 500,000. The way that actual metrics of the people who participate in this festival are counted is the State Patrol parks cars on either side of that long stretch you saw on the map, the main street, and they count license plates, and they look for unique license plates. And there was over 540,000 unique license plates that had cruised up and down that strip. So we know that we had a sizable, large number of folks at this event, 31,000 of which were AT&T subscribers that did authenticate. And out of those 31,000, their average data usage was approximately 440 megabits. Another key statistic for us was the device breakout. We were able to measure which customers were using the 5 gigahertz versus which percentage of customers was using the 6. And we assumed that there would be a discrepancy, and we assumed erroneously that it would be a wider discrepancy between those that would use the legacy 5 gigahertz versus those that had the newer devices that supported 6. And we were happy to see that the ratio was split 60-40, with 60 on the 5 gigahertz and 40% on the 6, which gave us a little more confidence that we were getting more device penetration for support of 6 gigahertz and that it had been growing. So how do we do in terms of data experience? So for the 5 gigahertz, we had 4.5 terabytes of data, a little north of that, with 3.25 for the upload. And we were averaging speeds of about 83 megabits per second for download and 33.5 for upload, which was a good user experience or good enough user experience for us as an offload solution when you had that much congestion in that geographical area. What we were really excited to see was what we were seeing from the 6 gigahertz side, where it did a little bit less in terms of volume download and upload, and 3.3 on the download and 2 3/4 for the upload. We were seeing speeds at an average of 191 megabits per second on that download and 47 megabits per second on the upload. We were seeing considerable speeds increases with that 6 gigahertz, and we were expecting to see that, but I don't think we were expecting to see it quite that fast. So we were very pleased with seeing the speeds in both 5 and 6 gigahertz during the event. The next thing that we wanted to do was comparative analysis on how we were measuring to our cellular network. So one challenge that we face occasionally is ensuring that when we do move a customer off of the cellular network and onto a Wi-Fi network through passpoint authentication, that we are doing so without a severe degradation in user experience. What we saw here is that it proved that we did not have that, and that was not the case, that the user experience was commensurate for the cellular network, which happens to be 5G in Sturgis, versus what we had with our Wi-Fi 7 deployment. So as you can see, our average for the download was 115 megabits per second on cellular with 34 up. Comparatively, in the Wi-Fi experience in aggregate for average, it was 95 for the download and 39 for the up. So we're very, very pleased to see this because we wanted to ensure that the user experience was as good as possible on the Wi-Fi offload and that we weren't sacrificing that user experience for the sake of getting them off the cellular network. So in conclusion, what our key takeaways were, as noted, was that we thought we got a really good sample size in getting the offload at 23%. We saw some marked improvements in both data volume supported as well as data speeds on both 5 gigahertz, but more specifically with the 6 gigahertz. We saw that we had a large amount of data growth, or at least data growth volume on the Wi-Fi offload, so we saw it as a viable opportunity. And through this exercise gave us a higher degree of confidence that our Wi-Fi 7 investment on our equipment was justified, and that it could be moved on and we could scale to other future events, which we plan on doing so in the coming years. Now, as I said at this top, I'm focused on the in-building side, and we do a lot of Wi-Fi deployments, and we connect to other Wi-Fi networks where we can, especially for in-building and smaller venue types. And we're very happy and very looking forward to seeing future Wi-Fi 7 deployments in this space as well, because we think it will even support even further the adoption of more venue-funded models for in-building, as well as alternatives from expensive solutions or even support for supplementing expensive solutions like distributed antenna systems. So that was my presentation. Thanks for your time, and I appreciate it.
Cameron, thank you. We've got a couple of minutes.
Yeah.
Actually, I've got a first question. Was the Wi-Fi just accessible to AT&T users, or was there also another SSID or something like that for everyone else to use?
This deployment is specific for AT&T subscribers.
So you deployed it essentially as almost like a pop-up extension of your existing network?
That's a perfect way to put it, yeah.
Interesting.
Especially with Passpoint to allow for the seamless authentication, to make it seamless to the customers that had Wi-Fi enabled on their device.
And it was decided to do that rather than having cellular cells on wheels or something like that?
This is considerably less expensive after the investment we've already made in the capital and the solution itself.
Ah, right. So you can move it around to different places.
We do move it down to places. Golf events are popular. State fairs, Texas State Fairs, the next place that we're going to deploy our next deployment. So yeah, when we see the opportunity, we use it.
That's actually very interesting because, yeah, I'd never really thought of sort of outdoor Wi-Fi as a competitor to, well, what are called cows.
Yeah, cows and colts. Yeah, absolutely.
Yeah. Any questions? I see one on the front row. There's a microphone coming.
Thanks very much. Paul Rose, Digital Catapult. So we've got WOW as well as cow now. Now, what was the Wi-Fi solution that you had previously? And do you know roughly how many macro cells you have serving the area?
No, so I I don't have the number off the top of my head. We do have the statistics. I'm happy to share with them later. I will say anecdotally, as I had mentioned, and I didn't say it was a concern, it was more of a curiosity as to how the Wi-Fi was going to do with the cellular network, because when I first approached the network director responsible for this region this year, he's like, oh, we don't need that this year. I was like, well, why not? He's like, well, we just deployed C-band. So we have 5G, so we're good to go, and we got coverage. I'm like, well, I'll deploy it on my dime, because usually the local markets have to pay for the deployment of these. I said, we have a budget, so I will pay for this because I really wanted to demo out the Wi-Fi 7 and see how that did in performance-wise. And I was glad to see him come back and say, you allowed us to not have degradation on our network. The 23% plus or minus kind of talks for itself on how much we actually offloaded during congestion. And so I don't remember the exact number of macros we had, but it did support the fact that it was seen as in a 5G environment being very supportive. Sorry if that didn't answer it, but as well as I could.
There's another question, there, just behind you.
Yeah, thank you very much. That was very interesting talk. I have a question regarding your statistics on the downlink and uplink. And you showed that in the cellular AT&T, downlink was higher than the Wi-Fi AT&T. Why?
The downlink?
Yeah, your downlink was higher from the cellular part compared to the Wi-Fi part. And the uplink.
Our 5G. Our 5G is the cellular. Yeah, no, that was expected actually, because we have C-band 5G for the coverage. So we expected that. What I didn't expect was, and I think this is just me being a novice about some of the technology for Wi-Fi, that the Wi-Fi uplink was actually better than it was for cellular. Yeah. But for the cellular network, we expected that 5G to perform very well, and it did.
And for the uplink, yeah, in fact, the Wi-Fi was better.
Right, and I don't have a real, I think someone smarter than me in this audience probably knows the answer. I've asked it.
I can probably guess, normally cellular networks are dimensioned for more downlink than uplink.
That's right.
Whereas Wi-Fi, I think, is more likely to be 50-50.
Yeah,
right.
Symmetric.
More even, yeah.
Another question there. Oh, Michael.
Yes, if your AT&T subscribers, which I'm one, if they just showed up there, how did PassPoint get onto their phone? Is it just automatic? Does it automatically get on when you subscribe to AT&T, or would it have to have been put on by Apple in the iPhone or Samsung in other types? In other words, do they need PassPoint on their phone, and how does it get there?
So the authentication, as far as I understand it, for PassPoint allows for SIM-based authentication onto the Wi-Fi network. So the Wi-Fi network itself, if it's PassPoint enabled, will take the SIM credentials and use those credentials on the SIM card to be able to do the authentication, to know who you are and to see if you're allowed to use that Wi-Fi network. That's how that function works. So it's not a feature that's specific to the iPhone or specific to the UE. It's specific to the network. Now, the UE supports it through its Wi-Fi protocol, is my understanding, but it's not something you sign up for. It's not something we add to you as an account.
So the SIM is enough when you recognize it's your customer?
The SIM is what's used for that authentication.
Okay,
thanks.
And is there how does prioritization or I would say steering work? Is it a case that if you've got Wi-Fi, you end up on Wi-Fi as a priority, or is it we will put you on Wi-Fi if there's congestion?
Sure, that's a great question. So we do have a solution that allows us to see the congestion on the cellular network. And based on the congestion on the cellular network, we'll then allow for authentication onto the Wi-Fi network. I will say a future state that we're actively working on near time, right time, is making sure that we can get quality metrics real time from both the cellular network and the Wi-Fi network, and be able to marry them up to make an even more intelligent decision so that we're not throwing you to a bad Wi-Fi experience.
Excellent. Right. If we've got one more very, very quick question. I saw the gentleman there. Andy, you may have to come back to the panel. But keep it short, please.
How was the mobility between the two networks? So did you test mobility handovers between a hotspot and a hotspot, and mobility between Wi-Fi and 5G or not?
Did we test the mobility network?
Yeah, so if you're driving on your motorbike down the
Yes.
street, would you go
would you hop to hop?
access point, access point?
No, our understanding is that it was very sticky in terms of the Wi-Fi experience that we were on. There was no reason to go bounce back and forth because we had a wide swath of the Wi-Fi connectivity across the main thoroughfare where the majority of people were.
Excellent.
All right.
Cameron, thank you
Dean,
very much indeed.
thanks a
That was
lot. I appreciate
excellent.
you.
Really appreciate it. Round of
Thanks,
applause. Thank you.
Okay.
That was genuinely interesting and fascinating, and hopefully the next one will be as well. And it's a speaker I've heard a couple of times before, Bob Hawari, who's from Cognitive Systems, who I suspect will be talking about sensing. Bob. Oddly enough, yeah.
Can you hear me okay? Yes? Yes, good, thanks. Yeah, that was a good guess. I will be talking about Wi-Fi sensing. Thank you, Dean, and thanks to everybody here for joining us today to hear about Wi-Fi sensing. So what I'm going to talk about today, really in the context of Wi-Fi sensing, is how you as a service provider or an enterprise can add value for your customer in the context of some real-world motion use cases that we've had first-hand experience working with various partners around the world on. So we want to try and share our experience with you and build upon what I shared last year. So just a little bit about cognitive systems for those of you who aren't aware about cognitive systems and attended last year. Cognitive Systems are a company based in Canada. We're a Wi-Fi sensing vendor focused on value-added services through a software-based solution that can reside not only on a home broadband router, but also it could be resident upon Wi-Fi connected devices as well. So we have various ways of implementing it through our patented innovative technology. As you can see here, actually, this is out of date. We're actually up to around 400 patents to date, with another nearly 200 more that are pending in application. So we are by far the most innovative patented Wi-Fi sensing vendor in the industry. And it's not only backed by our patents, it's not just a research and development arm. We actually have real world deployments. And these are just a snapshot of some of the customers that we have deployments with around the world, not only in North America, but you can see some of the brands that are over here in Europe and even into Asia Pacific most recently. But it's not only limited only to internet service providers. As I mentioned, there's enterprises in a really exciting use case that's focused around elderly care monitoring remotely, which I talked about briefly last year. So we've got a couple of enterprises that we've closed deals and have some real live deployments on. So it's really, really exciting. And I want to try and share with you some of our experience in that space. So just as a recap from last year, for those of you who attended and also for those of you who didn't attend, what I touched upon was how you could potentially, as a partner, monetize Wi-Fi motion. So there are various areas that I talked about. I talked about how you as a partner could use this as a competitive advantage against your competitors to provide a value-added service. So that's one area that you could monetize accordingly from a really highly monetizable Wi-Fi motion use case. The other area was around having specific features. Okay, Wi-Fi sensing isn't a feature just on its own. There are subsets of features that you could deploy with your customers that you could actually charge services for. We have examples of that with various partners around the world. You could also, as a partner, use it as a way of upselling from a particular tier of service to a more premium tier of service. Again, to keep customers onto your network and also add more value in terms of additional revenue from a premium broadband offering with another value-added service addressing a use case using Wi-Fi sensing. And then I touched upon last year two particular use cases which have been seen to be the most popular. One that we call home care. We call it home care. It's really around home security and daily home insights. What's happening in your home when you're home, and also what's happening when you're away from your home in case there is an unexpected intrusion. And as I mentioned earlier, which we have a couple of partnerships in North America and we're growing across the world now, is around elderly care monitoring. So allowing the elderly person to be able to age in place at home safely and be monitored effectively by a family member or a healthcare professional. And that is actually probably, of all the use cases, that's probably the most monetizable one, because a lot of countries in the world, as we all know, have quite a highly aging population. Every country we go to and visit, they all say that their country is the most highly aged population, or potentially will be over the next 5-10 years. And it's actually obviously putting a lot of strain on the healthcare systems, but not only the healthcare systems, also on the elderly person, because they actually would like to be at home longer and be with family members and stay in touch with their daily routines. So that's a use case that Wi-Fi sensing has proven to be quite popular around the world. So what I'm going to talk about today is not in particular, the experience of every single use case. What I want to convey to potential partners who want to use Wi-Fi sensing in a particular use case is how you can optimize Wi-Fi motion in your UX, in your app, in your UI for gaining maximum value. Because at the end of the day, of any technology, what's in front of the customer in terms of the user interface is really going to dictate, what they see, what they like about the service. They may hear about Wi-Fi sensing as a cool technology, but if it's not usable and they don't perceive it to be adding value, they're not going to keep it. They're not going to stay on your network that long. So I want to share with you some key areas of the development of the user interface that would be able to enable you as a partner to maximize the value when you actually implement Wi-Fi sensing for a particular use case. And I'll give you some user journeys and use cases accordingly. So, setup. Setup is probably one of the most crucial steps in the process of adding value. If you do not have an effective and quick and simple out-of-box onboarding experience when you set up an application or a service to address a particular use case, and that user gives up after trying to get it up and running, they're not going to like this. And the likelihood of them trying to download it or calling a call center agent is going to be very, very high. And you absolutely have to avoid that at all costs. Every partner we've talked to in all these use cases, whether it's a service provider or an in-home care provider, what they all have consistently said is you need to have a really simple, effective, out-of-box onboarding setup experience. And we've really focused very closely with our partners to ensure that, so that that setup doesn't take more than 5 or 10 minutes. Okay? There's a lot of other complicated solutions in the world. You could have PIRs, you could have other sensing solutions that can take you 30 minutes, they could take you an hour, it could even take days to set up. And people will just give up. They'll just have technology fatigue and give up. And a lot of people aren't maybe as technical as all of us here in the audience. We all have some sort of technology background. We're here at Wireless Global Congress, right? Wireless. How many people know what wireless means in the context of technology? Or Network X, what is Network X? People in the general public won't understand that. They need something very, very simple. So for example, in the setup, I'm not sure how many of you know how our Wi-Fi sensing solution works. We put our software, for example, and this is in the context, for example, of putting it on a broadband router for a service provider. You put our software onto that broadband router, and what happens is every Wi-Fi device in that home ends up converting to be a motion sensor without actually doing anything on those particular Wi-Fi devices. Okay? It was one central hub, which is the broadband router. So those Wi-Fi devices, so you can see here as in the example, you have a Google Home Mini, you have a smart light, you have a smart plug that are connected to that broadband router with our software. Those are now motion sensors. But you need to make sure that those devices are in the right areas of the home that you actually want to monitor for your particular use case. So for example, if you're going to be implementing a use case around home security, it's logical that you want to have a device near the front entrance to understand whether an intruder has come in the front door or not, or through the garage, or through the back door. So that setup and that guidance to the user is really, really important when you're conveying and educating the customer on how to use Wi-Fi sensing for that use case. The other use case around, for example, remote elderly care monitoring and aging in place, you want to ensure you have a device in the bedroom. The reason that's important is what our solution can do is monitor your sleep. Not only what time you went to bed, what time you woke up, but also how many sleep interruptions the elderly person had at night. Did they go to the bathroom more often than maybe 2 weeks ago? That could be a symptom of an underlying health condition. So if you don't have a device in the bedroom, you're not going to get that data and that insight. If you're not going to have a device near the bathroom, you're not going to know that they went near the bathroom. So again, where the device is placed and having proper choices for your particular use case is extremely important. And that all happens in the initial setup. It's got to be simple, quick, and effective. The other area that's really, really important in terms of a user interface and UX for user experience for Wi-Fi sensing is being able to deliver meaningful messages and notifications to the user. What can often happen is the user could be unintentionally be flooded with notifications that there's motion happening in the home when they don't necessarily need to know that information. Wi-Fi sensing can detect every element of motion happening in the home at any given time. And we could send an alert every 5 seconds if we wanted to. But that's not going to be meaningful for the end user. If anything, they're going to be flooded with notifications and alerts, and they're going to ignore them. You don't want to be at work. You know your kids came home. You want to find out what your kids have been doing. You don't want to be getting an alert and notification every 10 seconds saying there's movement in the kitchen, in the bathroom, in the bedroom, in the garage, in the playroom. You want meaningful, contextual aware alerts. And what we focus on with our partners is focusing on the areas and the transitions between inactivity and activity. And I'm going to show a couple of examples of how we do that so that when you do get a message, that it actually has some context around that. Okay? So those are the two areas that would definitely add value from a Wi-Fi motion monetization perspective. So in terms of the user journeys, what I'm going to talk about, especially in the context now of what I just showed you around contextually aware alerts. Here's an example. We have a service provider who's looking at the journey in the life of the day of their home. Okay? When they're at home, when things are happening at home, and also I'll show you in a moment when things are happening when they're away from their home. So, as you can see on this slide, this is showing what's happening when you wake up in the morning. You want to get a contextually aware alert that tells you, okay, there's a summary of what happened at night, in bedtime. The household went to sleep at 10 o'clock, but they also woke up at 6 o'clock, as you can see by another alert called Rise and Shine. So you can see that the overall household had about 8 hours of sleep. However, as I mentioned before, in the elderly care use case, it can also be used in the context of a family. There were 4 sleep interruptions. So somebody in the family got up 4 times. Maybe they were just tossing and turning in bed, or maybe they actually got up and went to another room. You could customize your alert to say, hey, of those 4 sleep interruptions, 2 of those went to the bathroom, or actually 2 of them went down to the living room and they were playing on their Xbox or something like that. So again, those are contextually aware notifications that add value to the use case and to the user, whether it's a family member, a parent, or anybody else in the family. You could also use it to help automate home actions. So for example, if there's been a period of inactivity, let's say for 1 hour, it's a preset timer that then, meaning that there's no activity, you can then turn down the heating and save energy. Okay? So there's a vast amount of use cases and ideas of how you could use this in the context of activity and inactivity to add value to the end user, whether it's knowing what's happening in the home and also even automating home actions, like I said, a thermostat. The next part of the day in the life is actually what's happening during the day. It's not only knowing what happens when you wake up in the morning and maybe turning off the heating or turning on the heating, or knowing, what's happened at night. It's also tracking when you're away. For example, if you're expecting a service person to come to fix, or a plumber, for example, to come fix a faulty leak, you can actually find out what time they arrived, how long they spent performing the activity, and getting a contextually aware alert to indicate that they've left. So in this example, you can see that they spent about half an hour of work. There was some inactivity prior to their arrival because you left the home. You had to go do some shopping. The service person or the plumber arrived. They did about half an hour's of time of work. And then after that, you can see that there was no activity for about 30 minutes at 2:15. That's one example. The other example, again, going back to the family, are tracking the departures and arrivals for your school, for school, going to school, for your kids. So for example, let's say you needed to go to work early, which typically happens sometimes as a parent, and you've left your child at home who's got to go to school. If you want to have a peace of mind and understanding that they were supposed to have left at 8 o'clock, you get an alert that says there's been inactivity for the last 30 minutes, you get assurance that, hey, they've actually left the home and there's no activity accordingly. Okay? So that's from a daytime awareness. This is an example in terms of the life of the day from a daytime perspective. Again, we talked about the nighttime awareness, monitoring the household, when they go to bed, what time they wake up, the amount of sleep interruptions in terms of out-of-bed activity. We talked about that. That's also very important, not only for the family, but as I said before, for monitoring an elderly person at home who you want to understand their daily activity levels, not only during the day, but also at night. It's not only limited, as I said, to just family awareness. The obvious use case for Wi-Fi sensing is around home security. So if you're not at home, your kids aren't home, you're away on holiday, you're out of action at the home, you want to make sure your home is safe and secure. And what Wi-Fi sensing has been seen to be very popular with a lot of partners is being able to enable basically providing a do-it-yourself home security solution. Not having a professionally monitored ones with cameras and really expensive alarm systems and panels. This is a do-it-yourself, low-cost security system. And what this will do is that it will track when you're not at home if there's an unexpected intrusion. Now, one of the things that's really, really popular when we talk to service providers is, okay, let's say there's an intrusion. We want to do something about it. Let's say we want to investigate it further. We have ways of being able to replay the motion that's happened. So think of a camera that's in the home, and let's say there was an intrusion and you wanted to rewind the camera, or let's say in a premises like here, like with CCTV, and you want to see what's happening. What Wi-Fi sensing can enable is actually replaying and rewinding motion from a Wi-Fi perspective. So what you can see here on this diagram is an image of the real-time activity that was happening in terms of the motion intensity in a particular room. You can see here in the entrance, there was a whole range of motion based on that intensity. What Wi-Fi sensing can also enable is rewinding that, replaying it if you want to investigate how much motion was happening and in which rooms as part of an investigation to understand, wow, is this really a serious intrusion? Did they go up to my bedroom? Did they go into an area where I've had some valuables or not? It's all part of enhancing the value from a home security perspective. Finally, I'm on my last slide, Dean, and then we'll have some questions. I know, I could detect motion on the side. Finally, it's not limited to what we have today. There's a future vision. Everybody's heard of AI. We can all spell it. It's 2 letters. The best thing about our system is it can actually fuse our data from other data from partners, such as service providers, who have really valuable network data. And when you combine that with Ask Me APIs and generative AI and all that sort of thing, you can actually make your home really smart. So you can interact with your home like it's a member of your family, that it has a personality. So you can just, like in ChatGPT or any Gen AI, you can message your home and say, what's happening at my home? What time did my son Johnny come home? Or my daughter Lily? What are they doing now? They'll come back and answer you. Johnny is downstairs in the living room playing on his Xbox, because it has data that knows that there's streaming happening via that games console. So things like that are going to be really valuable, and this is what we're actually talking to a number of service providers in terms of future roadmap capability to fuse the Wi-Fi sensing data with their network data. Similarly, on the caregiver side, there's a lot of data from PIRs and other data and wearables that do fall detection and all that. Again, fusing all that data is really important, and there's a really big opportunity to make that home a really valuable member of the family and provide value at the end to the end user who lives in that home. So on that basis, I'll end there and allow any questions, Dean.
All right, there's a very, very quick question there. Actually, one on that last point, I will also say, as well as sensor fusion, I'm doing some stuff at the moment looking at AI and home for voice or audio. Yeah. And so things like motion detection plus the sound of breaking glass would be an interesting one, for example.
So thanks for the presentation. I had a quick question on the accuracy on when you detect an event. Can you actually localize it? I mean, you talked about the importance of the setup. Yeah, and you said if you want to detect an elderly person in the way it sleeps, you need to have a device in the sleeping room, in the bedroom. If you want to detect someone coming into your apartment and so on. So in regards to some of the work that WEBA has done for MDUs, what happens when you have many apartments close one to each other? Yeah. Can you actually make sure that an event that you detect is actually within your own apartment, or are there going to be a lot of false positives on that accuracy?
That's an excellent question, and it's not the first time that's been asked. A very, very good question. This is what we call the concept of living in a home that has a shared wall. So for example, in an apartment, you have adjacent homes that have a shared wall. What we've been able to do is basically mitigate any motion on the other side of that wall by managing our sensitivity. So there's various levels of sensitivity, really, of how far you can detect motion in the home. And when you look at the characteristics of a wall where, the Wi-Fi signals can propagate to and then bounce off of, we can manage that sensitivity to minimize any of the movements on the other side of that wall. And our system also, in our algorithm, will learn that, and also effectively, from an AI perspective, if you want to call it that, filter that out.
Thank you very much. I think maybe pick that up at after the session. Thank you very much once again, Bob.
Thank you.
Always fascinating, and a big round of applause. Now I'd like to welcome to the stage our next speaker from Cisco's Gino Corletto, who's going to be talking about some security aspects. Oh, cheers.
Okay. So, welcome all. Thank you for sticking with us. How do you feel? Have you left some bit energy for cybersecurity? I'm going to bring it into a very simple way to you. But before we go into the topic, I want to state the problem first. Why are we here? Why are we talking about security? And I brought you a short quiz. I need your participation. What do you think? How large is the expected global damage caused by cybersecurity attacks in 2025? Some of you already know the answer. You have been seeing this already. Is it A, B, or C? And you already have here a hint. So who says A is the right answer? Okay, we have a few. Okay, who's for B? Good. And who says C? This is the right one. Okay, thank you for your answers. So the right answer is 10.5 trillions. This is the worldwide expected damage caused by cybersecurity attack, and that breaks down to $8.3 trillion until today. You might say, oh, this is a big number, how does this impact my pocket? If we break that down to the average citizen in the OECD countries, per average is $630 per month that you are paying for those damages. There is no statement, probably on your bank statement, hey, this goes to the hackers, to the bad actors, but in a certain kind of way, we are all paying for it. So cybersecurity is something which is happening while we are sitting here and listening to this talk. And the bad news is not to be expected to go down, but to go up to 15 trillion by 2029. I brought you just 2 points, and those are really important points I want you to walk out with from the session. So the first one is with more awareness, so that you have more awareness what is happening outside there, and this is impacting us. I brought a small video for that. And as a second point, we're going to discuss what can we do today? What technology do we have? What is Cisco doing, and what is the WBA doing in the industry to push this forward? My name is Gino Corleto. I'm an industry solutions architect in Cisco. I love new technology. I always need to wear things, test it out, and wireless technology, this is really at my heart. Privately, I have one wife, one cat, and a lot of bees. The bees are connected to the internet with wireless technologies, with IoT sensors to measure humidity, temperature, and also vibration to harvest more honey, of course. My cat is also tagged. I always know where my cat is. And my wife is not tagged just for the protocol. So, first of all, let's give the bad actors a face, and let's roll quickly the video.
A hacker doesn't always look like a hacker. A hacker's at home, everywhere. A hacker comes in many forms. He's interested in everything. He can work alone. But with a crew, so much better. A hacker is free.
With Cisco, protecting your business from cyber attackers is simple. If it's connected, you're protected.
Yeah, not every hacker is looking handsome and friendly like this guy. We know this. So the question is, what can we do today? What can we do in terms of security? Sometimes security feels too complex, or it feels far from us. Somebody's taking care of security, it's happening somewhere, or we put a bit of technology into the network and check security is done. Let's look into that, what security means and how we can approach it. So I would like to compare security to our body. In a way, how do we approach our body, our health in a holistical way? So what do we do to be healthy? So we are trying to exercise, we are trying to eat healthy, we are trying to be emotionally healthy as well. So all in all, we are doing something. And our body is doing also something in a kind of automatic way. Our internal system is detecting bacteria, viruses, and trying to respond to it. So it's a kind of active process. So just because the head is important, we just don't protect our heads. We protect our feet, we do something for ourselves. And sometimes we know what we should do. Probably while we're on a conference, we should exercise and move more than that. Sometimes we don't do it. This same concept applies to security as well. So when we see security from this holistic approach, it's not just we need to take care about the endpoints, the data, the AI today, or the human factor. And by the way, the human factor is sometimes the weakest piece in the whole security architecture. Why? Yeah, sometimes humans make mistakes. We are stressed. Somebody's calling us. Hey, here is Cisco IT. Can you give me your secondary authorization key? Yes, of course. Here it is. This is like handing over the keys of our homes, of our apartments, to the bad actor. So we need to approach it from a different view. And this example shows that we are in a race against cybersecurity attacks. So also our feet are important. So the shoes that you're wearing while you're racing, while you want to move forward, those are important too. And this is an important topic we're going to cover pretty soon. So a holistic approach, this is how, this is one ingredient on how we can win this race. What is Cisco doing? Cisco has this big messaging of One Cisco, and you might probably think, oh yeah, great, this is the next marketing term. And yes, it is, but there is more behind it. So what we're doing internally is every product that we're building needs to be embedded into our global secure infrastructure. And just to simplify it, think about a spider building a spider web, and if you're afraid of spiders, think about a different insect who's building a web. So the spider spins single lines, and at the end, the spider is bringing it together. So all the conjunction points are making the spider web really, really strong. The same is happening here. So on the product development side, we are trying to bridge our products, embed security into it, and making a really great and strong experience to our customers, to our partners. This is what Cisco is doing holistically to make things more secure in our networks, into our worlds. What are we doing in the industry? So in the WBA, we're trying to act as the platform for converged security. What does that mean? So what it does not mean is that we are reinventing the wheel again with new security protocols, new security standards. What we are doing is convergence. You have been hearing about convergence all day long on wireless technology. So how can wireless technology converge and create something bigger and better? This is what we're doing in the WBA. The first example is enterprise network security for private 5G networks. Private 5G networks are a 3GPP created technology. It was never created to go through and integrate into the enterprise where you have microsegmentation, zero trust security. So how do you bring these two worlds together? We defined it here, a security architecture. We wrote a blueprint, and now we are in phase 2 to go deeper into how can we leverage telemetry from the network, how can we leverage what we already have in the network, and doing, for example, zero trust, microsegmentation on the private 5G side, just to mention one of the examples. And you see here, different technologies are coming together, and I think personally, this is a great place where we can create something new blueprints, where we can bring all what we created in technology, in security, with wireless networks together and make the world more secure. So, in summary, we spoke about cybersecurity, which is happening right now. The race is happening. What can we do? We spoke about it as well. We need to have a holistic approach, like our body. We are trying to stay healthy in every part of our body, so it is for security. So when you go back maybe into your companies, you go back tonight and speak with your colleague, ask the question, what are we doing on security? Who is doing what, and what can I do to make the world more secure as well? The last point was converged security. So if you're working in the WBA, you are happy to join us in our calls and contribute maybe your point of view, your technology, which can make our networks more secure. So here the last thought I want to leave you with. The race against cyber attacks is moving at full speed. And I'm going to leave you with a question in your mind. The question is, are we using the tools we already have fast enough to stay in the race? Thanks for your attention. If you have any questions right now or also to the end of the day. I wish you a fantastic, great session here in Paris.
Thank you. Do we have any questions? We've got a few minutes. I'll come back to this thing of converging security between the enterprise wireless network and maybe private 5G. How does that work in practice? I mean, is that from a single vendor, from a single integrator? You know, do you have to? Does it work if you've got a managed service and a separate service provider? What's the boundary condition there?
Yeah, that's a good question, and good that we have a bit of time still left, Dean. So I'm going to start with a customer story. So I went to an automotive customer in Germany, and the IT team, they were not trusting the private 5G new technology, that we don't trust them. We're going to put everything against it, and because what we're doing in enterprise is micro-segmentation. This is our security rule, and we can't do it in private 5G. So this is when we started thinking about it. How can we bridge those networks together? And some vendors are already doing it. So there is kind of micro-segmentation. There is this bridge between enterprise network and private 5G. Some other vendors are looking into that, and probably they're going to come into this further development. And what we did in the WBA is stating out what is the glue between a private 5G network, a packet core, and a network that is already there with all the technology. How you can leverage this security policy, which is already there, and bring it into private 5G.
That's really interesting for me, because I mean, often when I speak to people on the cellular side of the world, they start with the premise that the 3GPP core is the umbrella and everything else fits neatly underneath it. But that doesn't work in, say, enterprise, where you've got 1,000 Wi-Fi devices in your factory and you want to have 10 AGVs on private 5G. You're not going to re-architect everything. So, yeah, excellent.
That's a good point. Yeah, just to close this up. So the Wi-Fi guys think Wi-Fi is secure, and it is. You go to the private 5G guys, they say yes, private 5G is secure as well. But how secure it is if you are binding and converging those two together, and this is the white spot we are trying to describe.
Excellent. Okay, really appreciate that. Any other last-minute questions? Oh, you thought you were going to escape there, but you got another minute.
Very much. We usually say that Wi-Fi is secure, but 5G is much more secure. This is what we say, usually, when we want to sell like private 5G. I have a question actually with regards of this end-to-end security. You said the enterprise part and then the private 5G or Wi-Fi or any other run. How does it, how do you guarantee the same level of security from the device generating the traffic up to the service as we are crossing different security solutions?
Yeah, and you nailed the point. This is exactly where we are trying. So wireless security is somewhere here. 3GPP, private 5G security is here, and they're not compatible. And this is where we are trying to build this bridge in the middle, saying, hey, we have different mechanisms which are open. We have open standards which you can reuse in building those two worlds together. Or a vendor has a kind of own technology on how to do that. It's a good question, and this is exactly why we're doing that. Thank you.
Excellent. Okay, well, thank you very much once again. I'll let you escape from the stage this time, Gina. So, final presentation before we go to the panel session. I believe that the next session is actually a video from Paul Lai at Asia RF to talk about Halo. So, unless Paul has magically appeared in the room, I will let someone play the video and we'll take it from there.
Good day, everyone. Ladies and gentlemen, I would like to say thank you for WBA invitation and congratulate this event successfully first. My name is Paul. I'm CEO of HRF. It is a great privilege today to share with you about how Halo accelerates operators' return of invest from Halo Flight to smart at scale. Billions of IoT devices have been promised, but around 70% of projects fail to sell profitably. Operators are investing, but the return of investors is stuck. Yet, Most projects fail to scale profitably. Why? Because connectivity has bottleneck, short range, high power consumption, high cost, and fragmented technologies hold back return of invest for operators. Let's take an example. In agriculture, farmers cannot afford to deploy dozens of base stations just monitor soil or livestock. In logistics, thousands of sensors on plate and truck loads converge the moment they leave urban area. In smart buildings, every new floor requires repeaters and cabling just to connect a few devices. Each case adds cost and complexities. This is why so many IoT projects never pass pilot stage. Think about it. Traditional Wi-Fi in IoT is short range and big power consumption. Cellular is too expensive for many IoT applications. Proprietary low power WAN creates silos and complexity. For operators, this means deploying more infrastructure, spending more, and earning less. That's the return of invest trend. This is where Wi-Fi Halo changed the game. So this delivers long-range coverage up to 1 kilometer distance link, low power operation, so devices last for years, native IP support, seamless integration into existing networks. And it is a global IEEE standard, no vendor lock-in. Compare this to LoRa or Zigbee. Both are proprietary ecosystems with limited throughput. Compare it to NB-IoT, require licensed spectrum and high operator investment. Halo combines the best of both worlds, long range, low power, and Wi-Fi compatibilities. This means operator can scale IoT without reinventing their networks. At HRF, we are not only promoting Halo, we are delivering it. Our latest Halo Fly USB dongle plug in and play in 10 seconds for all operation systems. Make any mobile phone instantly a Halo device. Yes, in 10 seconds. Enjoy iOS mobile phone, Windows, MacBook, Linux PC, all work. Perfect for testing, pilot, and scaling deployment. A full Halo product line, HRI providing. Commercialize Halo access point, gateways, mesh node, and a development kit for sensor and power switches. All easy to use and available right now. And our body-worn cameras, designed for security, law enforcement, and industrial use. While today they are use Wi-Fi, our roadmap integrated Halo for extended coverage and reliability. This is a real innovation operators can monetize. Now, what does this mean for operators? It means low capital expenditures because you deploy fewer base stations. New revenue streams because you can offer connectivity in agriculture, logistics, healthcare, and the smart city market. Higher average revenue per user because IoT service can be bundled with cloud, data analysis, and edge computing. Like this diagram, you can manage the arrival of all EVs, balance the charging load, initial full charging at the start to ensure a great initial charging experience for everyone. and then continue charging smoothly to provide steady and intelligent energy distribution. Wi-Fi Halo compared with the satellite, you can say satellite is a Starlink. Halo is grounding to extend the access. In agriculture, Halo makes it much easier to link vast farmland sensors and smart devices, even across a long distance, ensuring farmers can monitor soil, water, and crop in real time. In logistics, Halo can fill the gaps where communication often fail, whether it is the remote warehouse, distribution center, or moving vehicle, keeping the supply chain connected without interruption. In marine industrial, vessel and onboard machine often struggle with connectivity. Halo is the perfect solution to enable stable communication within ships, between cabins, and even across the port facilities. In a wiring, where storage area, vineyards, and control centers are often far apart, Halo can seamlessly connect operations, ensuring quality monitoring from grab to bottle. In offshore wind farm, we can use one 4G or satellite gateway at the main station, and they rely on the Halo to connect all the other turbines. This approach can save a huge amount of communication cost when maintaining efficiency. In all your wheels, Halo's unique long-range linking ability provides reliable connections in places where traditional Wi-Fi cannot reach. And in all your refineries or dangerous chemical factories, safety is always the top priority. Using Halo ensures the secure, low power, and stable communication, helping prevent accidents and protecting the workers' lives. As you can see, across agriculture, logistics, marine, wiring, renewable energy, and heavy industrials, Halo is not just a technology. It is a practical enabler that lowers cost, increasing safety, and create opportunities for smarter operations. At HRF, we invite you to partner with us with HaloFly, with connected devices, access point, gateway, mesh node, and also our body-worn camera, and with new IoT devices and the service. It will define the next decade. Let's accelerate the return of invest and make the IoT truly profitable. Together, thank you.
Thank you. And unfortunately, that was pre-recorded, so we can't take Q&A even remotely on this one, I'm afraid. But I'm sure that there's a channel to contact, whether it's via LinkedIn or email. Right. Now I'd like to welcome my panel to the stage. I'd say sit anywhere unless they're going to put names up and pictures, in which case sit underneath them. And we're going to round out today by, well, the panel title is Delivering Wi-Fi with Enterprise-Grade Performance, but I suspect we're probably going to be talking slightly more broadly than that. While I'm standing up, I'm going to take water. So, we have 4 panelists here who have different angles on innovation and what's next with enterprise and to some extent service provider Wi-Fi. And 2 of them, Eric from Intel, Matt from Cisco, you've heard from already, but I'll ask all panelists to introduce themselves, who they are, their companies, and sort of what cool new stuff you're doing briefly, and then I'll jump into questions. And I'll start at the far end with Stu Goomans from Ekahau.
Yeah, so I think it's working. There we go. So I'm Stu Goomans from Ekahau.
My title is Director of Community and Customer Engagement. What it really means is I get to talk to my customers, our customers, a lot closer and understand kind of what their needs are and how we can drive product innovation, right? To expand on that and then understand what they're doing. How do we make our products better? And then get right under the forefront of things. Sorry, it's too long.
That's all right. No, fair.
But I am based out of Vancouver, Canada, so this is my first time to Paris. And
oh, right.
I'm actually enjoying it. The architecture is amazing. But I do apologize. My French is very basic, but I do wish I could speak actually a little bit of French today, but we'll pass that along.
So Matt McPherson, I'm the Enterprise Wireless CTO. And everything we do is cool, I think. But I will say one. Even
cooler.
So what's really cool right now is we're working on new technologies to handle edge conditions. So whether the edge be AP to AP, indoor to outdoor, whether it be satellite to LTE or to Wi-Fi, that's the latest thing that we're working on. We really want to make this convergence complete, and so it's been a lot of fun.
Eric McLaughlin, I'm the VP and GM of the Wireless, actually Connectivity Solutions Group. We changed our name because we're managing all the different connectivity aspects at Intel. So cool stuff we've been working on is just making primarily your laptop experience with wireless just seamless and easy.
Joe.
I'm J.R. Wilson. I am Chief of Networks and Spectrum at AST Space Mobile. AST Space Mobile is a purpose-built direct-to-device satellite provider. Basically, we're building the world's largest LEO satellites and creating a constellation that'll work with the billions of devices worldwide, unmodified, without having to have any type of equipment in between.
Joe, I've got to do a bit of a follow-up on that because I'm very curious. I mean, obviously you've got a long history looking at Wi-Fi. What is the link-up you're seeing between satellite connectivity and Wi-Fi?
Yeah, so great question. Look, to me, the satellite is another transport mechanism. I mean, if you want, the topic is enterprise-grade Wi-Fi. So the preference from my perspective is, you're always going to lean towards fiber fed. I mean, that's going to provide the greatest amount of fuel. But when fiber isn't available and it's either, more antiquated technologies or there's no coverage, then satellite is often the best alternative. Obviously, there's different flavors of satellite out there. I mean, going from what was traditional VSAT, and that was like, for example, how you would provide the transport layer for a cruise ship business that effectively has a wireless DAS. And then it's evolved to satellite broadband. So like Starlink is a really, really good satellite broadband solution. More consumer, but now they're getting into more enterprise. OneWeb has been more of an enterprise grade, call it satellite backhaul for enterprise, and then soon you're going to have the D2D solutions like AST Space Mobile. So it each has its place in the ecosystem.
I'll come back to some more of that later and find out if we have unlicensed satellite connectivity. But for now, let's park that. One of the big themes walking around the rest of this show, and indeed any show in telecoms and networks at the moment, is AI. From my perspective, at the moment, Wi-Fi is being a bit more selective about its AI use cases rather than some of the sort of AI native hype and AI RAN that you get from cellular. It's much more focused on AI ops and a few other things. So, is this changing? Are we going to come back and say Wi-Fi 8, Wi-Fi 9 will also be AI native, or are we going to tone down the hype? Well, who wants to take that one? Stu, I'm going to find this for you.
AI plays an important role in a lot of the networking aspects. And from a Wi-Fi perspective, we're in that, not the early days, we're in that days where we're allowing, how should we apply specific RRM or type algorithms to Wi-Fi? How do we make it better? Is it broke, right? Or how do we fix it? But from an AI, I see it as, how do I see this? Is that AI is there for us to use, but I still think that it's still a little bit more, there's a lot more to learn and to teach it.
before we start letting it go and letting it run and configure those networks.
Right. So, and that's in terms of the sort of like management console and AI ops. Are we also seeing it sort of down in the nuts and bolts of the radio?
Yeah, I think so. I mean, Eric brought it up when he was doing his presentation. I mean, if fundamentally radio is an analog technology, and analog by nature is going to be harder to analyze. And so when we're doing things like sensing, the ability to apply AI to intelligently interpret something that looks like a mess to a human, to determine that, hey, that's a person that's fallen, that's a person that's standing. Eric was talking about breathing. These are perfect AI type applications. And once you start better understanding the RF, then you can optimize it.
Eric, so is that your main focus at the moment? Is you mentioned the sort of making the laptop experience better, but is it sort of broader than that from your perspective?
Oh, yeah, definitely. So I think 3 areas for us, right? We hit on it briefly. Can we use AI to fix problems real time and just dramatically decrease the mean time to resolution? So very AI ops-centric, focus right now. Looking at, sensing technologies and context awareness to make the experience with your devices and your network much more personal. Understanding where you're at, what you're doing, what are you most likely to do, anticipating those things, knowing what you typically do with your device at that time of day and that location, making sure that all that information is there and available and ready to make sure it just does what you're expecting it to do, right? So I think those type of things. And then last but not least, there's a lot of workloads going around the network, and wireless is going to be inherent to making sure those workloads get to the place they need to be, or get the data back into the device so that you can use that AI, analytics or whatever it is to actually enhance the experience.
So are you using it for things like beam management, for sort of beamforming?
I think over time, for sure. We've got a few things like that going on in the labs. So, yep.
Cool. No, I'm just trying to sort of level set it, compared to some of the stuff I hear from the cellular industry and other parts of the network world. Stu, from an enterprise point of view, is there conservatism about this still, or is there worry about jobs being replaced or changed?
No, there is, but there isn't at the same time, because you got to take it that AI piece is actually, it's got to work together, right? We have to work it together and then help us enhance the experience. When you talk about we know that the operations piece and the back end, that's key. But when we're looking at the planning perspective, we can leverage AI to make it easier and speed up the process. If you've been in Wi-Fi for a long time, many of us here, we used to do it like we measured it out. We measured it, we knew where that pattern was going to end until we started having software to tell us exactly how far away that pattern was. Now AI is efficient, making it more efficient now, and making it that we'll place it down there on the map for you, and then be able to say, okay, well, we already know what the antenna is going to do, its capabilities. And like I say, it's an analog piece, but how do we apply those algorithms to push it out? And it's getting better. It's getting better every iteration, and Wi-Fi is a funny thing, is that it's, someone once said to me, is that it changes, if not by the hour or by the second, right? As the standards change, and it is true, because now we're seeing it in that next iteration of AI bringing Wi-Fi designs.
I'll look forward to the Wi-Fi 9 or 10 with the spiking neuromorphic chips for the analog AI techniques. I'm not making that up either, just slightly, but yeah.
Yeah, so here's how I think of it, and I mean in the context of the WBA as well, and kind of why I think most of us are here is we've been trying to solve this issue of convergence. And when I think about what's the roadblocks to solving it, it really goes back to network selection. And then where does network selection occur? Network selection largely occurs in the RAN. There's some protocols in the device, certain algorithms, et cetera. So do I think AI is going to exist in the RAN? Absolutely. And then in combination, there's going to be whole new data sets, metadata. So like the satellites. Now we fly a satellite, broadcast a PLMN ID, we can see every hole in the network. So we know where the dead spots are. You start combining that data, and then you figure out the network selection piece so that all the edge use cases, the device seamlessly goes in and out of Wi-Fi and terrestrial. That's what we're here to solve. So, and I don't think in terms of like, you know, people's jobs, I'm not aware of anyone who's like flipping the network selection switch on the wall right now. And if they are, they're doing a really bad job. They need to be fired anyway. So.
I'm going to remember that one. I like that. Okay, so on the prep call for this, we talked a fair amount about positioning and location, and sort of, and I think that then extends out to sensing as well. What's happening? I mean, for things like in-building location, is anyone using Wi-Fi in Vengeance and then exposing that via an API for a developer to work out where things are for asset tracking stuff? How real is that?
No, it's very real. So we have a Spaces platform. We've been doing location services going all the way back to when we were using RSSI to triangulate off of APs. Of course, it wasn't that great, right? It was, 10-meter accuracy, so maybe you're there, maybe you're there. But as we go to FTM, as we go to ultra-wideband, now we're getting location accuracy down to here. The better the accuracy, the more applicability or the more applications that it can apply to. So I think this ability at layer 7 to track assets, hospitals love this because they lose all their equipment, so they want to be able to find it. They even lose their nurses and doctors on occasion, sometimes patients, but they like to track these things, right? So this is something that's working very well. In fact, Cisco has a complete open ecosystem where you can use the open APIs that we have both going into our Cato solution as well as going into the Meraki solution for cloud, such that you can create an application that'll use those APIs. And so you don't have to call us to do interworking, you can do it yourself. So you can start to build applications on that. We have a complete app store from all sorts of partners that are doing it.
Well, that location tracking piece is key because it's the sensing and understanding, but it goes down to the core network design, right? Is that AP placement, do you have it right? Because you have to trilaterate, right? And in order to, because we're not triangulating yet, but cruise ships are using it now. They're starting to augment the APs in a way so that they can use the Cisco Spaces piece and to actually for kid tracking, right?
I had one couple of discussions which was saying that the places you'd put APs for good broadband is not necessarily the same place you'd put them for location tracking or things like people counting or anything like that. How do you deal with those design trade-offs?
Yeah, it's interesting because we are having that conversation as we speak. We're working with companies and partners like Ekahau, for example, because right now, when you go to provision a network and you're going to place your APs, they'll give you a simulation and they'll give you a pretty good idea. And what you're doing is you're basing it on coverage. Maybe I need an extra AP because I can't get around a stairwell or whatever. But when you start doing triangulation, and triangulation now is based on timing, it's not based on energy now, timing, which is much more accurate. What happens is that to be able to get that triangulation, you actually need APs now at the edge of your building. Because if you start moving beyond the set of APs that you have, you start to lose the accuracy. And so we're seeing densities go up, and we're seeing the placement to include the edges. So it's in process. The tools now are taking that into account because we know it's not just an access application anymore.
Is that around the edges so they can get GPS for timing? Or?
So, well, that's interesting too. So it was actually around the edges so that you had enough APs to triangulate when you're at the edge. But that's also true because what we're doing is using GPS to locate the edge APs, and then we're using FTM to locate all the APs in the center of the building. Now, when we go to Cisco Live, we talk to a lot of customers, and we've asked our customers, anybody that runs a big network, they're lying to you if they say they know where all their APs are. And so every customer I've talked to, if you're deploying thousands of APs, they don't know where they all are, right? And that throws these location algorithms. So the fact that we're auto-locating now, and we can actually tell you that some guy that's painting the ceiling or something moved the AP and forgot to put it back, now we actually know.
Actually, JR, there's a cheeky satellite question here, which is, in some parts of the world, GPS is becoming progressively less reliable because of jamming and spoofing. Are you going to be delivering sort of, positioning and timing as well?
We haven't disclosed anything. I mean, we're certainly aware of it, and for that matter, AST, we've got very close relationship, I think folks know, with various government agencies, so.
Okay,
we haven't
I'll draw my non-AI inference from that, but yeah.
There you go.
Okay, what about leaving aside the satellite thing, what about the links between the enterprise Wi-Fi access points and other technologies? I know you were talking about having turning access points into multi-wireless hubs with Bluetooth or Zigbee or something else. How real is that? Or is that something that's starting now, been going for a while? What's the roadmap? Eric, I don't know if you got...
Well, I think, from a device perspective, most of the devices out there already are multi-radio products. And so on the device side, we've been used to, the coexistence requirements, management of multiple pipes, those kind of things, and knowing, what traffic should run on what pipe for what reason. It's been in existence for quite a long time. So I think, on the AP side, certainly already there as well, and, becoming more and more. So things like, Matt was saying, on location, you're going to need a combination of what the device sees and what the network sees, and coordination between those solutions. So, we can't do asset management type things and do, fencing, geofencing, and those kind of things without the two of us working together to make sure those things function accurately and consistently. So I see a lot of work already being done and making sure that we're coordinating across all those radios to deliver the experience that particular radio can give.
Yeah, we were talking about AIRM, and all the vendors are doing it now, and it's an important technology. You were talking about trust. Do they trust it? And we've been doing AIRM now for multiple years, and we're still getting past that trust issue, right? Because typically what happens is that AIRM will calculate a better spectrum allocation, and then based on that, a human still wants to push the go button. So it could just do it, but most customers don't just do it. They use AI to calculate it, and then they'll push it at 4 o'clock in the morning, or whenever they schedule the downtime. But then connecting this into what Eric just said, I often, a lot of RF experts here, so I don't have to explain this, but, I'll hold up my phone, that has an RF characteristic. Now I changed it. That's how fickle RF is.
Yeah.
And so if we're looking at all the RF, but we're doing up there at the ceiling, the RF characteristic that's down here can be quite different than what the ceiling sees. And so if you start to exchange that information, we've calculated that you can improve your radio resource management algorithms by 20 to 25%, just because we're talking. And so there's huge gains to be realized.
I think there's an awful lot we can still squeeze out of, whether it's Shannon or anything else with this sort of optimization. I think there's one that amazed me. I talked to someone talking about 6G, and they're actually thinking about putting antennas on a robotic arm in and out from the cell tower, rather than just tilting, and just for sort of optimization of the propagation characteristics. So probably we got a little bit of robotics meets AI meets wireless coming.
You just scared the hell out of me when it comes to the AFC.
It's kind of shocking, though, to think that there's still people that have to go out and touch an antenna and point it and angle it.
Well,
think about
you've
that
got auto tilt, and I think it's Rakuten saying they ran that in Japan, and they got sort of 25% performance gains out of it. But I come back to the satellite aspect. I'm still curious about what is. We've got a fair idea about the convergence between cellular and satellite, what that will look like. There's different models of it. We know there's various approaches to convergence between cellular and Wi-Fi, and they've had mixed success over the years, and hopefully it gets a little bit better with... I believe, Matt, you were talking about divergence as well as convergence, which are fun.
I learned that from you.
It's one of my. I've been talking about that divergence for 20 odd years. But what does the Wi-Fi and satellite, leave aside cellular, Wi-Fi and satellite convergence presumably that's not going to rely on a 3GPP core. What's the signaling layer look like for that? Is it going to be tied into a sort of cloud Wi-Fi control, or is it going to be I don't even know what for a LEO satellite, what the sort of operating system is, or sort of controller layer?
Yeah, I mean, look, for me, it's impossible for me to answer that question without thinking of it from the context of cellular and satellite. And let me just start there for a second. Again, I mean, I just view Wi-Fi as a radio technology that hangs off of some transport. Again, whether it's fiber, satellite, or copper, etc. I don't know that most people do really understand what satellite and cell phone convergence looks like, because we're at the very beginning of being able to experience what D2D, direct-to-device, is all about.
True, but we've got NTN standards in 3GPP release 17, and I mean, is there a satellite standard in IEEE for 802.11? Is there 802.11.b?
I'm sure there is. I'm not the IEEE
or CS
expert.
or something for satellite connectivity.
Yeah, I'm not the IEEE expert. I go and solve problems around the world, and I'm going to make people's phones work when they're driving down a highway and they have 1 bar of coverage and they're hanging on the terrestrial network and it sucks. They can't make a phone call and they can't have a data session. We're going to go and fix that and fix it globally. So our goal is we're not going to be the #1 carrier in any given market, but we could be the #2 and #3 carrier in every market around the globe. So that's what I think is going to be the convergence story, and it's not fundamentally different than what the WBA has been doing in terms of getting cellular to talk to Wi-Fi and handshake in a very seamless way.
Well, that was a convergence piece, right? Is that we would have been talking about this week, is how do we make sure that that handoff is better? How do we make sure that handoff between the Wi-Fi and the cellular is better, and then back and forth?
Yeah, this is a mindset too. When we first started doing 6 gigahertz and we wanted to go into standard power and we wanted to put it outside, who was complaining? Well, it was the satellite guys and it was the point-to-point guys. Right? Because what you're doing is you're encroaching on a business model that they understood and you're adding a new variable, right? But I think what we have to do is we have to look past these types of issues, because we can handle them technically. It's a math problem, right? If we can handle it technically, now we can focus on the mutual benefit of the capabilities of the technologies, and that's where we need to get to.
But what I have in mind, for example, is there's a lot of discussion about you leave your house and your phone switches, quote, seamlessly, I hate that word, from your Wi-Fi in your house, you walk out the door and it's on the cellular network, and then you get in the car or whatever it is. And I've seen countless presentations of that. But as I walk out the door, what and who decides if I connect to a cellular terrestrial network or a satellite network?
The device. So we've kind of come to the conclusion, look, there's been multiple attempts to control this from a central point. And there's even standards work that's still going on to have some sort of central intelligence. Cisco's a big believer in what we call loosely coupled networks. We want to be able to move across different access networks that have different management domains, maybe even different company management domains. And you need to be able to move across those. Fundamentally, what we found is the device will not concede the user experience to another entity telling them which access to use. So the current thinking is that you have to give the device the information it needs to make a good decision.
I mean, I would tend to agree, and I think that one of the things that the Camara people are not doing fast enough is an API for what's called connectivity insights, which is how good is the network in this place and that time, or heuristically predictive.
I'm glad you said that, because we do it at WBA.
It's the device, but it's also, it's the MNOs. They influence it through the technical specs that go to the device OEMs. The AP manufacturers influence it as well, because you don't want your customers to be in an environment like this and keep bouncing in between networks. And the MNOs, they always wanted the network to be really sticky so that they don't have home-on-home roaming. That was the whole intent behind it. And the reality is that the industry has been managing network selection largely based off of signal strength for the last 25 years. It's not based off of quality. So if your fiber gets cut, And your Wi-Fi to your network is still going to look like you've got a perfectly good Wi-Fi network, but we know you don't. You've got no transport layer.
Well, the same thing happens
It
on
won't
cellular, as I found out on the way on the train 2 days ago when
Yes.
Vodafone UK had a huge outage, which took out both, even though I had signal, I think they basically killed their internet gateway. I think basically the ASN disappeared,
They must
which
have known you
was
were
also took out the on-train Wi-Fi as well as a single point of failure. Anyway, I'm going to throw it open to the floor. We've got about 5 minutes left. We've got an array of very interesting people on the stage. Are there any questions out there, or are people sort of at the end of the afternoon and just looking forward to a beer? Go and get a beer and bring it back in. Yeah.
Okay, thank you very much, very insightful. I have a very quick question regarding the joint sensing and communication that we can see very active in ETSI or 6G developments. Is this something that we can consider in other wireless technologies, either IEEE or satellite communication or any other wireless, technically, I mean? It's about localization, anyway.
For sensing, did you say?
It's like a joint, like you use the signal for communication of the data, but you also sense the objects. It's not only sensing the device as what we do usually, it's sensing the object.
Yeah, we're already doing quite a bit of that. On the client side, for example, we can tell if the person is in front of the laptop, not in front of the laptop, did they move? And as I mentioned in a presentation this morning, we're starting to get towards, are they breathing, right? And eventually we're going to get to gesture control, we're going to get all sorts of things as channel bandwidths get larger. It becomes essentially a bigger radar, right, a bigger sensor. And so we'll get to much more fine-grained capabilities in the ability to sense. And then as we talked about earlier, it's what kind of sensing do we need to do in the broader enterprise, right? If I'm moving and I know that I'm moving because I'm the device, and I pass that information to Matt, and Matt knows which direction I'm moving and how fast I'm moving, then we can make sure that, those personal handoffs and those kind of things to make sure all of these devices work well and everybody's experience is great. So yeah, sensing is already here, and it's going to get better and better from my perspective.
Yeah, it's absolutely going to get better. I mean, my mom is 90, and she wears one of those buttons, right? So if you fall, you push the button, but what if she falls and she can't push the button? Right? Sensing solves that.
Yeah, I actually have a personal story in that my mother last year had left her phone on charge by her bedside, and she'd taken off the pendant because it got tangled around her neck. Actually, her solution was to shout at Alexa, which I'd enabled with a drop-in function, and it phoned me in the middle of the night.
Yeah.
But coming back to the question there, this sort of sensing and combined sensing and communications, this is one of those areas where the cellular industry thinks it's ahead. But in fact, it's about 8 years behind. Because Wi-Fi has been doing that for years. And in fact, the people who did it first is actually the fiber industry. I remember going to a thing, I think it was 2018 in Korea, where SKT, or KT, had built a national fiber network, and they'd instrumented it to look at the sort of variations. And they kept finding the sort of strange perturbations in the photonic signals. And they basically realized they created a national seismometer. And when there was an earthquake, the fibers bent a bit on bridges, and they were able to detect it.
Yeah, so I just want to mention, I can't help myself, but I can't tell you how big an AI space this is. When we train AI, it looks for patterns. That's why it's effective. Being able to pick up patterns and recognize the repeating of that pattern to the point where you could actually tell that it's Eric sitting here or me sitting here. I mean, those are the types of accuracies that we're going to get to. So in this particular case, AI is definitely an enabling technology.
It at least allows us to understand, because we're all bags of mostly water, right? It's a Star Trek reference, if anybody gets that one. But we have to pass those radio signals through. And as like you said, if we're already sensing the device in front of us and the access point is behind me, I have to pass through something to get to it. But if only we could tell it, no, I need you to connect to the AP that's over there, not the one behind me. And that's where the AI needs to kind of on the I'll say the controller side of it, the control plane of it, is to kind of adjust to allow that. And that's where sensing really comes into play.
And all the pattern. I mean, submarine cable guys are doing it as well and trying to work out, is that a shark or is it a Russian submarine? Anyway, well, part of that.
Hi, one aspect I'm curious about is privacy. How do you manage that? If you want someone to know where you are today, that's fine. But if you don't, then what do you do? Or you only want people you know to know? And I know the quick answer is anonymization, but that generally falls down quite quickly, especially if someone's got 1 or 2 cues on you, they can figure things out. I mean, Eric, do you want everyone to know you're here at the moment?
Yeah, I think, well, I'd first answer that all the companies sitting up here on stage probably have 100 lawyers that tell us exactly what we can do with the information that we can gather, because we can gather so much information off the devices that we are, and the networks that we're all working on. So we're very, very closely monitored on those kind of things. So the data that I'm sending Matt, extremely anonymized, right? Just abstracted to ensure we're not passing anything that would be able to triangulate back to a person, a specific person. Now, to your point, there is a place along the continuum where, as Matt said, we do want some sort of personalization, but what we want isn't who I am, what my job is, those kind of things. It's where am I going, what am I doing, what devices do I have, and what direction am I going, and what am I likely to do when I get there. So those kind of things I think are going to be kind of natural evolutions, and they build on the security and privacy that we're already using.
It's a very important question to have about the sensing and the privacy of it. And that's one of the topics of the WBA we're working on, is to figure out how do we understand that sensing and how do we understand the privacy of it, because you have to comply with not only GDPR rules, you have California privacy protection, you've got Canadian, you've got Japanese, you've got global privacy things. And so each realm is going to have its own specific things. And that's going to be a huge challenge for all of us to figure out how that's going to play as we start to rely on sensors and to rely on the privacy of those devices.
It's an accuracy thing too. I can remember when GPS used to intentionally be off.
Yes, and it still is today in some districts.
And so what they did is they connected to more satellites so that they could get the accuracy back. And it's the same thing with sensing, because I've often heard people say, well, we can do RF sensing. I can pick up you and you're sort of an object. So that's better than if you're sensing with a video camera, because you can see who it is. But the problem is as we get better at the technology, your heartbeat is as identifying as your thumbprint.
Absolutely, right? And how do you like my watch, right? And how do I send that off to someone?
It's a real concern.
My discussion with people who are struggling with a similar problem in other parts of tech, like the Kamara people for wireless cellular networks, consent management becomes hugely important, and it's non-trivial to do. And with that, though, I would like to ask the consent of the panel to wind this up, and everyone to thank them very much, because I know that we've got I think it's an award ceremony coming up next. Once again, thank you very much to all 4 of the panelists here.
Thank you.
Thanks. Tiago, back over to you.
Yeah, good to see you again. Okay, so hello everyone, and welcome to the 2025 WBA Industry Awards ceremony. So this is a moment to celebrate innovation and as well innovative ideas and how those innovations impact our industry, and in particular the Wi-Fi technology. And I'm super proud of all the candidatures and all the companies that submit on these industry awards.
I want to make a mark that this is the 13th year that we have been celebrating the Industry Awards. And I want to as well recognize the panel of judges that do the heavy lifting to evaluate all the submissions on these awards. I can tell you it's not easy job. It's a very comprehensive effort. I see some of the judges on here on the audience. So big thank you to our panel of judges. I want as well to give a big thank you to our sponsor of the Industry Awards this year, that is Iron Wi-Fi. So Iron Wi-Fi, thank you for supporting this ceremony. And I would like to invite Mark Carter, Business Development Chief Officer for Iron Wi-Fi. Welcome, Mark.
Good evening, everyone. Are we having fun yet? It's a privilege to welcome you all to the WBA Annual Industry Awards. It's a celebration of creativity, collaboration, and connection. Over the past 20 years, the Wi-Fi Broadband Alliance has stood for one clear mission: to bring together the wireless industry and create a global framework for secure, seamless connectivity. I think its objectives are shared by every member in this room tonight. We look to accelerate wireless innovation, bridge the digital divide, and enable global roaming, reminding us, Dr. Peterson, that connectivity is not only a technology, but is a shared commitment to progress. At Iron Wi-Fi, we share that progress and that mission. At Iron Wi-Fi, we focus on one core mission: delivering secure, identity-driven access for modern wireless networks. As organizations of all size move towards open, federated, zero-trust architectures, Iron Wi-Fi provides the essential infrastructure to make that shift both secure and operationally efficient. Our cloud-native platform provides Radius as a Service, captive portal management, IDP, and enterprise integration services, all delivered with simplicity, scalability, and performance at their core. Our focus continues to be centered on identity, authentication, and security as we look to deepen our partnership with the WBA community through participation in the work groups. We are proud to be aligned with the WBA Open Roaming Initiative, enabling secure, automatic, federated roaming access across the globe. Through such initiatives as Open Roaming Release 5, the Wi-Fi 7 trials, and the recent white paper releases on the emergency calling framework, the WBA continues to push the boundaries of what the connected experience can be for operators, enterprises, and individuals alike. Looking forward, the new terms of reference for the WBA's 2026 roadmap is now available. This is an important opportunity for you all to shape the direction of the working groups. So I urge you all to review, vote on, and actively get involved with the projects being considered. Together with the Wireless Broadband Alliance, we continue to build a world where connectivity is seamless, trusted, and universal, enabling opportunity everywhere. Because when connectivity is secure, seamless, and simple, it stops being a barrier and becomes a catalyst for creativity, communication, and connectivity. Tonight's awards remind us that progress happens through partnership, through collaboration, through people willing to experiment, share, and innovate together. The WBA Industry Awards provides a unique opportunity to demonstrate excellence and innovation. So tonight, we honour the people and the organisations who are pushing the boundaries in our industry. These awards celebrate not only achievement, but perseverance, the courage to explore, the persistence to deliver, and the imagination to redefine what is possible. I would, again, as Tiago did, like to thank our independent judges for their hard work and say congratulations to all the nominees and the winners. Thank you for your imagination, your partnership, and your leadership.
Thank you, Mark. And to help me to announce the short list of winners and candidates of the awards, I'd like to invite once more Mark Carter from Iron Wi-Fi and Dr. Derek Patterson, Chairman of WBA, to help me out to deliver all the awards to the winners. So Mark, Derek, please come on stage. Okay, so first category for the industry awards is Best Wi-Fi Network Operator.
디자인 모두 잡은 와이파이 공유기를 찾고 계셨나요? 더 빠르고 더 매력적으로 업그레이드된 KT 와이파이 7D를 소개합니다. 빠른 속도는 기본, 안정적인 인터넷을 사용하고 싶을 때 우리 집 와이파이 공유기를 KT 와이파이 7D로 바꿔보세요. KT 와이파이 7D는 기존 공유기 대비 최대 2배 이상 빠른 속도를 제공합니다.
LGU Plus is a leading telecommunication provider in South Korea, driving innovation in Wi-Fi service. We are the first in the nation to commercialize the Wi-Fi 7, supporting 320 MHz bandwidth and 6 GHz spectrum and multi operation. With speed over 4 times faster than previous generation and advanced QoS management for ultra-low latency, our Wi-Fi 7 technology set a new standard.
Turk Telecom, with over 180 years of history, is Turkey's leading telecommunications operator, connecting millions across all 81 provinces with mobile, internet, and fixed-line services. As of March 2025, we serve 17.4 million fixed lines, 15.4 million broadband, and 27.9 million mobile subscribers. Our 36,054 employees drive Turkey's digital transformation, delivering innovative connectivity.
Winner is KT. Congratulations to KT. Thank you.
Why are you guys all?
Congratulations.
Yeah.
Moving on to the next category, the Best Wi-Fi Network Technology Award, and the short list of companies are
Hi, my name is Dave Sumi, and I am CEO of Airvine. I am here to talk to you about that long-known and prevalent problem that we all suffer from in broadband wireless access or any internet access, the last foot. The problem that we're addressing is when you get that signal, that data, that connections of gigabits to your building, and it's on your roof, it's outside your wall, how do you get that inside? Today, the only way you can do that is drilling.
Cloud-native campus gateways for seamless roaming in the campus.
I think it's no surprise to say something like this, that more and more customers are shifting to cloud ops, right? And moving away from traditional on-premise infrastructure. I think what is new about this statement is that customers are not saying, hey, help me move to cloud in my branch. They're saying, help me to move to cloud now on my campus. How do I do this in my most high demand?
Every day, hundreds of millions of people connect to Wi-Fi networks worldwide, never seeing the critical security infrastructure that protects their data and privacy. InkBridge Networks stands at the intersection of protocol development, open source leadership, and enterprise solutions, securing the foundation of global wireless authentication. InkBridge Networks' technical innovations span from writing the Radius protocol standards that govern authentication to maintaining free Radius, the world's most widely...
And the winner is? Congratulations. So moving to the next category, Best In-Home Wi-Fi Network. And the short list of candidates are
At LGU+, we leverage AI technology to enhance the quality and satisfaction of our customers' internet experience. To accurately predict the quality of wireless environments, we have developed models such as the potential VOC customer prediction model and the service-specific QoE prediction models, which are applied across a range of customer care services. Our customer support system utilizes the VOC cause identification model to determine when and why a service issue occurred.
Internet subscribers expect flawless Wi-Fi on every device, in every room, from day one. That's why Internet service provider Windstream partnered with Route This. Windstream's Kinetic Whole Home Wi-Fi is a premium fiber service focused on high-quality installations powered by Route This Certify. Certify equips field technicians to optimize whole home coverage for the best customer experience. It also gives...
And the winner is? Okay, let's keep on going. Congratulations to LGU Plus team. Next category is Best Enterprise Wi-Fi Network. And the short list of companies are
There's one thing that we all travel with here at the airport. One of these things. Here at Phoenix Sky Harbor Airport, they know what it takes to keep these things connected so that your email works, your boarding pass works, and yes, you can even download your favorite binge-worthy show right before boarding your flight. At Ookla, we know a thing or two about great airport connectivity. Every day, we capture millions of consumer-initiated speed test results, enabling us to
Cisco leads innovation in Wi-Fi 7. The CW9179F large public venue access point brings excellence in radio design, antenna configuration, and patented indoor and outdoor flexibility in an integrated design. Just listen to what a Cisco customer has to say about it.
Wi-Fi 7 will dramatically improve our network connectivity at events, providing high-speed internet access no matter how crowded our spaces are, thanks to the new 6 GHz band and multi-link operation technology. Low latency will also.
Unlike other vendors, Huawei has gone one step further by developing the unique Wi-Fi Shield, MACsec and Wi-Fi CSI sensing technologies on Wi-Fi 7 APs. These innovations help create three-dimensional campus security. Huawei Wi-Fi 7 AP injects interference noise into radio signals that aren't destined for the target star. As a result, only the target star can receive valid data, while other stars, even just centimeters away from the target star, receive.
The winner is...
Congratulations.
Thank you. All right, thanks. Congratulations to Boingo. Next category is the best Wi-Fi for social impact, and the short list of candidates are
Power lights our lives. Tunnel safety keeps them running. Workers enter tunnels to keep life going. But thick walls and complex paths made old networks fall short. Capco has installed robust and efficient Wi-Fi access points throughout its power tunnels, building a fast and stable large-scale communication.
Welcome to Project Access Connect, your all-in-one tool for resident support, connection, and empowerment. From food distributions to health workshops, get quick access to the resources that matter most. Access thousands of free resources right in your neighborhood and beyond. Explore educational videos and resources that help you and your family thrive. Get real-time updates on local events, programs, and opportunities to connect. Need help now? Get quick.
And the winner is... Congratulations to the Korean Electric Power Company. And next category of the WBA Industry Awards for 2025 is Best Wi-Fi Innovation. And the short list of candidates are
The future of industry is wire-free, and a new generation of wirelessly connected assets, AI-driven robots, autonomous vehicles, mega data-producing endpoints, has created new demands on wireless networks. Wi-Fi alone can't keep up. But that's okay, because now Cisco has taken wireless connectivity to a new level of reliability with ultra-reliable wireless backhaul, or URWB.
Hamilton Wireless has always been a leader in wireless design, but now we've taken it one step further. You can take the survey data that you receive as you walk around the building. We can now see how the RF propagates, how it moves around your space, how it interacts with the objects that are in your environment. And what we can do is we can then use that data as like an overlay so that we can see, yes, previously we used walls and objects, but now...
Good afternoon, my name is Mario Didio, I'm the General Manager of Network at Helium, and this is the video submission to support our submission for Helium as the best Wi-Fi innovation for the WBA Awards. So Helium refers to as a decentralized network. What is a decentralized network? It's essentially the ability of creating a Wi-Fi based carrier or flow network which is owned by the many. Usually when you think of centralized network architecture with towers and radios, you think of
the winner is...
I like this song. Congratulations.
And take a look around the room. Love comes wearing disguise.
I think we're good. Howard's going. Yeah, Howard's good. Congratulations, Mario, Joey, and all Helium team. We are almost done, but still 2 awards to come. So next award is Best Wi-Fi Customer Experience, and the candidates are...
Outlet is a global retailer. We have 8,000 stores and 16 brands.
What's very important to me and also to Deleuze is really making that difference in our customers' lives to give offers relevant to him or her based on purchases.
Cisco Spaces was implemented to provide seamless connectivity for the customers. The game changer here is that we know the moment that the customer walks into the store that the customer is there. So we can influence or trigger purchasing behavior.
On the screen, you can see the Gemba Fault Process Management Platform. By clicking the Wi-Fi Mertech Analysis widget on the homepage, you are directed to the related page. This page includes in-home network analysis, AI-detected findings and solution suggestions, daily and weekly wireless performance graphs, and a heat map showing devices connected to the modem. You can view the weekly analysis report of the connected devices on this page. By selecting a device,
and the winner is...
You got it.
There's one for this group, and then one for this. Yes, so congratulations, the LAs and Cisco teams for the award, and we reached to last award of the night. So it's a new category for WBA, so it's the best open roaming deployment, and the candidates are
Hi there, my name is Gordon Poppe, Vice President Information Technology at AIDA Cruises. AIDA is Germany's most recognized tourism brand. With our fleet of 11 vessels, we welcome 1.5 million guests annually to destinations around the globe. AIDA is part of Carnival Corporation, the world's largest cruise company, operating far over 90 ships. From an IT perspective, we provide technology to deliver unforgettable happiness to our guests by providing extraordinary cruise vacations while honoring the integrity of every ocean we sail, place we visit, and life we touch. Onboard connectivity.
Hey everyone, Chase Harrison here, CEO of Alta Labs, and I've got something game-changing to share. Tired of spotty cell coverage ruining your day? Sick of signal boosters that underdeliver or cost an arm and a leg? Well, buckle up. Alta Labs is about ready to blow your mind. Meet Alta Boost, one of the world's first and certainly the easiest to deploy Wi-Fi powered cell coverage solutions. We've taken our industry-leading Alta Labs Wi-Fi access points and supercharged them to deliver seamless Wi-Fi and impressive cell phone coverage all in one. Your guests, your team, your family.
We all need to be connected 24/7, but it's increasingly hard sometimes to get a connection to the mobile networks in central London. That's why we all rely so much on public space and local Wi-Fi systems. But they can be fiddly and difficult to get onto. That's why we're launching Connected London Wi-Fi. So with one single download and connection, you get access to public space Wi-Fi all over London, all over the world.
and the winner is Yeah, congratulations to Wi-Fi and Alta Labs for winning the awards. So, sincere congratulations to all the winners, all the shortlist companies, everyone that submitted into the awards. As you can imagine, many times it's very challenging for the panel of judges to evaluate all the good candidatures that are submitted. So once more, big thank you as well to the judges. I will ask a round of applause for the judges that do a wonderful job on this evaluation. So 2026 WBI Industry Awards will be announced, the opening for candidatures and submissions by March next year. So if you like to participate on the awards, watch out for WBI communication by March. And I would love to have you all making submissions and participating on this celebration. Once more, I would like to thank you all the sponsors of the WBI Wireless Global Congress. I want as well to take a note that after this session we are going to have a networking celebration and somehow socialize informally, more informally between all of us, right on the VIP speakers lounge outside this room. That is sponsored by Cisco and Boyko Wireless. I want as well to thank you, Iron Wi-Fi, for sponsoring the Industry Awards in 2025. Has been glad to have you, Mark, as part of this celebration. And I would like, before we just go, everyone goes away, I would like to invite all the winners of the awards to come on stage for a group photo. And for everyone else, thank you for your time and for staying until the end and watching the industry awards.
Drinks are over there.
Drinks are outside.
Drinks are outside. Don't run away. We stood up here as Vanna, so you got to have a drink.